secure all of the new exhaust fans in the roof because that's weight, right? So we have to be able to make sure it doesn't fall through the roof. And so that's all the exhaust fan secure bracing that we have to account for. C301, let's look at that real quick. C301. C. Okay, so yeah, 10-inch, 12 gauge on each side of that. Okay, so we can go back to that. You see, basically that's going on each side and you have to connect it. Okay, and then D, you connect it like this. Okay, so you got to be able to make sure you know how to get from what they're trying to tell you to the next thing and get it on your estimate. And make sure you get it all together. Something around here. Fan supports, 240 feet. And then the Samsentai L70. So much fun. But yeah, structural is no joke. Okay, that and electrical probably, and excavation, especially if you have bad plans, it can be three of your most difficult of estimates to put together. Okay, so this is the basics of structural estimating, right? Just your structural set, and only the concrete in the S plans. If you have concrete in the C plans, civil set, it's not on here. You don't put that on here. Everything is separated just this way because it's all its own thing, right? So, even if there is interior building concrete, it won't be on here and it won't be on the civil set. It'll be on the estimate associated with the architectural set. Okay, so we'll come up with a video in detail to show you like how you separate estimates, because a lot of people just throw everything on there, and those are the estimates that get thrown away, right? Because it shows that the person doing it, they don't know what should be on their estimate. So unless somebody specifically says, like for the electrician, put the trenching on that, well, that's different because electrician's job is to be an electrician. And the structural set it's understood that these things are on it, so all of these will be on a structural estimate. Concrete, the foundation, any of the structural components, all of the beams and columns and stuff. It's understood those will be all on the same estimate. Okay, so if you have any questions, please let me know, and please give me your comments, and thank you for your very nice comments and your likes and all that good stuff. Please continue to like. Let me know if there's something in particular you need help in and you want to know, because there's very few things about this mess that I don't know and I like to share. So thanks a lot. Email me at education@sfjohnsonconsulting.com. I hope you had a wonderful Thanksgiving and look for the next video. Talk to you soon. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and I hope you had a wonderful Thanksgiving. It is Sunday the 27th, and it's basically Christmas, right? But yeah, so today we're going to talk about framing and the basics of framing. And we are also, I don't know if you've had an opportunity to listen to a previous video where I will be offering you our certification for all of our subscribers. We have the Basics of Plan Reading certification, which is actually 10 videos you have to watch, plus all of the views videos in order to take the test, which we'll send you, are actually quizzes, which we'll send you, and then the final. And if you pass, we will mail you or email you our certification saying you qualify now, based on, you being able to pass the test. And my tests are not easy. And so what we're going to be offering now, and look for it in the lineup, is the basics of what we're doing now, where, say for instance, you want the basics of structural estimating. there are certain portions that are in a structural set, and so we will be going over all of those points in detail with an accompanying quiz. And you take the quiz, you pass. There'll be about 4 or so per subject matter. But you do have to be a subscriber, and you do have to sign up at our website, sfjohnsonconsulting.com. But those are coming in, just look for those soon. So now we're just going to do a quick overview of the basics of framing. And we're talking about the architectural set framing, not structural framing. And what we're looking at here is an existing facility that had a renovation to some, existing stuff. So when we have the existing building, but we're also going to build some new partitions within it, which is what this is. We pan in and we see the call out. So basically this is the existing. And when we have existing, you need to take good attention to the demolition plan, if there is one, because in the demo plan it'll tell you to do and then prep for new paint. If it says that in the demo plan, then you can exclude it and then add it in the architectural set framing plan, because basically you'll have to prep walls and finish the drywall. Okay, so it really depends on how you want to break it down. With this one that we did, we put the prep of all new walls, because it was prep new walls, prep floors, prep for everything we demoed. So we put that all in the demo estimate. So it's really up to you how you want to do it. Okay, so what we have outlined here is all the existing walls, and then we have another existing walls and existing, and see they kind of show you what's existing, which is in gray. So these are all walls that are there. We knocked out a few, and then they're building. I don't know if this was existing, but if it is, it's gray, so we're just going to add it too, because these are walls that we need to prep if they're existing. And then all this would be new, but not the exterior wall, right? This exterior wall. So basically, they just build new partitions where we'll go to A over A401 to look at all the new walls. And so when we talk about framing, we need to know what kind of new walls we're framing, right? They'll name them, they'll tell us P5, P4, P4A, P3, P3A, P2, P2A, all the way down. So we see the A portion is a 6, and we're all doing metal, right? Because if they were wood, it'd be 2 by 2 times 4, 2 times 6. Excuse me, that's my Thanksgiving cold my grandkids gave me. And so let's see, here's all our new walls. Okay, so you just need to keep in mind the height. Okay, so when you're doing your framing, you need to look at a section view to try to determine the height of your walls. You use your plan. We use this to determine the length, but we don't know the height of the wall. And so we have to be able to look at a section view somewhere to tell us the height of the wall, because we need that when we're talking about framing. But a lot of the typical height of a wall excuse me, would be 10 feet, but where else you get the height of the wall is the reflective ceiling plan. It should, yeah, it gives you, it doesn't give you the height of the wall, it gives you the height of the ceiling. Okay, so let me take that off. So in your reflective ceiling plan, which is something also the framer needs to look at, because you may have some soffits or some, let's take all that off. You may have some soffits or some ceiling drywall you need to install. Okay, and so this is what this is. Okay, so I'm jumping ahead. So the floor plan is going to give it the existing walls. You can go through openings or don't go through openings and go through your door and window schedule and determine this area so you can deduct it from your framing, or just go through all of them, all of the openings, which we didn't do here, and consider it waste. It's really up to you. Okay, so here we got all of our existing walls. Then we had a few new P4, P2A, P5. Okay, so that's P5 and it's 10 foot high, so that was easy. And P4 on this. P4. Did it light up? Oh, over here. P4 in our equipment platform. P2A. Okay, so we had a few new walls on this, but our main one is our main walls are at the call out. Okay, so we'll go to the call out, and here are all of our P1, and we go through all the openings. Unless they're larger, wider than 16 feet, we just go through them. P1, P1A, P1. There's lots of P1s. Okay, so that was that call out from the floor plan, right? Okay, so now we've added existing, and then the call out from the floor plan. Not a lot of new walls. Okay, framing, architectural set framing, and the enlarged office. Okay, now be mindful too that the framer also has to look at the reflective ceiling plan. Oh, let's take a look at the section views too, because you want to kind of determine the height of your walls. So it's like, if I didn't know, okay, I know I have at least a 10-foot height on the basic wall, and this is at our exterior. Okay, so let's go back to framer needs to make sure they go to the reflective ceiling plan and see if we have any ceiling framing that needs, or ceiling drywall, which is the case. And these two have section views, right? Because these are soffits, which are walls that come down from the ceiling. So what do we need? We need to know how far down and how they're built, right? So we have 4/A1111 to give us that section view, and I believe that's here. And here we go, 3 and 4. Okay, so we have the flat area that we see on the plan, and then we know that we have an additional little wall segment extending up 6 inches above the ceiling for that. And then this other one is, here's our flat area shown on the plan, and then we have basically 2. And it's like, well, where does that continue up to? We're going to assume it's going to go to the roof joist or braced, to the roof joist. So, we have to see, okay, roof joist is where? This about 10 feet. So roof joist probably 16 feet. So this is probably going to be 6 feet high. Okay, so that's why you need those section views, okay, in order to determine. Okay, so that's our second component that on the framer's agenda. And then the framer needs to look at all of the door frames. Okay, so typically the framer is going to install all of the hollow metal. Here are the frames. We have some existing, and we have some hollow metal. Typical size on commercial is 3x7, but 6x7, then that's a double door. And storefronts are usually, you'll see manufacturer, whatever, storefronts, or in our case, it's all overhead doors. that are, and they come with their own frames and all that stuff, so you don't really have to be concerned, but you may want to either exclude it or give them a cost to install it, one of the two. The frame, but the installer of the overhead door manufacturer most likely does all of that. Okay, so framing, A plan framing, the floor plans, all the new walls, ceiling reflective ceiling plan, all of the new ceiling and soffits, all of the new door frames. We don't really worry about window frames because those usually come with the windows. But as the framer, yeah, we're going to make sure the opening is there. That's the rough carpentry kind of thing, not so much us that we worry about in terms of framing. Okay, so, and that's pretty much it. Okay, for the framer. So now we're going to look at the estimate. And yeah, now, no, let's go back and look at the partitions. I'm going too far. Here we go. Alright, so all the new walls, insulation on some, drywall just on one side, top track, short wall, whatever. Drywall on one side, and then some acoustical sealant, top and bottom on one side. Same thing here. Drywall on one side, no acoustical sealant, but at the bottom. And here we have drywall on both sides. Batt insulation and acoustical sealant, top and bottom. And so what do we do as far as totals? The framing is the length times the height. The insulation is length times the height. Drywall in this case is 2 times the length times the height, right? Because we have drywall on both sides. And the ceiling is 4 times the length of whatever this length of this wall. Okay, so those are just things you have to. Some walls are attached to the bottom of the roof deck. Some are not, and then braced. Okay, so the main concern is what's the height of the roof? Because these walls will probably go up 10 feet, 12 feet. So you need a good section view. What's my height? So I'll know what the height of the bracing is, 6 feet, 8 feet. Okay, and so then we get to our estimate, and all of those partitions, we break it down. The framing, the bracing, the drywall on one side or on 2 sides, one on each side, so we say that times 2. And then the level 5 finish and the sealant and every different type of wall. And I give them a section view if it applies or whatever. Okay. Dun, 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 dun. Very complicated, but as an estimator, you're supposed to look at your picture, and everything in your picture should be boom, boom, boom. Now, this from your measurements, cost book, whatever your base rate for a framer, right? And our totals cost book based on what I'm doing. Okay, and all the way down. Okay, so any questions on this framing? And remember, sign up for that so you can get your certification through me. And you already know you're going to be the best at everything you do. You don't name a company after yourself and end up lousy. Okay, don't ever do that. So if you have any questions at all, please email me at education@sfjohnsonconsulting.com. Please sign up. Please give me your thoughts. Please like. Please tell your friends. And I will see you at the next video. Thanks a lot. Hello everyone, this is Stacy with SF Johnson Consulting and Construction Services with another lovely episode of the basics of, and now we're going to talk about HVAC or the mechanical set, but mainly when we talk about mechanical in the construction set, we're talking about, well, mechanical really is the HVAC and plumbing processes. But in the construction set, we are focusing on the HVAC. So all of the equipment that either moves, heats, or cools the air. So we're talking about fans and air, rooftop units, air handlers, exhaust fans, that kind of thing. And so when we look at the mechanical set, it's always going to give you a list of all of your equipment. So even if it's the same equipment, same specifications, they're going to list it all in your equipment schedule. So you don't have to guess or go to the plan to count how many of whatever. It's always going to be here. But in terms of the grills, yeah, it'll give you just one type of grill, but yeah, you'll have to count the grills on the plan. But the equipment itself, everything will be listed in the schedule. And what I always do is whatever's listed in the schedule, we would just rewrite it because we need the cost of the equipment and the cost to install it. Okay, and so when we talk about the basics of HVAC, we have our equipment. Now we have to, let's take that off. Let's take that off. Okay. So when we have our HVAC equipment, what do we have? We have either spiral ductwork, that's signified by this in the radius of the ductwork, 6 inches, or we have rectangular ductwork, which is signified by this, something by something. So this is an 8 by 8 inch, and it's always inches, rectangular ductwork. Here we have angles, so we have 90-degree angles. Sometimes we'll have, I call this a 45, that's the price I give it for, 45-degree angle. Those little thingies right there, anytime it's not straight, because there's a cost for the ductwork for the straight measures, and then any of the 45 or 90-degree angles. And so when you are completing your HVAC takeoff, that's just how you have to do everything. So by all of the different sizes, and depending on the set of plans, you might have to guess, right? Because there's nothing here, but I'm assuming this and this is the same size. That's why they didn't write it twice, because it is definitely bigger than this one, right? So we say that this stretch is 16 by 14. Then we have a 16 by 14 90-degree. Okay, and so that's all you do when you're talking about the HVAC plan. All of the stretches, linear, you know, how many linear feet, 10 by 8. And this is a 10 by 8 90-degree angle. Okay, and then we have right here is a 16 by 18 return grill, and with the duct up to the second floor. Okay, so what would we do here? We'd have a 16 by 18 90-degree angle. This is what I do, because we have to go up, right? Your ductwork is rigid, so you have to have straight pieces and then connected to 90-degree pieces, and it's not flexible. The only portion of flexible ductwork you can allow to use it are at the grills, and this is a symbol for a flexible ductwork, and it's usually no more than like 5 feet, max 3 to 5 feet. So that's what that means. And so we have an 8-inch spiral ductwork connected to a flexible ductwork that's connected to the grill. So the flexible ductwork connected to the grill is flexible. It is not rigid. It moves. So you don't have to worry about like a 90-degree angle for it to go down. You got to use your imagination. That all of the HVAC equipment is up where you can't see it, just like in your regular house. You can't see it. It's all on the other side of the drywall. And in a commercial establishment, it's all on the other side of the acoustical ceiling tile. Only thing we see, what are the grills, So all of this is behind all of that, running here, but then at some point at the grill, it comes down to the grill and the air blows out. Okay, so if you don't see a flexible duct work symbol, like we don't see one here, then I'm going to assume it's a 10 by 8 and then a 10 by 8 90-degree angle going down to the return grill R1. Okay, so you have to keep that in mind. So when you're doing the takeoff for an HVAC, you have your equipment given to you on the equipment schedule. You don't have to ever worry about that. But then you go into all of the ductwork. You measure the spiral ductwork as opposed to the rectangular ductwork, and then excuse me, and then your 90 degrees and 45-degree angles, then all of your grills, return grills, supply grills are always next to the equipment. And all of your 90 degrees. And then all of your supply grills usually come with the damper, and so that's what is the symbol for damper. So you want to choose from your cost book this type, whatever S2 is. That'll give us the size, whatever, and the neck size and the size of the grill from the schedule. Okay, and then you have to make allowances for these adapters where we go from 12 by 10 to a 8 by 10. You can add 10%. You can look in the cost book and find that adapter that changes from this to that. Okay, all of those things need to be taken into account, even though you don't really see it on the plan. You need to think about it when you do that. So again, if you're not given flexible, then you need to account for the distance down, which is a 90-degree angle of 6-inch rectangular 90 going down to the grill. If you're using flexible, you don't have to worry about it because flexible will go down. There's no 90 required. Okay, and one last thing is usually the ductwork has a lining and 1-inch insulation lining. So you have to account for that because a lot of the cost books just give you the cost per linear foot for the ductwork, but not the lining. Okay, so if you look at an estimate, we get all of the, and I usually don't put it in any particular order, just as long as I have it on there. So an 8-inch round, and then we had a 90 cost per linear foot, and then the cost each for the 90s and the 45s. So all of the ductwork and the 90s associated with it, then all of the equipment costs. And remember, all this you're going to get from the cost book. You're not going to guess. A good cost book's going to tell you the man-hour unit, how long does it take, cost unit per linear foot to install 1 linear foot of this. So you're never guessing. Okay, and then again, go all the way down, got your equipment, and then we'll have our grills, return room grills, supply grills, all of that stuff. Then the ductwork lining for what applies, and then of course the specialty trades have the permit, so you want to include that and always include some extra spaces for stuff, lifts, and really we could add another cost for testing the system in man hours if you want to add that additional cost. But yeah, that's pretty much it. So again, to recap, when we look at our plan, mechanical set, cover sheet, right? It's going to tell us all of our equipment. So we don't have to worry about counting from the plan. We can just note it, go right from here to our estimate. And depending on, there'll be a different cost based on the cubic feet of air, exhaust fans per minute. If you do this for a living, you know what the cost of this stuff should be. But the cost book's going to help you with the man hour totals, how long it's going to take you. So each one of these is a different size, exhaust fan because it's giving out a different amount of air, so it's probably a different size, so it's a different amount of man hours to install it. So that's why you want to use a good cost book. I mean, everything's not going to take 30 minutes and everything's not going to take an hour. But based on construction standards, that's why we use the cost book. So especially in competitive bidding, if you're going to be close, then you need to use a cost book. That's just it. Like a baby has to wear a diaper. You need to use the cost book. I don't know how that equates, but it's just something you just need to do a good job. All right, so that's all your equipment. Then you go to your plans and have a good linear tool to do your measurements, where you need your linears, your changes from one size to the other. Good cost book's going to tell you what that is, and everything in the cost book's going to be based on, it's just going to be crazy. All the possible sizes of rectangular ductwork is going to be there, and you'll be able to get the price and the man-hour totals. So all your linears, all your elbows, if it doesn't look like it's flexible, and you know these are going down like an angle down into the ceiling, you need to have a 12 by 1290, two of them, to go down. And then really, if you want to get in real detail, is you want for your equipment, there are the cost to connect that equipment, all the rings that are associated with the equipment and all that stuff. But again, if you do this for a living, you know what I'm talking about. So all your linears, all your 90s, all your return grills, supply grills, flexible ductwork, and then all the lining that's associated with it, and then you come out with a nice, professional, pretty estimate before overhead and profit, and then you have to figure out what that is. And I said I was going to have a class on what's included in overhead and what's actually included in a profit. You know, there are certain things you need to think about before coming up with it, just 10%, 15%. But if you have any questions related to this, want to take a class, please let me know. Give me your thoughts, give me a like, subscribe, and make sure to join in the next class. Talk to you soon. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and I'm going to be presenting in this video the basics of the finishes. So we're going to go over various finishes and what plans you need to look at and what you need to consider when that is your trade. So the finishes are everything that goes in and on the building once the building's been constructed, from paint to flooring to even the roof finish. And so it's important, if you are doing, if your scope of work is paint or brick or, you know, any kind of wall covering or wall finish, that you do have a good set of elevation views. And the elevation view is the view as if you're standing in front of it live, and like we're outside and we're on this is the exterior elevation. So it's as if we're outside this building looking at it. And it's going to give you, of course, a finish schedule of ABC, and this is through Z, of the different finishes. And so to make your life real easy, if you are the painter, you're going to look for new paint. And then, okay, that lets me know I have to determine the square footage of everything that's B, C, D, where else? We're going to paint the doors. We can do that separate. And then we have to remove some mold, okay? And so basically, everything is marked. And so use a good digitized software, and then you can get your measurements very accurate, which is important for competitive bidding, right? You have to make sure that all of your numbers are, to be competitive, a good start is to have very accurate takeoff numbers, meaning your measurements. And so you want to always have a good digitized software that you can use to determine areas or linears or segments, portions of lines, or whatever. Okay, and two, sometimes you have sets of plans that aren't clear. Like if you notice here, this gray area, I don't have anything colored in, which means, this tells me either there's a mistake on the plans and I've let the GC know a while back, or there's nothing that we need to do to this gray area. You see that everything is either noted, and or I know, this is a new garage door, so I know that's going to be painted because it's set on the door schedule. But as far as this area, this is noted, right? But that's just the roof. L is just the roof, and there's nothing to be done to the roof, so that's why that's not colored. But it's important when you have a set of plans, if you are the painter and you get something like this, and you either exclude this area or give them a call and say, hey, am I supposed to paint the south elevation any particular color because it's not marked, as opposed to this being marked, those are marked, everything is marked except for this gray area. So we assume there's nothing to be done to that because this is an existing building that's really just having an addition added on. So that makes sense that we wouldn't be doing anything to this. But then we're painting the downspouts and all of the gutters. Okay, so make sure you just don't assume when you get a set of plans. Never add more than what you see, and ask questions. Okay, so that's the exterior elevation. So finishes is important to get elevation views, especially like if you're the painter. That's the only way to get a good visual, so you can get good measurements. And then we want to also look at the finish schedule, so we know each of the rooms. In the event we don't have good elevations, at least we know, okay, well, we're going to have carpet, I believe, on the floor, rubber wall base, paint one, everything. All 4 walls in all of the rooms appear to be painted the same color, paint one. And then all of the ceilings appear to be acoustical ceiling tile. That's a finish. Paint's a finish. All of these are finishes. That's why it's called the finish schedule. All right. And so we pretty much know what everything is going to be. A lot of things aren't going to be done. The shop area, there's nothing. Sealed concrete on the floor. No wall base. So you get a good idea. And then they're finished plans. So from the finished plans, right, you get the plan view, which is a view from above. So now you can do all of your wall bases and all of your floors, the different floors. You can get some good measurements. And then the last thing to do is to have your interior elevations for the inside. So now you can get your wall measurements very accurately, and there's no questioning for whether it's tile or paint excuse me, or the trim. All right, and you can had to put it on hold real quick, hopefully it doesn't show. My grandkids gave me a cough over Thanksgiving, and it's just been crazy. Okay, so interior elevations give you a good idea of all of your areas. Can be very accurate. Set your scale and then begin to make your measurements depending on what you got. And then here we know this is glass, so we're not painting the glass, so we didn't include that. Okay, so interior elevations, exterior elevations for all your wall finishes is vital, so you can get good measurements. And two, from your floor plan, actually, let's go to, also reflective ceiling. If you're doing the acoustical ceiling tile, gotta look at that too. Let's take all the bubbles. Okay, so ceiling, am I the ACT person? I have 2x2 acoustical ceiling tile. Just get the area, and then the IT room is JIP. Alright, so we have to paint that, so we always have to look at the reflective ceiling. Okay, in order to see what ceiling components we need to measure. And last but not least, we go to the interior elevations. I can never find them on. in the row. Equipment, elevations, exterior elevations, and then the interior elevations again. Go to those, get all your interior measurements, and then really you want to go to your door schedule if you have to paint the doors and the frames. Okay, so finishes, right? I mean, it's just for finishes, paint. So really, any wall paint, wall finishes, elevation views, reflective ceiling plan. Got to come to your door schedule to see if it's stained or painted for the door or nothing. Okay, interior elevations inside. Your finish schedules tell you the finishes on in each of the rooms, on each of the surfaces. Then you go to your plans to do your plan view measurements, wall bases, floor tiles. And then you have to go to your interior to get the walls, right? Because this is an interior elevation marker. So this says that page IN 401, image 14 is going to show you everything on that wall, and that's how we make, those are where the interior elevation views come from, using the interior elevation markers. So you know on each wall, depending on where the arrow's pointed, what's going on each one of those walls, and then you could take those measurements. So you know if each room pretty much has a interior elevation marker, your interior elevations are covered, except for see that this room doesn't have one. So we just go to the reflective ceiling plan or the finish plan for the IT room. See if it even has anything on it. Paint, okay. So what we need to determine then, what's the height of the wall in the IT room, because we don't have an interior elevation. So how we do that is we go to the reflective ceiling plan, because the job of the reflective ceiling plan is to tell us the height of the ceiling, which basically is the wall, right? And the finish on the ceiling. Here, this symbol, this format, pretty much this design indicates drywall. Okay, so even though we didn't have an interior elevation marker on that finish plan, you go to the reflective ceiling plan, and that is the height of the ceiling. So if you have to paint it, you figure you're going to paint to the ceiling, and give it a couple inches if you want. Okay, so, and then our other finish really is our roof and what we need to look at, and this is our new roof. So what the roof is going to give you the flat area, of course, and if you have a good measuring tool, your scope of your roof can be taken into account, because the steeper the slope, right, the more material is going to be to cover that slope. And then of course you have to look at all of your section views to see where that's going to lead us, or does that show us something in terms of our roof finish. And we know that these are all of our downspouts as part of the roof. So the painter and the roofer needs information about the downspouts, but the roofer doesn't paint the downspouts. Right, so the roofer needs to look at all of these. So 2 over A102. A102, where are we? Oh wait, we're already here. 2. Okay, so for the roofer, they need to say, okay, this is my scope of work. Anything else I need to know? This is a type of roof. And then this 2, this doesn't, that's the existing roof. So that's here at this connection. So that's nothing I need to know about. And then this one, 6 over A302. Let's just look at that because it is off the roof. A3026. Yes, we need to know now. This is our roof. We need to look at both of these because it is a detailed call out that encompasses our roof. So that may tell us we have a scope of work within these call outs. So 13A501, this is 501, I think, right? No. So 13 and 14, 501. 13, and 14. 13, where is it? See, I already worked on it. So for my roofer, no, nothing more than a roof because this is the fascia. That's not the roofer. That's not the roofer. That's not the roofer. That's not the roofer. 13, 14. Metal channel. Yes, the roofer. Yeah. Or, well, if it's like flashing, yeah. Or it's structural. I have to see. No, that's structural. I think I did that for the structural. So, roofer, no. Okay, so you have to make sure you follow your call outs, whether you know it's for you or not. But if it encompasses your scope of work, you got to follow it. All right, so finishes. Now let's look at an actual estimate. So new finishes, this is all the floor. Tile, square feet, cost book, and most crucial is the man-hour unit, cost unit, out of the cost book because it tells you the accurate amount of man-hours it takes for each line item. Okay, so you have to make sure you get a good material cost, okay? But the things that will probably, either help you win or not is how accurate are you when you say how long it takes you to do each scope of work. Tile work is very time consuming, very expensive too. But how are you determining how much time it takes? That's all you need to ask yourself. Are you doing it by guesswork? Are you using some kind of standard based on construction? Right? That's the difference between a winning bid and one that's just thrown in the trash, I'm telling you. All right, so paint, how we have it here, and I'm going to come through with a separate painting estimate, but this is a subcontractor price. So this incorporates material and labor per square foot. But I'll come through and do a small video again for a painting estimate that breaks down each of the tile, walls, ceilings, railing, concrete, and then I think I did it before. That's probably already on there. And then how we determine how many 5-gallon or gallon buckets of paint we use, and I think I already have that on there actually. But this is a subcontractor price, and then miscellaneous stuff. This is miscellaneous finishes, the coffee bar, and they had a bunch of extra stuff I just added for them, the bathroom accessories. Okay, so that's what it looks like if you want to be a winner. And then, you can play with your labor rate based on your city and state and, all that good stuff. But, if you have any questions related to this, the basics of finishes, we kind of threw all the finishes there all together. Email me at education@sfjohnsonconsulting.com. Let me know what you think, and I will see you at the next video. And if you haven't subscribed, why not? Come on, please do. Tell your friends, and I will talk to you very, very soon. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and I just wanted to get you a little more information on some of the estimating costs and how they're broken down and how you should be thinking about those when you are completing a full estimate. And so when we talk about the estimating cost, it is basically our direct cost versus the indirect cost and what those are. So the direct costs, really anything associated with that's going to be a permanent part of the building is part of the direct cost. So And it's also known as the field cost. So everything from the man-hour labor that's required to build the building, the equipment cost, all the material costs themselves, and any subcontracted items that you would need in order to complete the building. Okay, so those are all of the direct costs. All of the costs that you would find on your detailed estimate pretty much are all of the direct cost as opposed to indirect cost. And for construction, those would be the ones that we would list under the general conditions portion of the project. And so that would be anything related to the office, vehicles, any of the fringe benefits, insurance, bonding, overhead, and any supervision cost. So those are things that are part of your overhead costs. You know, when you consider your overhead, all of these really are part of your overhead cost for a project. And so just know what the differences are, and basically the difference is the direct costs are anything that you use in the production of the project that becomes a permanent part. So the labor that's used to build the concrete foundation, that's part of the direct cost. The concrete foundation itself, everything in terms of that. Subcontracted anything. If you have to take photographs of whatever, that's all part of that too. Okay, and then again, indirect cost, the office, so your field office, the vehicles, the fringe benefits you have to provide. You know, that's part of your labor costs. Part of the fringe benefit part is your indirect cost as part of your labor. So insurance, all of that. So keep that in mind when you are producing your estimate. And the thing about a good estimator, they have to be able to consider all of these things and how they are applied within the estimate and how to apply each portion of these costs to the final estimate. So just think in terms of direct cost, anything that becomes part of the building and the labor needed to build that or make that happen, and then everything else pretty much is going to be your indirect cost. So join me at any time to take any one of our classes. We'd love to teach you live online. If you have any questions, please email me at education@sfjohnsonconsulting.com, and I will see you next time. Make sure you subscribe and give me a like if you so choose. I will talk to you soon. Hey everyone, this is Stacy again with SF Johnson Consulting and Construction Services. Just want to give you a little information on for our Estimators Corner, the idea of conceptual estimates. We're going to talk about all of the different types of estimates. We have conceptual estimates, detailed estimates, square foot estimates, all kinds. And we are going to discuss the attributes of each kind and when you use each, and when you don't, and what you need and why. Okay, so conceptual estimates. Well, conceptual estimates are ones that we use when we don't have a detailed estimate, where we're kind of it's for pre-construction, and really we use conceptual estimates to tell the owner or let the owner decide if they want to do the project, if they have enough money, if they have the money to complete the project. And so a couple of things are true about conceptual estimates. I mean, they're the easiest to do because if you have a good cost book, you'll at least know the square feet maybe of how many square feet, how many floors. I had to do one for a apartment building with 4 units, right, 2-story, and wanted to get an idea of the cost of that. Well, for me, because I've done so many of them, it's easy to get the specifications on something like that from all of the many other estimates that I've done. But 2, I mean, if you kind of know, I mean, they know the building envelope size at least, because they probably already have the land and want to develop it. And so they probably already have the building envelope. So they probably already know they want it's like 4,500, 7,500 square feet. And then they want 4 units within that 2-story. That's pretty easy to kind of figure out, if you've had some experience with that, and especially if you have a cost book. Cost book will give you, and that's the key. I always say cost book because you need good tools to do a good job. First tool is a good digitized software. Second is a really good cost book that's current, that you can adjust, because we do work in all 50 states. We can adjust it based on the location of the project. And 3, having a good way to present the information, like our Excel spreadsheets that we've designed for each trade with everything you need on it. So when a GC or project manager is looking at your work, they know you know what you're doing and everything is shown there, and they won't throw your stuff in the trash can. And that's what we don't want after you spend hours putting it together. But for a conceptual estimate, you don't have to do that, because nothing is given to you. You don't have a set of plans, or if you do, they're very limited. They'll give you a set of plans with no anything in it. They'll show you how many rooms, and that's really okay, because a good cost book will show you. You can then begin to use assembly prices, which is one price per square foot for a exterior wall, or for a floor assembly or roof assembly or something like that. It's not very difficult. So yeah, you use it as an initial thing. If it's not detailed, so you really have to have good tools in order to, or historical data from ones you've already done before, or something like that. Like if you've done 10 other kind of apartment complexes, you can go and figure out the price per square foot. It's not really difficult. So you would give them an estimate, and that would be the preliminary estimate. And then you would continue to adjust it as you got more details, because again, if they decided from your conceptual estimate that they want, like, I have the 2 million or whatever, then they'll go and get a very detailed estimate, and then you'll start to build from that. That's why you really got to know your stuff, right? And know that the design is not complete. Nothing's complete. So you really want to add, I always recommend adding at least 25% to a conceptual estimate, because nothing's, you don't know anything. There's no details. We don't know even what size, the actual size of the roof trusses should be. We can guess, and that's all conceptual estimates are, is really good educated guesses. All right, so that is one of the many types of estimates that we will discuss. The next will be the detailed estimate. If you have any questions on this or anything else, make sure you email me at education@sfjohnsonconsulting.com. Give me your thoughts. Make sure to join the Estimators Corner in 2023 so you can learn something new every week. And I will see you next time. Hello everyone, this is Stacy with SF Johnson Consulting and Construction Services, and today I just want to give some detail on an HVAC project and how we should be doing the very detailed takeoff in order to, and I see a mistake right there, in order to make sure you have everything included in it. And so let's start from the beginning. And so with HVAC we have either rectangular ductwork, or we have spiral ductwork, which is represented like this. So the first thing we're always going to do is just measure the lengths of each of the different kind. And so in this project we had an 8-inch, we had 6-inch, and a 4-inch. And so we just made those measurements based on that. And then I always start in one area and just work my way all the way around until I get to the end. And then it's easy to tell if you've missed something. So the next step would be, after I do the spiral lengths, I'll do the rectangular lengths, or whichever one you want to do first, but just to knock that out. And so of course you're going to have a lot more of the rectangular ductwork, so you just have to name it what it is and follow the lengths and measure however long it is. Okay, so that is step 2. Step 3 or 4, however you want to do it from this part, this end, but then I'll go with all of the 45s and the 90s. So this is a 20 by 10 90 with veins, they call that. And so we counted all of that. So whatever had a 90, so this is a 14 by 14 90. And this is a 10 by 12 90, and all of the others. Okay, so that would be another step. Then we'll go to, I don't know what I did in order, but just don't miss it. So do the 90s. Now things like this, we look at the notes, and it is the supply and return grills, diagonal, supply grill, X, they go up to the rooftop unit. And so for this, I'll always have a 90 because it's going to have to turn up or down or whatever. So I'll just assume we have a 90 plus 6 to 10 feet of whatever size ductwork that is. And so for this, it's kind of like, okay, is it the 14 by 14 or 14 by 10? But I think we use the 14 by 10. I don't know. I'm not sure. But the rooftop unit itself is going to tell you the size of the ductwork. So if you don't have it here on the plans, you should be able to look at the mechanical equipment schedule or something on a takeoff or a section view or something like that. And it should be able to tell us the size of the supply and return. It should be somewhere probably on a section view. And if not, then you put what you need to put. Tell the contractor what size you chose and go from there. And so it's the same thing as here. Okay, so we're going to go with, and you see how it's a 14 by 14, 14 by 12 here. So make sure you don't make a mistake. Now, all the other little things that you should take into account when you're doing an HVAC estimate, like these things. Okay, so this is, and now we look at this and we see that there is a portion of some ductwork, plus this is a representation of the spiral flexible ductwork. So you don't have to worry about a 90 for that because it's flexible, so it automatically turns and you can attach it to your supply grill. But these are the branch components we need to account for in the material quantities, where this would be something like a cost book would say a 14 by 14 with a whatever size branch. And that's what this would be, and we'd have an additional cost for that, just like we'd have an additional cost for the 90. So it's the lengths, the 90s, these little things, and transitions, where we go from one size ductwork to another, where we have something like that. Let's see. Right here, and it's dotted. So here we went from a 14 by 14 to a 10 by 12, so we want to account for material cost for that reducer and whatever your cost book calls it. And we got to fix that. We're missing one right there. But I wanted to make sure I gave you a video of this in detail, not only for the client, but for you to know this is how detailed you need to do an HVAC takeoff for material quantities. Now we're not finished. So we have the spiral ductwork, and the spiral ductwork comes in the size of, it comes in different sizes. So 6, 8, 10, 12, 14, 16. So you have to account for, is it an 8? Is it an 8? Is it a 4? Is it a 10? Is it a 16? So make sure you note for the size of the flexible ductwork. And here, like something like this, it wasn't noted. It's a mistake on the plans. And so we just assume it's just like this one, that it's an 8-inch. And we'll give it 3 feet per dot because specs, you can't use more than 3 feet. So we're going to give it a 3 feet length. That's why we only counted it. We only made dots because each dot is going to be times 3 feet that size. And what else? So for the take, and then the grills, of course. And so they had different, in this one, and you'll find it's true in a lot of them where they'll be the same size grill, but the neck size is different, and that's how you price it, really, is on the size of the neck. So this neck size could be 8, 6, 4, like this one, Like this one has a neck size of 8, I'm assuming, right? Because it's going to be the size of the ductwork. So we made it that size. That's an 8-inch. And like these right here, this would be a 6-inch, CD1 6-inch, CD1 8-inch. So that refers to the neck size or the size that the ductwork is going to connect to. And as far as the detail takeoff, I think that's it. So again, to recap all of your lengths, and you see that you have 2 different types of ductwork, spiral and rectangular. So all the lengths, all the 90s, all the branches, all of the spiral ductwork, all the transitions. Where is that? Where is it at? All the transitions and all the grills. And then we have a couple of things that's not completely finished. What is that? A 4-inch flex. That's a 4-inch flex. And then we have to fix one more. That right there. Okay, and so if you look over here, it's everything that we counted, added, all the links, and now we'll take this and get the cost book for our cost per linear foot of cost each, and add the equipment. Right? You never have to worry about counting equipment because you're always going to have the equipment schedule, and it will tell you if it doesn't say existing, it's a new unit. And then the grills and the sizes. So, and then that's all they give you here, right? Is 24 by 24, 12 by 12. But when you look in the cost book, it's going to ask you that size based on a neck size. That's why, you don't want to do your work twice. Just note that when you do the takeoff. If it's the same grill and you see it's connected to different neck size ductwork, then yeah, definitely break it down even more detail. Okay, so if you have any questions, please email me at education@sfjohnsonconsulting.com. Otherwise, give me your comments and make sure to subscribe and even join a class if you'd like. And I will talk to you next time. Hey everyone, this is Stacy, and I hope you will take the time to review this. If you don't join us live, you take the time to review this later. We will be going over a full Victoria's Secret um, from top to bottom. And so, let's see, keyframes. All right, well, we're just going to assume we're good on everything right now because it didn't tell us that before. So we're just going to keep doing it until we make it perfect. Let's see. All right. We're just going to keep it going. All right. So what we're looking at here, these are some of the site survey pictures, some of the photographs from the actual site, because we will have a demo portion, and so we don't need that right now. Kind of what it looks like, getting rid of some of the old stuff. A lot of pictures taken, lots of pictures. All right, and everybody's heard of Victoria's Secret, and so let's go to the first page of our construction set. All right, so here we're at the cover sheet, and the cover sheet's going to tell us a lot about the project. And so we want to always review the cover sheet in full from top to bottom. This one gives us some information on the fixture. So, you know, if you've ever been in a Victoria's Secret, there are a lot of dressing rooms, and it's just fancy, but, you know, it's full of the fixtures and the millwork and stuff that all of the items sit in. So if you know, if you do that scope of work, that could be a good thing. That's a lot of money. All right, so our cover sheet is always going to tell us about the project, all of the things that we're going to need to do. And so we see here that there's a demo plan, which is good. We always like demo. Then we're looking at the cover sheet. The responsibility schedule is going to tell us different items, who's going to install and supply the items, the door schedule, life and safety, demo plans, barricade plan. So we'll include the barricade as part of the demo estimate. And then of course our floor plan, reflective ceiling plan, reflected lighting plan, that's different. And our finish plan, presentation and fixture plan, where all the stuff's going to sit. And then of course, because this is very, if you've ever been inside of a Victoria's Secret, you know that they have a lot of different stuff. So good interior elevations. Our storefront is going to be remodeled. And pink, I guess, is the other name for Victoria's Secret or whatever. That's their little logo, whatever. And details and specs. All right, so good cover sheet's just gonna do just that, so I know which trades I need. Oh, and then farther down it continues. So we have of course we're going to have all the MEPs because it's a remodel, but then we have a structural set. So let's see how the structure of the building is going to be changed. That's probably just at the storefront. So of course every cover sheet's going to give you the map, quest, view, and all of the details. But you know, if you do a lot of competitive estimating, you just blowing through this stuff and going right to the sheets that you need. So the responsibility schedule, I'm usually very interested when it comes to demo, because I want to see if the GC even has it on the sheet, because sometimes the GCs do the demo, because that's a good money maker. It's easy to do. Okay, so I mean, it's on here, so we'll assume that we are going to do an estimate for that too, or else there'd usually be an X through it for whatever is not going to be included in this actual project. And so the responsibility schedule again tells you about items, who's going to furnish them, and who's going to install them. So That's very, very important. So we always want to look for the electrician, because we are going to uh, we're going to estimate and send the GC our own estimates. So I need to know. Here we go. Electrical doesn't say. It says see the drawings. So we'll look at the drawings to see if, in terms of lighting package, especially, because that'd be a nice thing if you didn't have to worry about ordering the lights. You'd probably save $150,000 to $200,000. You wouldn't have to worry about. So that's important. All right. So what do we have? All right. So it's given us our door schedule. So let's just break this down first. Although we look at the door schedule when we are looking at for the framer, because the framer is going to install all of the frames, and for the painter, because we need to see what doors and frames are painted or stained or whatever. So and then if you're doing the hardware too, all of that will be here, but we rarely ever do the hardware, although that's a good scope of work. That's a lot of money. It takes about 2 hours to put hardware on one door. It's crazy. Well, at least that's, as long as it could take you. All right, so what do we have here? So we have our doors, and really I'm looking for because I'm just going to tear down everything. Paint, pre-finished, pre-finished, pre-finished. And, all of the frames we usually paint. See here, hallway side is, they're breaking it down by sides in some cases. And this is only primed. Side fold grill. Okay, so what I want to know, because usually the first thing I start is the floor plan and all the new framing. So let's see. The normal size, and then I want to see if it's hollow metal. Usually commercial is hollow metal, and if it's not, then I need to note that too. All right, so normally I'll go through and very slowly type in each one, but for the purpose of this, I'm not. But what I am going to do is the ones that I know, 3x7 hollow metal, I'm going to do those. Because that's the standard size of the doors. So, and then anything that says, like the storefront doors, you usually don't, the framer doesn't have to mess with that, because those are specialty doors. All right, so that's boring. That's the boring first part. And then all the hardware, we don't care about that. And then the doors. We will get a price for each of the different types of doors. Okay. And I haven't gone through the set at all. So we're going to be going through the set 2 hours every day until it's complete. And so if you don't join me today on this very first day, hopefully you'll join me soon, and I can get this latency thing fixed. I bought, when COVID hit, I bought everything I needed. And then, I kind of broke a lot of the rules online, playing copyright stuff that belonged to me, but still. And so we're trying to do things the right way. And now I know everything that I want you to see. I can direct you to my website, which we do on Sundays for, good movies and stuff like that. All right, so here are all the finishes. Let's just take a look on how detailed how many different paints. My goodness, come on now. Wait, that's the same. Oh, no, wait, it's the same. Oh, phone number, I'm telling you, I don't look at it before we look at it together. Okay, so yeah, see how many different paints? Oh my God. So this is why it's important when we do the paint takeoff. And the universe agrees. And that was do 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 do. We need to know exactly how many gallons of each one we need, or else you're just gonna be buying way more paint than you need. Cause it's probably trim. You probably need a gallon, 2 gallons of one kind, where you need maybe 5 gallons, 10, 20 gallons of a different kind. So that's going to be real important because there's just too many different paint types. Okay, ACT on the ceiling. It's all Armstrong usually. And this we can get out of the cost book real easy. All this standard kind of stuff. And then clear plate mirror with polished edges. We'll see who's going to have to supply that. All this kind of stuff is usually stuff that they have. They have a supplier or whatever. You order through the supplier. Alright, so wall finishes. We've got Firex glass board. And wall finishes. Vendor. Okay, so that's good to know. So if you say vendor, is the vendor going to install it? Or are they just supplying it to us? So we have to look at the responsibility schedule in more detail to figure that out. Let's look at more. But that paint's crazy. All right, floor coverings. What do we have? Who's not been in a Victoria's Secret bathroom? I haven't. VCT, easy from the cost book. Carpet. Okay. Easy. And then tile, porcelain tile, sales area, and transition strips. Don't forget those, very important. All right, and let's see. All right, so it's not very important for us. Video. We don't care about that. We're trying to build the thing. These are all the furnishings that go in. And then the bases, that's important. We've got to measure the linears. All right, let's go. And so, accessibility plan, what is that? How you supposed to egress out or whatever, right? How you supposed to go in and out. I never look at that either, because it's not part of drywall framing plan. All right, so what we got here, the demo plan. This is the fun stuff. All right, so we get these sweeping arms, right? And so if they tell us to take the lights out and we have sweeping arms and no lights to count, then we have to make sure, and I mean, if it's flooring, that's okay. I mean, we don't even know what's on the floor, but we got pictures, right? We have pictures. So we have to go through all those pictures and try to probably look at it and see if is there carpet there, what information do they give us. It looks like everything, all the broken lines right here, that means everything is coming out. Everything's coming out, so that's good. And so your cost book's going to give you good price for ductwork based on size. This is rectangular, and you could just say you got to guess. When you don't know, you got to guess. So you can measure that width and some by 2 inches shorter on the length or whatever. But that's easy. All right, so let's look at the keynotes. And let's look at the notes. Except where noted, maintain possession. Except where noted, maintain possession. What is it for the GC? That's for the sub that's doing it. Usually in a demo, the demo contractor maintains possession of unless otherwise noted. Or, it's, excuse me, unless it says it. I knew I wasn't going to get through. Where's the coffee? All right. Barricades, lighting for disconnecting, moving, utilities within demo, notify utility company, HVAC to inspect existing conditions prior to demo. That's important. Place marker. So, what we'll do is do a demo plan for each of the specialty trades too, because really if you know the person that's going to do the new plumbing needs to be the person that demos the plumbing, I mean, I'd like that. That'd be nice. Okay, so all right, gotta leave. You gotta take it out in the manner. Can't just be carrying it off the back of out of your trunk. All right. Flooring is one. Subfloor to the subfloor. Verify floor surface to be smooth and level to accept new finishes. Patch and repair. So on your demo plan, you're always going to have a patch and repair, and so we're going to put that on our demo plan, the patch and repair, and to because we're going to bid everything on this set, we're going to put the demo. We're going to separate the demo for the specialty trades on the demo estimate. Okay, and so the easiest thing for me always just start making the lines because we know we got to get rid of all of these walls. And so 4 is probably walls. And so we'll assume, because you do have to assume if they're, they say partition. So we're just going to assume, the assumption is, and we could put that in the exclusions part of the estimate, that we assume that the existing partitions are light metal framing. Because that was me drinking coffee. Because, it's 1, 2, 3, 4 on the clock. I like stuff like that. And I actually started something, I think, the live stream almost at 11:11. I like good numbers. I'm a numbers girl. What can I say? So, all right. So when we do the estimate, we do the pricing for the demo. And I'll have, remember, we're going to spend 2 hours a day or thereabouts, breaking down this in very good detail, because if I have to do this, which I do have to do it, this is how I have to do it. I gotta read it. Gotta read it. Okay, so the plumbing, remember, we gotta usually remove and cap. So those are usually in the demo estimate. Plumbing is usually the only scope of work that has a material cost. That's why we separate the prep for new finishes. We make that a whole different portion of the estimate. And so far, please vote on our what do you want to see for 2023. So far, 2 votes in, and both are for estimating. So, okay, we like it. They don't call, I call myself. I don't call myself the construction queen for nothing. All right, so let's go. All right, so we know the walls, so we could just go through. Let's do our thing here. Remember, we gotta find the scale. Where is it? Here we go. 1/8 = 1. What's that mean? For every 1/8 of an inch we measure, it's really 1 foot in real life. So we get the good old electronics here to get it together. And now we're going to say, I get a segment tool and we say demo walls. And if I have to demo exterior walls, I'll note that later, which it looks like this is some happening right here. Storefront. But I always like demo elevations when I have to do walls on the exterior elevations, right? Because you're not demoing the whole wall inside of this galleria. So, all right, so let's find some walls to start with. This is some real serious. That's a wall on the other side of a column, right? So that's a little more of a, that's like something like that, and let's do something like that, and then we do something like that. We don't want to cheat ourselves, okay? Because that's like something like that, and then like that, and then I don't know what we got going on 6, but I don't think that's part of that. I picked a bad place to start. Oh, that's 2. Look. So let's go to 4. that's funky. What kind of mess is going on there? Alright, we just gonna pick where we see 4. What is that? That's too big to be a wall. Okay, we just gonna do the little ones we know for now, and then we'll, because we could say 6-inch, right, as opposed to 4-inch. That way we don't really cheat ourselves. But you know, this is gonna be a good enough demo where, let me see what's 2. Gyp, tile, ceiling, soffits, and related. Okay, so 2 is the ceiling part. Okay, all right. We could do that later. Is that a 2 though, or a 4? Gotta get it right, because your 4 is gonna be like a more of an area than a line, right? Get rid of that. We gotta get rid of that fountain. And so go through openings, because there's wall above that. Okay, 4s. How much we got so far? So far we've demoed 206.5 linear feet of wall, and we gotta keep going. There's nobody more valuable to a construction firm than its estimator. So you should be at least at this point making $50 an hour. If you're not, then you need to learn all you need to learn and go make $50 an hour on your own. I'll teach you. That's what I did. You know, I was a construction defect litigation adjuster when I started this job. I wasn't an estimator. This business in 2010. So, you know, you could pretty much learn anything you need to learn to sustain your life if you're serious about it. And, you know, I'm a big believer in the old God being. So, you know, you always gonna get help if you think you will. And then there's people like me that had to sweat and cry. I don't know how to do it. And then I learned. And I'm a pro. And I can do my eyes closed. And there's nobody more valuable to a construction firm than an estimator, especially one that wins now. You better recognize. And all you got to do is win, right? And really, once you win once, you'll figure out how to win every time. And I tell people, I'm a winner. I'm sorry that hurt your feelings. But, you know, people don't keep bringing them, you know, your work. They don't keep bringing you work if you don't help them win. See, and that's how you know you winning. I'm like, they didn't tell me we won, but they sure keep bringing back work. And then I say, hey, did you win? Yeah. Oh, okay. Good shit. Excuse my French. That's what we want to do. We want our clients to win. Shit, what's the purpose? Right? What's the purpose if they don't win? There's no purpose. They won't keep calling you if they don't. I don't know what's going on. What kind of wall that is? What's going on here? But I'm just going to assume it's ceiling. Okay, it's 2. Maybe that's a little bigger wall. I don't know what's going on here. What this current situation? I don't really know. But I know we got to take it the hell out. All right? You see why I'm in construction? I can cuss. Hey, wait. It's like babies can cuss. But they sound stupid. See, we sound cool. Alright, here we go. So, I got me some likes. You better like me. How many girls you know how to do this, man? Come on. I'm a different kind, you know? My parents, they made sure we learned something. And construction is so cool. And I'm like, I need to do something that ain't never going to go out of style. So, it's like, yeah, as long as people are living and dying, guess what? They need a place to live. They need a roof. They need a McDonald's to go to. They need all that. And I'm going to help them continue to build the damn things. and teach the kiddos how to be super. I'm like, well, I'm gonna have a school eventually. I thought that. I'm like, yeah, I haven't done long enough to have a school, but yeah, I have now. So you guys are my test babies. I do actually have 3 children and 3 grandchildren, so I'm in the threes right now, and it's working out. All right, so we're just gonna leave that alone for walls, because I don't know what this situation is. I need to read 25 and 6. Let's see. 6, the other 6. For disconnecting, wait, not that, these 6. Okay, remove all tenant storefront materials to bottom of E bulkhead existing. Patch and repair, repaint any damage to bulkhead to match mall. Okay, so we gonna give any the bulkhead. See, we need to go back to those pictures. Right, that's the first one I saw. Oh, it's so cute. My grandkids love this place. I'm like, please. Now, if we can measure that, right, we got to remove to the bulkhead. So we got to remove all of that. Okay, all that. But these, I don't know if these are to scale. If we could use these in any kind of scale situation. I don't know. But, at least we know what that looks like. We got what? The opening, and then, well, you know what? The barricade is going to have to be that exact length. So wherever the barricade plan is, you probably can get it from there. Everything's about getting the right measurements. Everything. All right, so let's go back. That's why they give you the pictures. So it's like, we know we got lousy plans. All right, so that's all of that. I think. Oh yeah, we had bulkhead and then 2 windows, and I didn't really go into detail. I need to print that to see, because we know we got about, we can get at 5 feet above the opening of that sign, from the top of the pink sign to the ceiling, pretty much. I'll get at 5 feet, it won't hurt. So that length times 5 feet, that's all the front. That's all. Let's see what 25, we didn't read 25. Lease line, okay, that's not important. Yeah, so we give all this bulkhead stuff 5 feet up times that, and that's framing, and then whatever, probably drywall, right? So let's just do that. Let's do that. All right, remove bulkhead. See, now we know what we're talking about, right? Remove bulkhead, and then I'm gonna put 5 linear feet high, because I'll do another one and I'll think it's this one, and I'll be 58 on December 16th. I'm just saying. All right, I gotta write stuff down. All right, then we got that. Hey, and a lot of my folks, you guys ain't too young yourself, huh? A lot of you guys, and 91% guys, thank you, are from 45 to 54. So yeah, you guys need to be teaching somebody, huh? Better teach your kids. Oh, that's another thing too. If you want to teach your kids, people that are in this field, let me know. I'll teach your kids for free. I mean, not for free, but nothing's free. Is it? Is anything free? And if you get something free, it's probably not worth it. The only thing free is love. So, all right. So now we're going to do some of this. What is that? Is that still our ductwork? Looks like it, because it's connected to it. Let's just do, I need to measure that, because it really does make a difference, the width of your ductwork. So
That's 336 by something. Mm-hmm. So all the big ones will leave the same. But these little ones, that's probably Spyro, and it's probably, what is that, 19? I don't know, I went too far over. Let me go back. Let's start like right there. Yeah, 18. That's an 18-inch ductwork does exist. So look, I'm gonna say demo because the size does matter. 18-inch ductwork. So we're gonna assume all of them that look pretty much that size are 18-inch. And then this is that's not a spiral ductwork. So let's look for some of those spiral ductworks that's coming off of the main one. Like, hmm. We could do that one. That looks about the size, even though it may be like a 8 by 10 or something and not spiral. But our 8 inch is our key. Because anything bigger is more time. Shoot. Anybody tripping? We not giving nothing away, right? We want an honest pay for honest work, and we want the work, but we're not trying to cheat ourselves. Thank you very much. Let's do that one. That look a little bigger than 8. It's smaller than 8. No, it's bigger than 8. Hey, hey, that's 14. Okay, now we getting in the weeds right there, but we gonna pick 14. Demo 14-inch, cause it does matter. Cause I'm a nerd and I'm extremely anal, and we gonna go back and say that's not a 8. And let's start it right here, and then we go back and do magic. Stop. Let's take that out because we don't double charge, boys and girls, but we do know when we make mistakes. Let's take that way because we were cheating ourselves. All right. So now I'm not going that deep no more. Yeah, but that looks like that. So I'll say that's a 14 too. It won't hurt anybody. See how it curves though, and then we're gonna go like that, and then like that. And our HVAC professional is gonna take all of that off, and that's a little bigger, right? We know that. We can tell by looking. And 9's telling us something, but I'm just doing duct work right now. Did I say that was 8? I think I did. But those do look smaller than that, so I'm gonna leave that. We don't need to be that anal. Okay, and now we'll do the bigger ones. What size is that? What size did I say it was? Oh, Jesus. The bigger one, 36 inches. What? 2 feet? That's not. Oh, I think that's 36. We're just gonna say 36-inch ductwork. All right, so who's bored with this right now? Okay, but it's real life, okay? That's why we play the music. And oh, we will be uploading way more for you for the boring times. Because it just makes life go by easy when you have the music. Oh, yeah, that's probably going in there. And then we're going to do something like this. And then we're going to do like that. And then, but yeah, if you want to learn how to be an estimator, this is the real deal Holyfield right here. Oh, I sound old when I just said that. All right, because those are big duck words. Ain't nobody playing with these people. All right, And then we'll go back to the 8. Didn't I have it? Or did I say 18-inch? Oh, Lord. I don't even know anymore. I don't know. And see how we do it, so I'll fill all the rest in later. And then, so as far as the demo, we got to move on with life. Okay, so one more thing though. We want to demo the ceiling. And then see, you do all of this stuff that makes it, so we got to do this. Part of that was like soffit top and stuff. All of this is, right? All of that is. You know how you got your jip running in between like open ceiling or whatever. That's what that looked like that was. Okay, so for that we have that. And then let's see 31 and 2. Because it's like flooring, so that's the last thing we do because we got to cover up everything. Existing to be removed. So we got to do like store fixtures. We don't know how many, whatever. Yeah, right. We do 25 cents a square foot just to knock them down and drag them out. All right, that's what that is. Electrical, if it's like that, 75 cents a square foot, especially if we keep the fixtures. Okay, that's just been something that didn't look too overpriced when I put it in an estimate. It looks reasonable and something you could play with too. All right, 31 and 2. Let's see, 1 and 2. Remove flooring, okay, and then 2 ceiling. All right, so you can basically say once you do the one for the flooring, but you can't do it for the ceiling because we got that different ceiling than whatever this is. So, and we look on the pictures again, but you know, we'll give that. I don't even know. I don't even know. We'll just assume that's acoustical. Well, we look in the pictures and see what this ceiling is, how it differs from what we just did. Okay, but doing the, it just requires thinking and experience too. That helps. Oh, and then all the doors, right? Go in there and knock out, boom, boom, boom. But the partition doors for a bathroom, not the same as a door for, this kind of door. So if this is a bathroom, I don't think so. I don't know. Let's see 4. Let's read what 4 is. Because those partitions don't get the same time as a regular door. What kind of door is that? Oh, those are the dressing rooms, I'm sure. So those probably dressing room doors, so it's not even the same, but you can give most doors not 0.95. Those are probably dressing room doors. That's a dressing room most likely we're taking out, and that's why it shows that as walls, but it's not really like a partition wall. It's some kind of wall. So we probably need to add that into, but there is a cost book price when you're demoing partitions like these kind. So we probably use that because it's not the same as a metal stud door, that that kind. Not at all. All right, where are we at? All right, so that's enough of the demo. We'll fill in the blanks on that. When I come back on whatever we do next, then I'll show you how I finish the demo. Oh, look at this. Nice. So this is the barricade, right? You gotta cover it, cover up everything so they can't see you working on it. And so this is our actual front of the storefront, right? So we have to measure this wall. It's usually about 22 feet, 15 feet, something like that. I don't even know. I don't remember anymore. Oh, no, it's not. Look how big that is. That's 37 plus 8. So that many feet of, is just plywood and then a double door. And then you have to paint it. And then they have their graphics that they're going to put over it. So we have 2 double doors. Yeah, it's going to go the full length. So basically full all the way across. Front elevation. Oh, we have two. There's two. I'm telling you, I don't look at this until I look at it with you. Okay, so there's two. So it's this one and then this one. This is good. This is good. Yeah, because I think you had that door off to the side. And then, or is this the front door and then, no, the door's off to the side. I don't know. All right, so let's just knock this out really quick. You see elevation marker showing us what it should look like. B3. Okay, well, that's basically this. That's what it should look like. What this situation is they doing right here, I don't know. Well, what's that? I don't know why that's broken. But we just go by the plan. So we know we need 3 double doors, right? This one, and that one. And then the length. And then the height of it is this height. And what's 2? What we got on 2? What's 2? Care, no, not that 2. Okay, dust barrier. Okay, that's good to know. Interior barricades only. Yeah, for sure. That dust thing, from what I understand, oh my God, that becomes a point of contention when you are doing a demo in a freaking mall. Oh man, people that don't know what they're doing, they get the dust all in the next, all in the Apple store, and it's all over Apple stuff, and somebody got to clean that. So yeah, the dust part in a demo plan, just act like, it's the Ebola crisis, okay? Just do it like that. Because as soon as you mess up the next retailer stuff, you'll never be hired again. You'll have to pay through your insurance, okay? Yes, Lord. Have that all the way. Dust. Hopefully they tell you how to do it. Okay? For real. Oh, we got a top on it? Oh, yeah. See? Yeah, Veskine. We want, hey, just give me human plastic. Put it over there. Connect it, tape it. Because I'm telling you, I've seen so many bad claims. Yeah, the whole 3 stores down, fully covered with dust. All 3 stores. God, so funny. All right, so what do we have here? This is our floor plan. And Victoria's Secret, if no one else Starbucks, other than Starbucks, has the most annoying floor plans. So here we go. All right. It's a whole bunch of numbers. It's just a whole bunch of numbers. You just got to go through all the numbers. Okay? Just got to go through the numbers. And what do we have? So let's try to make sense out of everything. Okay, so the hatch is the mark that represents because this is the floor plan, right? And so we need to, what do we need to build? Okay, so we've got some existing partitions. So in our demo plan, or either on this floor plan, we need to have a cost for repairing the walls. Okay, and you get in your cost book, patching a wall. And then a good cost book will give you the labor for, and we'll go over that when we do the actual estimate, but it will give you the labor for finish 1 to, level 1 all the way up to level 5. So that's very important, because you will cheat the hell out of yourself, especially in places that are kind of upscale. It's not like a Walmart where it's okay if you have bubbles in the, You can get away with a couple bubbles in your drywall. But, a couple uneven finish, whatever. It's got to be like glass in a Victoria's Secret. Okay, so, don't cheat yourself. And that dust thing, even you, drywall professional, you're the main one that's going to cause all the dust problems. Okay, you got to really, really use not only OSHA standards when it comes to that, but, standards. Common sense helps a lot. Okay, so, all right, so these are all of our new walls. So, this is the standard partition, which makes life so easy. All right, meaning we don't have wall 1, wall 2, wall 7, wall 44. Okay, which we very well could. But, that costs a lot of money. And that's another thing. The more detailed the sets of plans, the more they cost. Okay, and so you can tell the quality of the owner by his set of plans. All right, and if I've got a messed up set of plans, I have no problem letting people know, because when the numbers are off, who are they going to always blame? The estimator. It's always your fault. They never tell you when they win. Oh, but they'll tell you when they lost, and they'll tell you just about how much and how wrong you were and how you suck and you should never work again in your life. But we get over all that because we start to win, right? Right? You get so hard on yourself. This is like, I equate being an estimator to being like a good baseball player, like the pitcher. Okay? I'm the pitcher. I get it right, boom, right where it's supposed to be, and we win. Ha ha. So, I'm the pitcher. You the pitcher. And we're going to help a lot of pitchers win in 2023. All right, but in the meantime, all right, we have to, they're not helping us in life. Doing this is where life don't help. Because you have to, look, that's not helping. Right? You got to have a good eye. Look at that. That's cute. That looks like two eyes, but that's really a fountain. That looks like two eyes, a nose, and a big old smile. I've looked at too many sets of plans for too long. All right. So just know when you got something like this against something like that, don't they look like they're different sizes? So yeah, it said somewhere in the partition, 6-inch wall where something. Use for plumbing walls and pilaster walls as required. Okay, so if you don't know where it's required to use a pilaster wall, then you better be having a real good eye. Well, that's plumbing though, so plumbing walls, right? Because they got all the pipes that go up. It needs to be a little thicker, but just keep in mind that when you're looking at something like this, that it doesn't give you a detailed partition schedule. What you need to be thinking of is drywall. The size of the thing, because this looks different. So yeah, this is a 6-inch stud. This is we're using metal. We're using metal. So this 5 7/8, 3 5/8, 5 7/8, 3 5/8. All right, and but whatever is the finish, remember and always break it out. You want to think of the size of the stud and how many drywall on one side or two sides. So that's why I said this don't kind of help at all, because in most sets you'll have like wall 1, and wall 1 will say 3/4 inch one side drywall on one side, or show a picture of drywall on one side. So if you're new at it, you might make the mistake of not knowing. I think there's once upon a time I had drywall on one side, but interior walls, drywall is twice the framing, and if the wall is exterior, it's one time the framing, or the same as the framing. So just keep that in mind. And then in this case, you need to keep in mind if it's a 3 5/8 the skinnier one, or it's a look. That's a 5 7/8. That looks a little bigger, but then that look bigger too. Right? What's going on here? All right, so let's go over these measurements that they have on here. Because if you don't have a digitized software, you can use the dimensions on the plan very efficiently to help you. And we call it a highly dimensioned floor plan. And the floor plan is supposed to be highly dimensioned, meaning it has a lot of measurements already on it to help you. And so how we read the measurements, this 8-foot stretch is from hash mark to hash mark. Not this one, but that one. Okay, so hash marks that are basically on either side of that number tells you the length of that segment, right? So we know that this wall basically from here, not here, from here to here is 8 feet plus whatever this is, and then they have hash mark to hash mark here, but it's not giving me any number. So when it has like hash marks that are close, what they'll do is usually put an arrow and then give you the number out here somewhere. Let me try to find one. I don't know why they put them extra hash marks without giving. Oh, here we go. Okay, so hash mark to hash mark, and then they have this, and it's saying that's 6 inches. So they're giving you that for some reason. Oh, for this, is that a wall? Or just for that distance, is that a wall? I think that might be a wall. Let's see. Is that a wall? It just looks like a space. But we'll figure out if it's a wall. Let's look at the wall schedule. And we can tell if there's something like that. Yep. Yep. It's a demising wall. Replace, repair, replace. It's a 5. That's what that one is. All right. Okay, and so what we got here? 46. What kind of wall is that one? That is this one. That's that one we got to build. Okay, so all of those is that new wall. But okay, that new wall, that is. Now how do you do something like that and they're next to each other? Well, they're both new walls, but each one, and now we in the dressing room, so that's a whole, I'm sure we have a dressing room where it says typical, a dressing room elevation. Okay, but if that's a typical wall, then it's what, 3 5/8 with whatever it says. So we got a lot of those. We got a lot of those. So that's easy. And so the height of the wall, that's where it gets. I mean, we can measure length all day long, right? But we need to know what the heights of these walls are. And so what we need to start looking for section views. Okay, what's the height of that wall? Okay, well, where is that going? That looks like a section view right there. So it could tell me the height of this wall, these walls. Okay, and here's a section view. Tell me the height of this, or this is the cash wrap, so it's probably not much height we talking about. And then what is this? K, whatever that is. Figure out what that is, what's going on with that. K over A1202E. We'll figure that out, but yeah. Heights of the walls, here's a call out, so we have to go follow that call out, and then we got to follow this call out. Okay, and so what I'm going to do next is I will have just separate videos, not lives, on what we're talking about right now, so you can match up this live with these little sections that we've done so far. So we are going to meet every day until we finish this. Now we've only gone through the demo and the framing. And again, I will post individual videos on the completion of the demo, the completion of this, or pieces and parts of this. And then tomorrow we'll meet and we'll do what's next. Well, I guess we'll do some reflective ceiling. Yeah, we'll do some reflective ceiling. And see what we got going on the new ceiling around here. We got some ACT. And remember tags, right? Finish and height of ceiling. So, like I was saying in another video, even if we don't have the height or section view to tell us the heights of the walls on the floor plan, I need to mark that. I need to do housekeeping. Floor plan. So if we don't have section view to give us heights, then we can look at the reflective ceiling plan. And housekeeping, reflective ceiling plan. Alright, then we can use that and say, well, shoot, the break room is 10 feet. Okay, 8 feet, manager, 8. But we got to get us some building section views or something like that. This is the reflective lighting plan. So, yeah, our estimate for our electrical, okay, a pane in the wazoo. Look at all those lights. And they all got to be connected to something. Okay, so tomorrow we'll also do the floor and wall finish plans. And for housekeeping, for this, it's very detailed because it's a Victoria's Secret, right? The ladies are supposed to go in here and feel so sexy and wonderful, and it's supposed to be so pretty. So that's a lot of finishes, right? And there's the fixtures. Oh, so many fixtures with unfolded undies. Alright, here we go. And here's our elevations. Okay, painter. Okay, fixture person. Final cleaning. We're doing the final cleaning. My daughter has a final cleaning company. Okay, final cleaning is just going to be so nice because all this going to be dusty. Okay, even though it's new, it's going to be dusty. Look at all those paints. Look at that. I need that painted that color, that painted that color. Ain't that a pain in the butt? So the painter, yeah, that's a lot of labor when I gotta. And then again, too, when we do the paint estimate, right, we're going to determine how many gallons of each type of paint, because you're not going to need 20 gallons of this one. You might need, some of you may need a quart. Who knows? So that's important. I love interior elevations. It's what it's supposed to look like when we walk in, right? Oh, look at the drawers full of unfolded undies. All right. Obviously, I have been in the Victoria's Secret. Okay. This is fun stuff. Look at this. Paint. Look at that paint. Paint. 1, 2, 3, 4 different kind. Victoria's Secret is paint heaven for painter because you make good money, okay? It's not a Walmart where you can slap one color on there and it can run and nobody cares. No, this has to be beautiful and perfect. All right, so that's tomorrow. So make sure to watch all of the basics videos that I have online. Make sure to do that on framing. And, oh, better than that, make sure you watch all of the 4 views. I'm going to try to, in this one, I'm going to find the link to that video, the 4 views. Because you, as an estimator, you have to be able to follow the flow of the symbols, right? And it's basically the flow of the views. This is an elevation view. So this is the view for all the finished trades. or basically, or the fixture people, right? The painter who's installing these fixtures to kind of get a good idea of what it is. So you can say, okay, it's a 4 drawer, like a 4-drawer cabinet. How much does it cost to place that? There's a cost for that. And here you can take a good look and see, you know, how they're laid out. And then maybe you just do one and then you just count how many other ones you have. You ain't got to do, you know what I mean? So that's an exterior elevation. Interior elevation is the thing, the elevation view. And then for our plan view, right, it's the view from above, the most basic of the views. So here we can do a lot of measuring lines and stuff. I mean, the plan view is awesome for measuring lines and areas. But once you need to know how high the wall is, you're done, right? You need another view. You need another way to tell. Okay, I'm just like I had to go look at that picture to determine this exterior bulkhead, right? I need another view. You need a section view. And let's see if we can find real quick a section view. So plan view, elevation view. So make sure before you come back to this video tomorrow at noon Pacific time. It's going to be noon every day until we finish. Okay, go and review the views because we need to look at the views in order to determine heights of walls. So let me just try to find a section view at this point. In this set of plans, I tell you, I don't look at them until we do them together because I've done quite a few of these already. There we go. Okay. So this is a section view. So a section view is as if we're up here at the plan view and we are like cutting the wall down from top to bottom and we're opening it up and taking a look. And this is what we see, the section view, how the interior, how it's built in how it's basically built. This is a storefront. It's like we took the storefront door windows, cut that in half, and now we're standing in between the cuts. And so what do we see? And then here you get another section view. So you got to be able to go from plan view to section view to detail view, which is, this is a detail call out, not because it starts with a D. That's telling us what? Image D or picture D on page A08.15. And similar is the same as typical, but similar means, okay, if I'm showing you the left side, the right side looks the same. That's what sim is. Sim is all about. Same as typical, pretty much, kind of. All right, so views. You need to be able to go from one view to the next view to the next view because each of the views gives you more detail. So that, and also don't forget to sign up for our Plan Reading Basics certification at our website, sfjohnsonconsulting.com. That way, I think I'm going to do live classes like this. And so once you attend, I'll have proof that you've attended. Instead of you reviewing the videos videos can help you take the test. But we'll do the live classes. There'll be 10 of them from cover sheet all the way through the MVPs. As long as you attend live each one, and I see that you're here, then I'll send you the test, send you the final, and you'll get our certification for the basics at least, and then we can grow from there. All right, but thank you for, if you didn't watch me live, please make sure you watch the recording, and please join us tomorrow at noon Pacific time to get part 2 of this. Have a wonderful rest of the day.
Stacy with SF Johnson Consulting, and this is another live version of our Victoria's Secret Takeoff. And today, because Fridays are for HVAC and plumbing, we're going to go over the HVAC and the plumbing set. Just want to hope and thank you for all the listens on our music. Music is a passion, so everything I do pretty much involves music. So I hope you're enjoying the collections that we're putting together for you. There'll be many more to come. We try to add more every day. And yeah, it seems like you guys like it. I don't know. I mean, contractors might be rough and hard and stuff, but they sure are listening to that music. So what's waiting here? Oh, come on now. All right. Be nice on the chat. I'm just going to have to say that. All right. So right now we are going to look at our mechanical set. So what's the mechanical set? It's the HVAC set. So it's all of our mechanical equipment, our exhaust fans, our rooftop units, everything that heats, cools, and moves the air. And so we're lucky on this one because it appears that everything is existing, and we'll just have to reconfigure probably the ductwork on what's existing. And then here are all of the grills. And remember, when I look at this live, I look at it for the very first time too. So it's not like I've had a lot of time to prepare it. I'm sure you'll be able to tell. Now, let's go over some of these things right here. When we have the X's, we know that those types of grills are not included in this particular project. But because they probably have so many choices, they just let you know which ones they're using. So in this case, we're going to see SD1, SD2. We're going to see RG11, and I think I saw, an RG7. So return grill, and then supply grills. And so we go right to the plan, and this is a pretty big plan. So like all of our HVAC plans, we have to do pretty much 2 to 3 steps, right? We're going to measure the lengths of all of the ductwork. We're going to then count all of the 90s, count all of the grills, and if there is no indication that there is a flexible ductwork from the rigid ductwork to the grill, then we have to incorporate a 90 and a little portion of this same size ductwork going down. And this indicates that the grill has a adjustable damper. And so when we go to the pricing portion, we make sure we choose grills that have the damper included. All right, so what do we have here? A lot of 10s. And so we would just make sure our plans are to scale. This is pretty big, so 3/16. Okay, and so we would just start in one area and work our way all the way over. Now, something like this. This just means that whatever this is probably, it should tell us 22. Well, that's just the thermostat. This is some kind of ductwork that's already existing, that's on top of or over the ductwork that we're doing. So we can go ahead and include this section, basically, is what that is. And so, all right. And it can be a little confusing too, because there's a size here, right? 8-inch spiral. Nothing here, nothing there, nothing there. Okay, but you're just going to have to make the assumption that everything is 8, unless it tells you it's a different size. And for this one, we're just going to assume everything is 8, because this has nothing, right? This doesn't have the 8 down here. And it doesn't have anything here. And see, that's the thing. It's the only thing about being an estimator, is that you have to make sure, you have a good eye. It's very
precise, and you notice things like that. And if it's a problem, you note it. But it's probably, like I said, the more money you spend on a set of construction documents, the more detail you have. Okay, so they just don't think they just assume we're going to think these are H2, in which we will. Okay, now this stretch right here, yeah, those indicate the existing ductwork that's already there. And I'll read 21, see what 21 is telling me. Yeah, that ductwork, so everything that's hatched is existing ductwork. That, it looks like we we deleted that in the demo. Oh, I don't know, maybe so. It may look like it. It may look like it, but probably not. So I'll go back and check that too, because I'm going to come back on an unlive version of this and put all of those, complete all of those takeoffs to the demo, the framing, the ceiling plan. So, all right, it's still coffee time around here. Okay, so we'll start here, and we'll just assume that these are all, so this is a straight ductwork, and then we'll say that's a 45, 8-inch. Okay, so, and then that's a 90s. And so we do all the straight ductwork first, so 8, always do it like that, as opposed to 18 by whatever. And so we'll count it from here, stop it there, here, stop it there, and then here. And then we have to make some allowance to connecting new to existing, and we'll put that later. Okay, and so you can keep doing the same thing all the way to and I'll just do one more. Okay, and now we go to, so remember those are that's that, and then we go to the 10s. That's why you need that music. Fall asleep and say, oh God, this is the most boring thing in the world. But it's the end result that you really care about. So remember, when we get like here, we're going to do something like that. But then that's a 90, because there's no indication we have ductwork, flexible ductwork. 90, and then some portion down. All right, out of there. So that's the 10s. And it looks like this is nothing but 10 and 8. A lot of 10 and 8. And just remember too, when you have existing ductwork, you got to account for connecting new to existing. There's something you got to do there, right? So give the contractor some kind of man hours and some kind of material cost for that. Okay, so that's that, and RG3, turn grill 3. That's interesting, because what's it connected to? The turn grill 3. So I'll look into that deeper. It's like it's just hanging there. Okay, there's nothing else here that's special. All existing, so the only thing really to look for is you have a ton of connect new to existing, and based on the size, make sure you do that. And shoot, I'm not going to spend an hour just drawing lines, but that's pretty much all we have here. And to one other thing, you want to make sure, I don't know, let me look, if the grills separate them by neck size. That's always an issue, supply grills. No. Okay, so they're all 24 by 24, but when you do the takeoff, you want to know 24 by 24 8-inch, right? And 24 by 24 10-inch neck size. So keep that in mind, or whatever the other, if there's anything other than that, I don't really think so. 10 and 8. That makes this real easy as far as the takeoff. You don't have to do, excuse me, 10,000 different rectangular numbers that are typically all new, because just the thing about the HVAC system, the way the air moves, right? The air starts at the units, and the ductwork at the units are, the size of the ductwork is really big. And so when we still force the air through and we have smaller size ductwork, that's what forces the air. That's what forces air. That's the mechanical movement of the air type thing. And so that's why you always, in like bathrooms, you always want to have you cut a little portion up. You don't have the bathroom door going all the way down like the other doors, because in a bathroom you always want the air to go into the room. You never want the air to go out of a bathroom, because for obvious reasons. And so that's the mechanical. That's why all the duct sizes, project by project, will typically be like, you can never say they're all, especially the rectangular ductwork, is always going to be all the same size, because it's not. Here's 24 by 14, 28 by 14, 20 by 14, 20 by 14, because the whole purpose of the Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and I hope you had a wonderful week. It is Saturday. I know I promised some electrical work. I also have a nonprofit, so I've been busy trying to build our channel for that, so we can help the little kitties over there and make the world a better place. Just like I'm trying to make you a better estimator. So this is something very special that's dear to my heart, which is electrical and doing a big electrical job, right? If you can do the big ones, them little ones you can do in an hour. So this is a home to suites where we are going to be analyzing it, and I'm going to be running you through the process of if you run into one, it's possible. It's all about how much time you got, and just don't take forever to do it, but don't rush it, right? I mean, just a regular from the ground up project, I like 3 days. One day to look at it really, really good and start the takeoff. Day 2 to finish the takeoff. Day 3 to put the estimate together. Okay. And if you're doing a home to suite, you figure you're going to give that a week to do all the same things. It really depends on the types of plans you have, how they've outlined and how the layout is, and because you'll have two different kinds. You'll have a set of plans where you'll be given the site plan, a plan that will outline the common area, which is all the hallways and like the laundry and the trash chutes and all that on each floor. And you figure the first floor usually of a hotel is not going to have any rooms, so all of that is going to be the admin buildings, and again laundry, kitchens, that kind of stuff. That's first floor. So that's one of the ways it'll be laid out: common area, and then the second, third, fourth, however many floors, it will only outline the hallways and service areas and whatever. And then you'll have a whole set of 3 or 4 sheets with the layouts for each of the individual types of units in the hotel. That's one way they lay it out. Another way they'll lay it out is just throw everything in there together, where all of the common area and all of the rooms are all in there together on each floor, which is a mess. And it takes you a lot more time unless you can try to find a way to eliminate that, which is meaning if they have all the rooms together with the common area, well then try to visually figure out which of the rooms, because a hotel's going to have 5 or 6 or 8 or maybe even 10 with the ADA units, different types. So kind of try to find out the different types, the 5 or 6. Do one of each, and then go through and accurately count how many of those types you have. That's one way when they throw it all in there together. Because when they don't throw it all in there together, right, they give you a set of plans for each of the different types. You do it, you come up with a number, and you know that there are 23 of those, and you multiply by 23. In this other way, where they just throw everything together, which is actually how this is set up, this home to suites, you have to do every but again, just visually look and see, okay, these units are the 2, one room, the little small little units with a queen bed, a king bed, whatever. Or you can really just go by square foot totals. So if and that we're going to expand on that types of estimates. We only did conceptual, but there's square foot total estimate, and hotels are the perfect way to use that, because if you have a home to suites, right, and this is a 2-bedroom, whatever, and you've done one already, oh my God, you already know how much it is per square foot because you've already done one. That's a square foot estimate, going by the square foot because you've already done it. And there are books out there that say with hotels, depending on like from a Motel 6 to the Ritz Carlton, one goes at $35 a square foot all the way up to $350 a square foot, depending on the quality. That stuff's out there. You just have to find it, or if you're going to be a real estimator, you're going to do it yourself and build historical estimates for yourself year to year. I mean, I have 13 years worth of estimates. That's a lot of history. But each one, every time I get one, I do it brand new as if I've never done it before, because that builds your experience. Because you don't want to get lazy. Everybody's lazy. Don't be lazy. All right. So, symbols list. All right. So, Those are the two approaches to hotels or any kind of building that has a main building and then a bunch of units, because that could go for an apartment complex. And really, what you want to pay attention to is where is the panel for the unit. You want to figure out if that panel for that unit is with the main switch gear, you include that cost for that panel with the switchgear cost. If that panel is in the unit itself, you run all the main feeders up until you get to that panel, and keep that panel with that room cost along with all the wiring that that panel inside the room is associated with. Okay, let me do that again because that sounds confusing. When we have something like this, we have a big building, you know, every room's going to have a panel, and then the common area is going to have panels. And so you want to know, because I had to learn the hard way, right? You do everything, you throw it all in there together, and then your client says, oh, could you break down each room? Or even, could you break it down by floor? I'm like, are you really serious? Sometimes. So you got to be prepared to do that. So I will at least, and I already know, when I get a hotel, when I get apartments, I do common area, which is all the floors, like I said before, and then I do individual units. Now, if you want me to break it down by the floor, if there's a four floor hotel like this is, no, that's a lot of extra money. So, but it's good to have for you. Okay, so you want to think about the panels. Okay, so here's the site plan. You want to locate the panels for the units, and you really want to look at the single line. See, I haven't really outlined any of this, so let me see where the single line is, because it didn't look like the panels were in the units. Because you always want to do the hardest stuff first. It's 4 floors, and you see they just threw everything in together. Okay, so guest rooms, king studio. Okay, so do one king studio, which is what we're gonna do. We're not, because they're the same. We're gonna do one king studio, and then we're gonna count how many king studios we have. We're gonna do one accessible king studio and see how many of those we have. Okay, we're not gonna just sit here and count, because you'll go nuts. Count, because too, you as an estimator, you want to give your client the best way to budget, right? The best way to budget is, what's the total cost for the site, what's the total cost for the common area, and what's the total cost per type of unit. Beautiful. That's what you want to do. All right, but I want to see, okay, so here are the units. Let's look in the unit and see if we see a panel. I don't see panels in the unit. So that tells me that the panels are in some location. It may be on the floor. It may be on each individual floor. So let's see. That's one end. Is there and if so, usually with hotels you have like a center by the elevator. Where in the hell is the elevator? Okay, wait. I gotta match them up right. That's one end, and then we're gonna match it to E 3.2. Okay, that's this one. 3.2. All right, because sometimes you have here we go. Okay, so second floor, A, B, and C. And so, my main concern is how are we running the conduit and wire, and what's going to what? A, B, and C. Okay, so all of these, okay, these rooms, all these rooms, all those going to panel C. Panel C must be pretty big. Well, we see it's got at least 59 positions. 60 position panel. All of these are going to panel C. And then all of these rooms are going to panel A. Because that's your pain in the butt. That's your pain in the ass situation. Where and what's going to be, though? Probably all of your mechanical equipment. Let me see if I'm right. Am I right? I don't know. C. Are you something? Yeah, C. No, C. We got A, B. Did I find C? I don't know. But yeah, that's our situation. So we have the panels in a common area. And so each of the rooms, see, that makes it so difficult. When we have to run, and originally I said, okay, we're going to do one of the rooms and multiply. Well, we can't do that in terms of running the power wire. We can do the counts. Yeah, they're gonna have the same amount of outlets and da da da. But power wire, it's not gonna be the same. Why? Because these are stationary right here. It's not like each unit in most cases has its own panel. They're gonna set this place on fire. Anyway. So it's all right here, and each one of the home runs basically is a different distance. Now we can what you can do, and let me just think beyond the box. This room right here, the home run's going to be a particular distance. So measure every home run you need from this point. Measure that distance and say home runs times 20 feet, home runs times 30 feet. Because running all those home runs is going to drive you nuts. You got to find an easier way to do that. Okay, so this is one that I'm going to outline it because this is one I was going to do a long time ago and didn't do. And I want to do it for you guys to show you. Okay, so it's really when you come to the electrical, the money thing. The money issue is the wire, the conduit. Am I running it right? Am I running it sufficient enough to account for a real situation? So again, it's not like each one of the rooms has its own panel, which would make it easy. It'd probably be like right here, and every room would have the approximately same amount of linears for the conduit and wire and lighting. No, we've got 1, 2, 3, 4, 5, 6 or 7 59 position panels times 3, all right here. And we have to run all of the home runs to this central location. So again, we do one room and pick a location where we're going to run the home run. We'll pick the lower rightmost position in that room. Measure the distance, so I don't know how I would do it because I would say, I think that would take us less time than trying to run 5 or 10 or 20, however many home runs back here. Or maybe it wouldn't. I'm not really sure. Yeah, it might. Yeah, it would be easier. So I pick here, and I say the distance of the home run to the panel. Bam, there. Because each room is only going to one panel. So I say, and I would just have it imaginary in my mind. Room 1, room 2, room 3, room 4, 5, 6, 7. Imaginary in my mind. Room 1 to the home run. Boom. However many feet. And then I'd have to say, okay, how many home runs I got coming out this room. That might not be worth doing. But that's why electrical is the hardest. Especially when you're doing something like this, it's a whole nother level. Because you want to get it right, but you don't want to take all day to do it. Okay? So hopefully that makes sense. But I'm going to show you it makes sense because I'm going to do it and I'm going to come back and have that done. At least that. I'm going to do the runs at least for that to show you. But, they could have just made life easy. Well, it would have cost a lot more, right? To put a panel in each room. And just okay, but that's what we're dealing with, all right, times 4 floors. So that's a beast. Okay, and let's go back. So the site. So panel wise, oh, I was looking for the single line. I just stopped there because these are the panels for the site and for everything here that we see. Okay, this is the building envelope. And we know that the panels for each individual floor is on the floor itself. And our power panels are somewhere out here. There's some, that's probably it right there. I don't think those are trees. It's going to tell us it is somewhere, but we'll come back. Oh, that's the generator. Main distribution panel. So yeah, it's all in here. Although the panels are probably in this room. But yeah, we have to run our lighting, underground conduit, and I think in another video we were talking about underground conduit when you have things that are crossing or whatever, and how do you determine how many linear feet above or next to you can run conduit. They gave us this nice little thing here for the trench detail. I'm like, this is just what I was talking about. Okay, so gas, telephone, CATV is showing us that the telephone and the electrical secondary have to be at least a foot apart, and the secondary and the gas have to be at least 6 inches apart minimum. Okay, and at least a foot in. Yeah, that's perfect. That's kind of in line with what we were saying. And so, you know, when you have to run that underground conduit, right? Because we know all the lighting is going to be underground PVC, 1 inch. It'll say in the specs. But for our purpose, let's just say it's 1 inch PVC. It should maybe 3/4 inch if it doesn't tell us specifically. If anything here is 3/4 inch, then that's probably 3/4 inch too. Okay, and then it's usually 2 number 10s for the lighting. And, you know, again, you got to look in the specs to make sure. Lighting is you don't need the 3 to run in between the lights. You need 2. Underground number 10s because of the distance, that kind of stuff. But again, I'm not an electrician, right? I've just done a million of them, and it's usually number 10s. But that's what the specifications are for. Make sure you're doing the right thing. But our job, hey, getting this scale right. Oh, where's the scale? Getting that scale right and clicking in the right place. So this is part 1 of this, just reviewing it. Again, when you do an electrical estimate, you want to give anything 3 days unless it's a minor little thing where all these switch gears existing. You can knock that out in 1 day. But this from the ground up, everything new, even the site. So you need to take 1 good day, review everything. And if you've done it's a lot. I mean, it's more time doing clicking than, okay, and making sure you're paying attention to stuff like this, that you need 8 of them and not just 1. Okay, then it's going to take you more time to click and count than anything. And what are these clouds, right? Well, when we've had our original plan set, we don't want to rewrite a whole new set of plans. And so we put these revision clouds around what, we're changing from the original set. And then we'll put that triangle, and then they're on the same set. There'll be somewhere for us to read to tell us what the revisions are. Okay, and so just looking over, this is a home to suites. We got about 4 floors, and to procedurally start with the hardest stuff. I want to see, and let's go and try to find, and I didn't mark anything, so you got to be patient. Ride along with me. Let's just skip a few. That's the mechanical set, so we'll go up from the mechanical set. Up. Controls. Looking for, here we go. Okay, so all the panels, right? They changed the panels. So what do we have? 84 position panels. Yeah, each of the floors. Yeah. Okay, and that's a 18. Tells you where they are. All right, those are the panels. There's more. There's more. And main switchboard. All right, and you know when you're running into the panel, so we have to count every one of those. All right, here we go. Single line. Let's see. We saw where the main distribution panel was bonding, and then all of the floors. Okay, 4 floors, each one on the floor, and the distribution panel on that floor too. And so, I had some requests for design builds, right? Really, it just depends on how big is your location, right? Is it you need a 600 amp system, a 400 amp system? It really just depends on what you're doing in your building. 1600 amp, that's something, I mean, if you have an electrician, they should be able to tell you, but hey, just tell me what the purpose of the building is. It's a hotel? Well, how many floors? Bam. Okay. There's your design build. How many rooms, how many floors? So you want to design build anything. If you're not an electrician, you shouldn't be design building anything, but you can give recommendations. If you've done this similar type of project, whether you have a detailed set of plans, much like this, then yeah, if you've done it, like, yeah, it could be like I've done one like this, and seeing once you've done it, then okay, now I can go back in and say, well, how much is it per floor, or per square foot, or per room, or once you've done it completely. And this is a very detailed set of plans you can do that with. Okay, and so all of your other ones we saw outside the building, and then these are the ones on the floor. And so your job, and that we'll come back, I think, in the very next one, because we're going to work this project from the hardest to the easiest. And the hardest is running our power feeders. How do we go from this single line diagram to actual lengths, right? Single line diagram just tells us the whole power system in one line, like an elevation view of all of the panels, all of the power components, blah blah blah, whatever, right? But it doesn't tell us this, not to scale, right? And so you have to be able to, and that's where you can really mess up, is not knowing how to determine these lengths. So that's the very next thing we're going to do, because we're going to go from the most difficult thing to the easiest, which lighting package, counting, click 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 click, into we'll get into my technique on running conduit and wire, because there's no way without it being there. I mean, you just have to do it in the most conservative and the neatest way possible to run that stuff, because you don't know which way they're going to run it, but chances are they're not going to run it like chopsticks, all over the place. Like that game you play, chopsticks, they all over the place, and you try to get them out without, they won't be running it like that. So your neat skills have to come in. And again, with that stuff, conduit and wire, you're not trying to say, oh, I'm going to be exactly 1,100 feet. No, you're trying to get a nice approximation that will cover what's there. Okay? So don't beat yourself up about that. But don't come in short and be dumb with it. You got to have a method for, and that's why I love being able to make a video of my takeoffs. Here, this is what I did. Now you went and made your labor rate $355. Don't blame that on me. This wasn't the takeoff that made you lose, right? So Nobody defends themselves more than a good estimator. But once you start winning, you don't have to say nothing, right? But it's going to take you some time and experience and messing up. But everybody gets good if you just dedicate yourself to it. Jesus. All right, I'm sorry. I didn't mean to say that. All right. Allah, Brahma, whoever, God is God, whatever you call him, okay? I don't even know. All right, so Jehovah, that's one, right? Okay. And there's our little silly lights. We'll do that last. See how silly that is? That's so easy. Okay, wait. Did they break it? What? Why we only got lights right here? Oh, the room don't have. That's the only light in the room? Wait. Maybe, huh? Because all the lights are plugged in. Okay. That's not too bad. See, that wouldn't be something now that you could do one of. You know, as far as the lighting wire and all of that. Except for this stuff. Yeah, we'll do that last. All right. So, we're going to call this Home to Suites Breakout something. So, when I upload something on this, you can see, because we're going to go step by step. Hardest thing first. So, what I'm going to do is start working on that power, all the power components on the site plan. And running all that wire. We're going to run all the wire and power. That's the pain in the butt stuff. And wait to do that last. You'll be half sleepy and then you'll make mistakes. So you don't want to do that. We do that first. And remember to join us on Sunday. Every Sunday. I know you guys like that music that I've been putting up there for you. And remember, use that music while you're at work. Put it in your ear. You got your phone. You know, don't listen to dumb jokes. Stupid people make you nail your finger or something. Just chill out with the music. Have your get your exercise in while you're working. Listen to the music. And just know I'm always get you some good stuff to listen to. And on Sundays, all day from 6 a.m. every Sunday beginning tomorrow, the 4th, 6 a.m. to 6 p.m. live music all day. Just instrument, no word. Well, some of it had words, but it's nice. And don't forget to subscribe. If you haven't subscribed, please do. There's so many people that watch my videos and haven't subscribed. I don't understand that. Okay, I don't understand that. It's like, if you like it, subscribe. What's that? I mean, I subscribe to everybody that gives into my knowledge base. I don't even care if I watch one time, because you never know. So please subscribe. That helps me a lot. And oh my God, I'd have like 5,000 subscribers by now if people that listen subscribe. I'm like, oh my God, why ain't they subscribing? Oh, because I'm a girl in construction. Okay, come on, give that up. Anyway. Music all day on Sunday. Just the little first part. Okay, so look, subscribe because OSHA 10 for subscribers. We're going to begin in January. On Saturdays, we're going to do it for 10 weeks because OSHA 10, of course, is 10 weeks plus a little extra for your test, right? So it's going to be a little more than 10 hours. Subscribers will begin that. Look at the details. It's all on the upcoming live videos. They all have to be live, and you have to subscribe, and I have to know who you are. That's the only way you can get an actual certification. And then Plan Reading Basics, we're going to do that too. Those are 10 classes, so that's also 10 weeks, and it's an hour class. That has to be, I mean, it's better if it's live, so you can ask me questions. So sign up for that. We'll be working on that. And the live music every Sunday. And every day we have a new theme. And so tomorrow we'll upload some OSHA information that's specific to electricians, because you could kill yourself if you're not careful. And some of us, sometimes we think we know stuff, and then we do know it, but then we make mistakes that are unnecessary, and then we hurt ourselves. So I'm going to give you all the good tips that OSHA gives us to keep our electricians safe, because the Saturdays are all about electricians. All right, so look for our electrical on them. We're going to call this the Homes to Suites package. We will go over everything, and I know that you guys have a big interest for electrical and structural and framing. So I'm going to have a big emphasis on that over these next couple of months. If there's something in particular ever you want to see, make sure you send me a note, a comment, or something, and I will definitely make sure to get that out for you. And I have a huge knowledge base, and I'm going to share as much as I can. So have a good rest of the evening, and I will see you. Look for some more info from me on Sunday even, and I'll talk to you soon. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and in this presentation we're going to show our students how to look at a demo sheet and kind of go through the process of what we do when we perform a demo takeoff, pricing, and completing a professional estimate. So our takeoff class that we present each of the scopes of work. So whether you're having to do your demo estimate or a flooring estimate or a framing and drywall estimate, we will show you how to measure your takeoffs, or your takeoffs, remember, is a professional construction, if there is such a thing, term for measurements. So we show you how to take your measurements, and then of course the measurements, from there we price the measurements. And remember, everything in construction is like everything in the medical industry. There is a code associated with it, and with that code there is an amount of time that the construction industry states that it takes to perform that scope of work. So construction industry knows excuse me, how long it takes you to frame a wall, how long it takes to install drywall. And so you take our measurements. That's part one. Part two is to go through our cost book, and we show you what amount of time goes with pretty much everything that you could possibly do. And the third step is to go over our professional Excel spreadsheet that's designed for each of the scopes of work. So in this class, we're going to go over demo. And so we're going to, this is a 4-H center that's going to be modified. So the first thing, that when you are, of course, you're going to read your specifications, right? Specifications going to give you everything about the project, all the details you need to know. Remember, the specifications is also the industry standard that we use in North America to help us communicate in terms of the means and methods and material we use in construction. And so you're given a set of specifications along with the construction documents, and the good estimator or the good project manager will read the specifications first and take notes related to each of the scopes of work, and then line that up with what we read and what we see and what we measure on in the construction documents. And so for demo, we know that it is demo because anything that is to be demoed or demolitioned or taken out is always shown with a broken line. And so this tells me, okay, I'm probably taking out walls as well as the partitions, or really I need more detail because these may be partitions, these may be partitions with tile on them, or the typical bathroom partition, which is just attached to the wall, like when you go to McDonald's and go to the bathroom, those kind. So the first thing we do is measure or count. In our case, we're going to be it looks like demoing a lot of doors and some showers. That looks like that's a shower. And so again, we're going to make all the measurements, do all the counts, and from there we're going to jump to how long does it take to do each individual thing, and do the math. So if the cost book tells us it takes an hour to demo a window, then if we have 20 windows, what? Bam, we have 20 hours. So one thing about windows, and when you take the class, we will go over in detail how each of the items here, what type of measurement, how do we need to measure that item in order to line it up with the cost book, in order to line it up with how long it should take. So for windows, whether we're cleaning them or demoing them, it's always per square foot of glazing. And so, yeah, you have to have some kind of elevation view so you can determine the height of the window, so you can determine how many square feet. So that's just one thing. But when it comes to the doors, we just count how many doors, because it takes a certain amount of time per door. And if it's a partition like the kind in a bathroom at McDonald's, that takes a particular time, as opposed to demoing a interior partition. How long it takes to demo an interior partition depends on the thickness of it. Is it 6-inch, 3 5/8? Is it concrete? Is it a concrete wall? Also with concrete, when we demo concrete, we're not only having to determine how many square feet of concrete we have to demo. If we have to demo, say for instance, this is probably this right here. Say for instance, they want us to probably take out the concrete in the building. Well, the first thing we have to do is cut it out, and then we dig it out. So we always have to have a takeoff number for our saw cut, because we typically cut it and then we demo the concrete. Those are two different scopes of work, two different man-hour totals, two different takeoff totals. So that's important. Okay, and so always make sure you know what your scale is, because the scale is used to make sure you're accurate with your measurements. And so this is a really good demo plan. We're demoing a lot of doors and walls, partitions, toilets, showers, and so we do all those counts and measurements, and then we come up with numbers. And from those numbers, we're going to go to our cost book and see how long the construction industry states it takes to do each operation. So that's a little small overview of a demo takeoff when we're preparing a demolition estimate. Each linear feet, and we need some kind of elevation view, especially if we're demoing walls, right? We need to know the height of the wall, not only the thickness of the wall, but the height of the wall. Same thing when we're building them. Have to know all of that. So we'd love to have you in one of our classes, and any questions at all related to construction, you can always ask me. And our website is S as in Sam, F as in Frank, johnsonconsulting.com, and have a great week. Hello, and thank you for joining me. This is Stacy with SF Johnson Consulting and Construction Services. And in this short video, we are going to review the scooter's electrical plan, just in short review prior to doing the electrical estimate and the takeoff and putting everything together. All right, so what we're looking at right here is E0.01, which is the electrical site plan. And if we pan in really quickly, they give you kind of a quick overview of it. There's a drive-through, and this is typical of any drive-through, where they'll show you the menu loop, where you drive over it so they know you're there, and then the speaker and all of that. And then that is connected underground to the power of the building and to the service loop, service window, all that good stuff. So that's kind of like in a nutshell, showing you each of the electrical components for the site. And this is the electrical site plan in general. So here's the building, and then here is, and of course there's always keynotes, so you have to follow each of the keynotes to see where it tells you what it tells you what to do, junction boxes. And then when we get into the electrical power plan, this is how they tell you which of the panels, panel A, and what position on the panel that piece of equipment is directly connected to. And we know it's directly connected to because this arrow represents what's called a home run. And of course, when you hit a home run, right, you hit the ball and you go all the way around. Well, basically an electrical home run is telling you to go directly from that junction box to that panel A, position 3, and then whatever at 5 and 1 is telling us, we have to make sure we follow that too. And so all throughout an electrical plan, whether it's the lighting plan, site plan, power plan, you're going to have some power component, in this case some exterior building lights that are directly connected to each other. Okay, and same thing for outlets in a room directly connected to each other, and at some point it's going to be directly or home run to a particular panel and a position in that panel. So depending on, these are all commercial buildings, so I mean the smallest we have seen is a 10 position distribution panel, or you have 84 position panels. It really depends on what the power requirement is and what they're doing in the building. Okay, so this is the site plan, shows you the loops, all of the underground. Of course, it's going to be underground wiring, so they don't need to show it ... underground, which broken line indicates underground, because it's the site plan. We know by virtue of this being a site plan that this is all run underground. Okay, and to the building itself, and then there's some other things, and parking lot lights. I don't see parking lot lights. That must be coming along later, or whatever. So it's all the signs for the building directly connected to a panel at some position. Okay, junction box, waterproof. Okay, so that's the site plan, and the photoelectric plan shows you how the light is supposed to be distributed throughout the parking lot and all of that, but that's not for us as estimators. Some specifications. All right, now this is our panel. So we have a 84 position panel, and it really, when we get in a more detailed class, we can give the details of everything, but basically it's going to show every position on the panel and what is connected to the panel. And then if there is a breaker, the size of the breaker, 20 amp, 1 pole breaker, depending on the equipment, it's going to be a different size breaker. And so when we're doing an estimate, we have to make sure we count how many different types of breakers we have, and then the particular type of panel that we have. Okay, so this looks like we only have one panel for the scooters, but it's an 84 position panel, so it's a pretty big panel. And you should also be given what's called the single line diagram, which shows, and this is a single line diagram, which shows from the utility transformer, which is the power that comes from our city. It's the utility transformer. We have to bring that power into underground conduit and wire to the meter, to the building disconnect switch, and into the building to the panel. And it looks like they have a time clock that controls all the lighting and how the lights come on and off and all that stuff. So that's a single line diagram required in every electrical set to show you how the main power is coming into the building. You're always going to have a meter. You're always going to have a building main disconnect, and then directly connected to the panel, that 84 position panel, and a time clock. So it gives you more details about how the outlets in the boxes should be wired and positioned. And again, all that's going to be in the specifications. Some legal requirements, and now we get to the 2 plans for electrical sets. You're going to have 2 plans. So one plan is going to tell you about all the lights and how they're controlled. So it's going to be the lighting plan, and that's what we're looking at here. There's a lighting schedule telling you, it's calling this one light A. This is what it is. So we have to go and order those. You know what you have to order. So all of these call outs and all of the symbols you'll see on the plan. And it's a small little establishment, so it's really what it has, 2, 4, 6, 8 lights, some junction boxes connecting them, the emergency lights as required, and then the conduit that connects the lights. And then those are the building lights we saw from the site plan. And then the good old home run. Okay, now some plans have it, some plans don't. On your lighting plan, it's only the lights and how they're controlled. So the light fixtures, junction boxes, occupancy switches, that dollar sign is always a sign of a switch. Electrical, you have a ton of symbols. And so As you work on these more and more, you'll get more familiar with all the symbols you have. All right, so what you won't see is the power panel on a lighting plan. And so you have to look at your power panel or your power plan, figure out where your panel is. So when you accurately measure your conduit length from your home runs, you'll know where you're measuring it to. Okay, so this is the lighting plan. It shows all the lights and how they're controlled. If uh, if this was like a larger place and we had like some rooms they wanted on while other rooms were off, it'd be a totally different configuration, and we have some videos of that as well. But this is a really small place. All the switch bank. Okay, so lights. That's one of the plans you'll get in the electrical set, and the other one is the power plan. So power plan's only going to show you where the panel is. So now if I go back to that lighting plan and I have to run all my home runs, I know I'm going to run it to right here. See, it's probably right here, but they don't point it out that that's the panel because on the lighting plan, the job of the lighting plan is to show you just where the lights are and how they're controlled. Okay, dimmer switches, exit lights, but no call out of the power panel. So now I know if I have to connect this junction box to here, I'm going to go right there. I'm going to measure just that length plus some distance down directly to that panel at position 50. All right, so power plan is way more complicated than the lighting plan because the power plan's job is to show you where all of the outlets are located. Junction box is required to connect other pieces of equipment. Quad outlets, meaning 4. So that's an outlet that has 4. That's an outlet that has 2. Sometimes they have outlets that only have 1. So it'd just be one line sticking up. But in an electrical power plan, the job is to show you every component that needs power, what position on the panel it's connected to, what it is, and also it's going to also show you where the phone special receptacles and phones and data jacks are for electrical set. The high voltage electrician will always have to provide junction boxes and conduit for all phone, computer, all that stuff based on, the specifications. Okay, so the power plan's way more complicated than the lighting plan because its job, again, every outlet and what position on the panel it's connected to. Okay, all of the HVAC equipment, where it's connected, disconnect switches. That's going to be somewhere we need to know the value of those because large equipment always has a disconnect switch, so we'll cut it off before it burns the building down. So large pieces of equipment always have a disconnect switch connected to it, where all of the outlets, its main means of disconnect are the breakers on the panel. Okay, so special receptacles in the CLG in the ceiling for special lights and stuff, whatever. Okay, so the electrical power plan's job is to show you everything that needs power in the building, how it's connected, what panel it's connected to, also data phone outlets, where they are, and tons of keynotes that you have to make sure you read in very good detail. Okay, so electrical set, lighting plan, power plan, single line diagram, all of those things that are needed to help the electrician properly power and light the building based on the specifications, based on the power requirements. Any other questions, concerns, please visit our website. We'd love to teach you more about this and other topics at S as in Sam, F as in Frank, johnsonconsulting.com. Thanks a lot and have a wonderful rest of your day, week, year, and life. Talk to you soon.
Hello, this is Stacy Johnson with SF Johnson Consulting and Construction Services. And in this small class, we are going to discuss the shear wall plan in the structural set. Now, the shear wall plan is basically just additional framing that we put over our load-bearing walls to shore it up and to help prevent the building from falling due to shear winds and earthquakes and things of that nature. So
the shear wall plan is pretty simple. Where in this on this set, they note them as P1 and P2, and they show you exactly where they should go. So it's really simple. Where P2 goes here, just this length of the wall, that length of the wall. P1 goes in 3 locations on this side, right side, and then this wall on the left side. So it tells you the configuration of each of the shear walls. It indicates one side of the wall to receive 15 over 32 inch sheathing fastened with 8D common nails, 3-inch on center. So 8D is the size of nails, and they're just telling you to place them every 3 inches at the panel and boundary edges with 1/2 and 12 inches off center at the inner supports, and then additional 3x6 studs at the edges. Okay, so it's really simple, and P2 incorporates some LVL beams with 2 rows of 16D sinker nails at 16-inch off center at panel edges. Okay, so shear walls really just additional framing over your load-bearing walls to help strengthen the wall. And so here in this set, this indicates a hold down. So they have A, B, and C. And so you can identify each one and, come up with a pretty good material quantities list. So shear walls is probably the easiest thing you'll ever have to determine. And the length of the height of the wall is usually the height of the building, right, or above. So you'll check the section views, and there should be a detail. It should give you a detail there. It should be a detail sheet to tell you the configuration, even more of an elevation view of the shear walls. Okay, so that is the shear wall plan. Very simple, very easy additional framing that goes over your load-bearing walls to strengthen them, to prevent the building from collapsing due to wind and earthquake shears. So if you need any additional help, please feel free to sign up at our website at www.S as in Sam, F as in Frank, Johnson Consulting.com, where we will set up online office hours for you to help you a little more if you do need it. But once again, thanks for joining, and I will see you at the next class.
Hello, this is Stacy with SF Johnson Consulting and Construction Services. And in this small video, we're going to discuss the door schedule and some window elevations. Now, everything in the construction set is very important, as is the door schedule. And so we'll take a look at the schedule. This one also includes some details for the door jambs and some other things and some other exterior details, but we're going to focus on the door schedule. Now, in any project, every door is listed on the door schedule, even if it's the exact same size, regardless of where the door is, if it's a small door, if it's the storefront doors, if it's interior doors, exterior doors, they're all listed on the schedule and by the size, the door type, which they'll give you an elevation view of the door type. So those are the different door types, A, B, C, D, and E. So if you have to price them, then you know the exact type, and hopefully from a material supplier or a cost book you'll be able to get a pretty good price for that door. So it gives you the height and, well, the width is the first number. Height, of course, is the height of the door. And then if it is a pair of doors, it'll let you know. Okay, and so the type, the frame, depends on, each of the different doors may have a different frame type. That's SF is most probably a steel frame and a hollow metal frame. And in commercial construction, most of the frames are hollow metal frames. And so to give you information about, well, some do about the finish on the door, how it's painted, and then all of the lock set and all of the hardware that's associated with each of the doors. So that's the door part of the door and window schedule. And then, of course, the window schedule is going to give you an elevation of the windows, or the view of the windows as if you're standing in front of the window, so you can determine the height and the width of each of the windows as well, and how they're looked at. And two, who would need this? Of course,
whoever's installing the doors and anyone doing the caulking around the doors would find this useful, so they could determine how many linear feet of caulking you need for the doors. So the door and window schedule is pretty simple. It just shows you all of the doors. And again, even if they're all the same size, which many of these are, they still have to list it. The type of door, let's move that. The type of door, the frame for the door, all of the framing details, and that points us to a detail that's probably on this sheet. It gives us the framing detail and a whole lot of other information: the stop, the threshold, the closer, the lock set, and water stripping, everything involved in the door. And again, the windows are going to give you all of the elevations of every window. Now, the difference between doors and windows: if you need to know the number of windows, then you have to look on the exterior elevations and count. Where if you need to know how many doors, they're all listed here, regardless if they're the same. They're all listed here. So we know that this project only has this many doors. But as far as the windows, again, we'd have to go count via the exterior elevations and count the different types of windows. I think there's probably 2 of these and 2 of those and whatever. But you got to look at the exterior elevations in order to determine the number of windows, where on the door schedule, it gives you the exact. You just count, it's there. For windows, again, you have to look at the exterior elevations, and like for a high rise or for an apartment, chances are they're marked A, B, C, D. So you use a counting tool, count all the A's, all the B's. Then again, you'll know how many windows you have. Okay, so this is Stacy Johnson, SF Johnson Consulting and Construction Services, where we teach classes of every kind. This is part of the basic plan reading class, where we're looking at the door schedule and the window elevations. Feel free to contact us at info@sfjohnsonconsulting.com on questions on this or any other class. Thanks a lot, and we will see you next time.
Hello, and thank you for joining me. And this is your teacher, owner, and operator of SF Johnson Consulting and Construction Services. And in this small snippet, we are going to discuss the ceiling plan for our series of our study of the plan reading basics. Okay, so now we're looking at the ceiling plan. So it's from the plan view, the view from above. And the ceiling plan is going to tell us all about our new ceiling construction. And so for commercial, the typical ceilings are going to be acoustical ceiling tile, which is represented by these lines that represent either the 2x2 tile or, on this side, the 2x4 tile. And each of the rooms, it's going to have a ceiling tag or room tag, ceiling tag that's going to tell you 2 things. It's going to tell you the type of ceiling finish, and it's going to tell you the height of the ceiling. Not necessarily the height of the studs, so don't confuse the 2. It is the height of the ceiling. And so on the ceiling plan, we're going to see everything that's going to go in the ceiling. Not only the ceiling finishes, but then we're going to see all of the HVAC supply grills, represented by the X, all of the lighting fixtures and where they're represented, because the ceiling finish person needs to know, okay, we'll have 1, 2, 3, 10, 12, 15 less 2x2 tiles, because why? We have a grill in there, or we have a few of the tiles that need to be fitted for casings for the lights. Okay, so when you see the ceiling plan, you're going to see everything that's on the ceiling, that's represented on the ceiling, and it's typically for reference only for this whoever's installing the ceiling finish. So ceilings, again, for commercial, will have a 2x2 acoustical ceiling tile, 2x4 acoustical ceiling tile, and then we'll usually have some some gypsum or drywall, right? So this is saying that this is a drywall ceiling, and the height of the ceiling is 8 feet above finished floor. Okay, now, always have to take a look, because here on our ceiling plan, we also have a section view marker. And what is that? Well, it's telling the ceiling contractor, whoever's installing the ceiling components, that there is some other view you need to look at, because the construction of the ceiling is a little different. And so we're always going to take a look at that. So we're going to look at image number 1 on A103, which is, this is page A103.
And now this is image number 1. So in terms of our framing, because this is for our, our framer would need to know this information. So you would have to break this ceiling construction down in the most practical way in order for you to make measurements and to determine a cost for this. So we're basically just looking at the menu board that's represented here, and it's basically a wall coming down from the ceiling joist as opposed to the floor plan where the walls come up from the ground. Same concept, just coming down from the ceiling. And then here on the right, this is the bulkhead. That is basically 2 walls, right, coming down from the ceiling. And then in between, you have a flat surface, like a ceiling. And so you would break it down in those 2 ways. And so how we would break it down, anytime we have a wall, we need 2 dimensions. What's the height of the wall? What's the length of the wall? And then we can determine the ceiling framing for this set or this section of wall. We know the height is 4 feet, 10.5 inches, and the length corresponds to the menu board, which is from the plan. We can measure here. That's the menu board length, and I think that's about 20 feet long. So 20 feet times the 4, whatever, how many square feet of that menu board framing you'd have to construct. And so you break it down to the framing, and it looks like you have the top plate. That would be that same 20 feet, right? The bottom plate, same 20 feet. And then you break this one down the same way. And so basically what you have is 2 walls that are 3 feet, 10 inches, whatever. Excuse me. You can combine that and say you have 7 feet worth of wall times what's the length of the bulkhead, right? The length of the bulkhead is this length, whatever that is. I think I can. Oh no, we have to change the scale. The scale is different. And see, when you're looking at a set of construction documents and it's trying to tell me that that's 4 feet, that's obviously not 4 feet, right? 5 feet, 4.9. So that tells me, oh, something's wrong with the scale. But yeah, I was using the scale to measure this, right? And this scale is for every 3/4 of an inch, it's 1 foot. But I should have had it on this scale, which is much different. And so, yeah, the measurement's going to be different. Where the scale for this is, for every 1/4 of an inch, it's 1 foot. So I have to make sure I change the scale, and that's important, or else you'll be measuring stuff wrong. All right, now we can go back and see what's the actual length of that bulkhead length right there. If I click on it again, it's 15 feet. That makes a way more sense, right? So we can round that up to 15 feet times, well, we say 2 times these lengths. So now you see these lengths have changed because the scale has changed. And so scale is very important when you're looking at a set of construction documents, that it is correct, because it's obvious the menu board bulkhead is not 12 feet. Okay, that makes sense. All right, so ceiling plan tells us all about our ceiling construction. If there's a section view there, you need to follow that section view so you'll have a good idea of the construction of that. And you see it can become complex, very much so. But when we're talking about framing, all we need are 2 dimensions. What's the length and what's the height? And for the ceiling plan, we're typically going to get areas. So we know the area of this bathroom area is about 200 square feet for the bathroom. And we cut off the area for this, so we would determine that area plus the wall construction here, wall construction there, wall construction there. That would be the ceiling in terms of our framer. And then if we're the acoustical ceiling tile person, we're going to measure the area of all of this, of the 2 different types. Okay, so this is the ceiling plan. It tells you all about the new ceiling construction. If we're the framer, we're looking for any drywall construction or that bulkhead construction. If we're the acoustical ceiling tile professional, usually they don't do the same thing. So if I'm doing the drywall, I'm usually not doing the ACT, or I might. It really depends. But we always break that down separately, of course. Okay, but the typical framer is not going to do the acoustical ceiling tile. Okay, so it shows us everything on the ceiling for reference. So we know if we are installing the acoustical ceiling tile, we know we have a couple less tiles because we're going to have a supply grill for the for the HVAC system. And a couple, a few have to be specialty made for the can lights that are going to be coming through that. Okay, so that's pretty much all you need to know about the ceiling plan. All new ceiling construction Each room is going to have a ceiling tag that tells you two things: the ceiling finish and the height of the ceiling. If you have any questions about any of the information, please make sure to visit our website, www.sfjohnsonconsulting.com, and fill out our online office hours, and we'll be happy to set some time aside for you to go over this one by one. But again, thank you for joining, and I will most definitely see you at the next class. Take it easy. Hello, and thanks for joining me. This is Stacy Johnson, owner and operator of SF Johnson Consulting and Construction Services. And in this class, we are going to discuss the roof plan in our multi-plan review of our plan reading basics class. And so we have the roof plan. Now, when we talk about the roof plan in the architectural set, we're only talking about the roof finish. We're talking about roof finish only, not roof framing, right? Because roof framing is part of the structural set. And so the finish is basically is what we are discussing. And so when we look at the roof plan, we're looking at the roof from the plan view, right, from above, and really it reflects everything that makes a hole or a penetration within the roof, right? Because the roofer's job is to waterproof the roof, to put on the roof finish, and to make sure any openings within the roof are waterproof, no moisture goes through the roof. And so as a result, the roof plan shows everything that has a potential to leak through the roof. So here we see all of the rooftop units, because all of the uh, ductwork, right, is going to go from the rooftop unit into the building. And also same thing with the exhaust fans. The exhaust fans themselves, the hoods, are going to go from the interior of the building to the roof. And then all of the piping for the plumbing system for the vent to roof, all of that's going to go through the building. And so again, it's going to show all of the penetrations within the roof. And there will be detail sheets to show the roofer, how to more detail on how to make sure that that's done. So some is here on this sheet where it shows the roof curb, and the rooftop unit sits on the curb. Within all of this is the roof joist, and doesn't give a good clear picture of the ductwork and all of that from this perspective. But here's another one that shows the vent pipe. Okay, and so the roofer knows how to put all of those, the pourable sealant, the membrane, how it's supposed to lap over, and everything else to make sure that no moisture goes in here. Obviously, you can tell from that that's pretty good. No moisture is going to go in. All right, so a couple of things specific to roofs when we're talking about a roof. We are always talking about the pitch of the roof or the angle of the roof, because all roofs have an angle. So all liquids and water and snow, right, run off of the roof into whatever kind of gutter system that they have available. And so what you'll see is the pitch represented on the plan. And so what this one says is for every foot or 12 inches it goes forward, the angle is 1/4 of an inch. So this is almost next to a flat roof, but it has a slight pitch. And the arrow's always going to point in the direction of the water flow, or the direction of the gutters or whatever. So we know that there's some kind of gutter system this way. Okay, so that you always see the pitch, and the pitch does make a difference when we're talking about the material for the roof, especially when we're talking about shingle roofing, right? Because it's not butted up against each other, it's lapped over. So pitch becomes real important because of the additional amount of material that you're using when you're installing shingle roofing. So pitch, that is one thing specific to the roofing trade. Another thing that's specific to the roofing trade is the measurement of those. Back in the old days, you get the shingles in bundles of 100 square feet. And so for roofing, we use the square, and we it's abbreviated capital SQ period. square, and that's representative of 100 square feet. And so when we talk about roofing material, we typically talk about the square, or we price it by the square, which is, again, 100, it represents 100 square feet. So if we have a 5,000 square foot roof, right, it's, they say, you know, we're so cool, we say it's 50 squares. Hey, all right. So just know that's specific to shingle, anything, even siding, they'll go by the square, which again is just representative of 100 square feet. All right, so the roofing plan, all of our roof finish shows you all of the roof penetrations, and it will give the roofer details on how to close in those penetrations, right? The pitch is specific, it shows the angle of the roof. And then we also have something called our crickets. And a cricket is just additional framing that's built over our flat framing when we have really flat areas. So it makes like a tilt, it makes an angle to where, again, all liquids can flow off of it. So usually when we have flat areas, this is a cricket that's built here, where this is the ridge of the cricket and this is the valley. So if water were to flow this way, right, in the direction of the pitch, it would flow this way. Well, it would stop here and then it would flow down the valleys and into the overflow and the roof drains. Okay, so that's what a cricket is. It's just additional roofing that gives that area an angle where it would tend to be very flat. Alrighty, and there's a little cricket right there. Okay, so that's the roof plan. Roof plan, plan view, view from above. Now, it's going to give us some section views here, but it's really just more so, the intersection of the parapet. Do we have flashing over the parapet cap, that kind of thing. So you've got to always make sure you take a look at that, and that is exactly what that is for. It's flashing over the parapet cap. So let's go real quick to 3 over A 425, and then it'll send us somewhere else. 425. 3 over 4. Do we have everything? There we go. 426. 425. 3. Okay, so we are the roofer. Because we are the roofer, we only care about things from the roof up. Okay, so we are the roofer. Now we know we have a roofing membrane, right, over 3-inch rigid insulation, then the cant strips and the riglet, and then we know we have all that good stuff. And now we have a call out right here. And so, we always have to follow the call outs if we think our scope of work is involved. Okay, so we also have a call out here. Okay, membrane flashing top parapet. So yes, that's our scope of work for the roofer. And then, we got to follow the call out. This is a call out. What is it doing? It's calling out whatever's in the circle. So if my scope of work is reflected in the circle, which pretty much is from rough carpentry to the roofing membrane, I have to go again and follow here because there's more detail at this call out at 2 over A 450 that I don't see here. So let's go to 2 over A 450. This is 450 and image number 2. They're never in order and I never can find it. All right, let's see. Here we go. So that's the very top, right? So I'm the roofer. So I'm going to check it out all the way up. I don't do insulation because I'm the roofer. I don't do studs because I'm the roofer. I don't do the top and bottom plate because I'm the roofer. Continuous 2x8, I don't do that because I'm the roofer, but I do continuous aluminum sheet and it's secured with the ring shank that I think I do that, right? Membrane flashing to top of parapet, I'm the roofer, I definitely do that. And the cap, I do that. And cut any wood 2x, nope, don't do that. So yes, it's very important. If you see your scope of work in a call out, the previous picture, you got to follow it because you have to make sure that you are including everything within plan view, section view, detail view. All right, so that is the roof plan, a short, quick review of what we look at when we are reviewing the roof plan. Who would review the roof plan? The roofer. and the roofer installs all of the roof finishes. So what's important is where are there holes basically in the roof, and show me as the roofer how you want me to secure and close in all of those holes. So here's the roof drain and overflow drains, and so it's going to point to everything. It's got our flashing right there. So if we're roofers, we know exactly what all this stuff is, because here is, oh, this is our overflow. So this is our plumbing system that goes interior to the building and then out to the sewer system. So we never see that. And here's a roof hatch. So now it's going to tell us 1, 2, 3, 4, all the way to 11, every little piece and part that we have to make sure we account for, so we can make sure that there are no leaks at the roof hatch. Okay, so as the roofer, that's what we do. We look at the roof plan, we determine what type of material, we figure out how many square feet of that material. We look at the section view, but just in case our material has to go up the parapet and over the parapet wall, additional information, where are the holes and how do we secure them. Okay, so that is a brief overview of the roof plan. If you have any additional questions, problems, or concerns, please go to our website, www.sfjohnsonconsulting.com. At the lower right, you can fill out the form for online office hours, and we'll go over this more in detail with you on one-on-one. But as usual, thank you for joining us for this wonderful class, and we will see you next time. Bye-bye. Hello, everyone, and thank you for joining me. My name is Stacy Johnson, the owner and operator of SF Johnson Consulting and Construction Services. And then in this snippet, this is part of a multi-series class where we go through a set of construction documents, the architectural set, structural set, the civil set, and all the MEPs. And we go over them sheet by sheet for what's important, what you should be aware of, and basically what we're looking at. And in this snippet, we're going to be talking about the MEP site plan. Okay, and this is, we call it the MEP site plan because it is not a full site plan. It is a site plan that gives you kind of like a salad bowl of what is in a full set, a full civil set. The site plan is just one of the sets that is comprised within the civil set. And so this is like I said, it's a compilation of all of the trades just on one sheet. It's not used for detail, of course, because we need all of the individual sheets that would be comprised within a civil set. So this set or this sheet gives you contour lines, right, which would be found on the excavation page of a civil set. It's going to show us the parking lot striping and curbs and gutters, which would be found on the concrete asphalt plan in a civil set. Okay, so this is just one sheet that gives us kind of a little bit of everything that we would find in a full civil set. And then we're going to just go over each thing individually and give you an idea of what we're looking at. And so the first thing we'll start off with are these lines that look like mountains. And those are called contour lines. And those are the lines that kind of that do represent the GPS coordinates. If we were to go out there and do a survey, well, that's what they mark each of the contour lines, and it basically represents the height and the depths of the land or the dirt at various locations. And so what we're looking at on this MEP site plan are just a few of the contour lines. And what I want to go over is just how they represent, because the contour lines, again, represent what we would find on the excavation plan. And on the excavation plan, what is that? That's telling us how much dirt we need to either cut or fill in order to properly level the land to build, in this case, our restaurant. So the way they represent the contour lines are what they found on the survey. When they did the survey, the number that represents the number that, or basically before number, would be the number they represent here in the parentheses. Now, 588, we don't care what that means, but, we just want to make sure you know that before and after, right? Excavation, what we found before, and then what we need to either cut or fill to build our property or build or level it out for our foundations, our parking lots, and all of that good stuff. So the way they represent before is in a parentheses, and the way they show what we want as a result of the excavation is represented in a square. So this is for this particular architect and what they use to represent before and after, but it'll similarly be represented in some kind of way. Or we can see that before is represented by the broken lines, dot, 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 the broken lines, and where after is represented by the solid line. Okay, so in this MEP site plan, they're representing the heights and the depths of the dirt at various locations. Before is the broken line with parentheses. What they want after they've done the excavation is represented by the square and the solid lines. Okay, so that's one thing for our MEP site plan. Another thing is underground utilities and how they represent underground utilities. Well, underground utilities are represented by, if they're existing, they're more of a gray color. And so we see here UT, so that tells me that's an underground telephone. They have G, it should be underground gas, but it's a lot of inconsistency in this set. And then we see underground UE, underground electrical. And so how do they represent utilities that are underground and that are existing? They represent those by a gray broken line. Usually, new construction is always represented by a black line, meaning this is the new construction as opposed to the existing. So if I had to look at this and say in words, we see that the SD, which stands for the storm drain, is black, where all of these other ones are more gray. So that would tell me maybe we have a new storm drain coming through the new construction that is junctioned or broken off from the existing storm drain, something like that. Okay, so underground utilities are represented by gray lines if they are existing and broken gray lines. So you just have to kind of look what's the existing, what's the new, and kind of determine it that way. And so if we look all around this set, we'll see that we have, now this is a black S. So even though the line is gray, the line is probably telling me it's underground, yes. But the black is telling me it's a new storm drain or sewer drain that's coming into the building right here. So underground utilities, again, if they're already existing, broken lines, gray color if they're new, more solid lines, or maybe a broken line, but a darker representation of what it is. And so here we see that there is and we know that these are new because, again, this is new construction. So we have 8-inch water, then we have the underground electrical, underground telephone, underground something else right there, 4-inch gas. Okay, so broken lines tells me it's all underground utilities, and they're all coming into the new construction. Okay, that's another thing for our site plan that's typical of a site plan. One thing we always have to make sure we do correctly is to make sure if we're using a digitized software that the set of construction documents or the plans are to scale. Okay, so what does that mean? That means if we were to print a full legitimate set of construction documents and we used a regular ruler, for every inch that we measured with that ruler, it would really mean that we are measuring 20 actual feet in real life. Okay, so you always want to make sure if you're using a digitized software that you confirm that the scale of the set that you receive is correct. And so here on our digitized software, we just tell it that for every 1 inch, it's 20 feet. We set the scale, and then we take a measurement somewhere on that set to confirm that between 20 and 40 should be 20 feet. So we know that this set is to scale, so when we do our measurements, we know that our measurements are correct. All right, on any set of construction documents, you're always going to have keynotes. And how the architect represents the keynotes is really based by architect to architect. But it's very important that you look at each of the keynotes individually, match them up with the keynotes that are on the page, so you can make sure that you covered everything on your set in terms of your full scope of work. Every set's going to have keynotes. It's important that you find a methodical way to make sure that you have covered every one of the keynotes and what you need to do. Okay, so let's go back. This is a very generic MEP site plan. It shows us some of the things that would be on the site plan all on one sheet. Remember that the civil set, sorry about that. The civil set is the set of construction documents that show us everything, all new construction outside. Okay, so when you walk outside any door of the office or home, what you're looking at is everything that you would find on a civil set if it was to be built new. What do we see? We see asphalt, concrete. That would be a separate plan. We see, we wouldn't see, but we see the results of underground utilities, right? We would see fire hydrants or something like that, or manhole covers or something like that. Well, that would mean that there are underground utilities under our feet. We would see trees, right? That's part of the landscape plan. That would be a part of our civil set. We see, again, in this Popeyes, we would see parking lot striping, handicap symbols for parking lots. We would see all of that. Again, all part of that same asphalt concrete striping plan that we would find in a full civil set. What they did here was give a little bit of underground utilities, a little bit of excavation, some parking lot striping, asphalt concrete, all of that on one sheet. Okay, so this is kind of like a salad sheet of what would be comprised individually in the civil set. Let's see what else. Scales, always important. Make sure you are always on the right scale when you're doing measurements, or else your measurements are not valid. And the only reason why we had to have a set of construction documents is that we can look at them, we can scale them, we can make measurements, and from those measurements, we can apply value to this is how many linear feet of new wall, this is how many cubic yards of concrete, and we can give a cost to how much it is to build this thing. Okay, so again, an overview. Underground utilities are represented by broken lines. If they are new utilities, you'll see black. If they are existing, you see gray. The contour lines are represented by the heights and depths of the dirt. Those are the contour lines when we go out there and do the survey. And it's showing us for the excavation plan what the height and depth of dirt is at certain locations, and then what we need to do to get it to the height and depth that we need it to be at, so we can build our storm drain basins and build our new foundations. Okay, so that's what we're seeing here. Make sure you read all the keynotes regardless of the sheet. And one thing, and we'll go over individually, we are looking at this sheet from a plan view. And you will look at any of the sheets from one of 4 different views. You'll look at the sheet from a plan view, which is the view from above, and we'll have a separate class detailing each of the 4 views, how we look at it, how we flow from one to the other. But on this sheet in particular, we're looking at anytime you see the plan. See, we always say, send me the set of plans or whatever, but really that's a misnomer, right? Because plan is a particular way that you're looking at the project. It's a perspective of the sheet for which you're looking at the project. The plan view is the view from above. It's as if you're hovering over, you're flying over, and that is the most basic of the views, is the plan view. Okay, so from the plan view, we get a good idea of the site plan. But if we were to, say, build the walls of the Popeyes, the plan view doesn't tell us the height of the walls. It doesn't even tell us the thickness of the walls. So we need other views, other sheets in order to give us more detail. All right, so this is the MEP site plan for our set that we are breaking apart and analyzing. And remember, if you have any questions or concerns, you can always go to our website, www.S as in Sam, F as in Frank, Johnson Consulting.com. Fill out our online office hours. We will make time at your convenience to go over anything with you to make sure you understand. Thank you very much for joining me this time, and please make sure to return. You're awesome, and well, I guess that's it. Have a wonderful rest of your day. It's not wise, and there's 10,000 tricks of the trade if you have to do that. But as professional estimators, we always take our time get the measurements, get a reliable cost book, because I can't emphasize enough that if you are going to perform competitive bidding, especially in when you're talking about $100,000, $200,000, $1 million projects, you really want to give the best detail as possible. You really want to know how many man hours it's going to take. You really want to have your details squared away. You really want to know how many man hours is it going to take to lay the foundation, as opposed to the driveways, as opposed to the curbs and gutters, because you, as a professional contractor, even as a general contractor, it's really important to keep on schedule, to keep on time, and to, if you're on schedule, you're going to be on budget. And if you're not, then you're not. And so it's important to, as a professional estimator or a professional contractor, it's important to get a good estimator, or to get a good combination of a takeoff software and a material cost software, and a good formatting procedure, which really, if you have one nicely formatted Excel spreadsheet, you can use that over and over and over again, just edit it. And that's what kind of we recommend. We have specialized Excel spreadsheets for every trade, because we know what should go on in every trade. If it's a HVAC system, well, yeah, we have to include the cost to balance the system. If it's a plumbing system, we have to include the cost for the rough ends, if it's from the ground up, that kind of stuff. So it's important to be able to have a professional format, and Excel, of course, has been used forever. So, and Microsoft has professional contracting spreadsheets, and all of this new stuff that they've created over the last 10 or 15 years to help you create very detailed formatted estimates. And really, sometimes the general contractor will give you the format they want you to use, because they may break down, they want the cost for the curbs as opposed to the driveways, as opposed to the foundation, or they may want the rebar cost, right, separate from the concrete cost. They want the concrete totals in cubic yards, right? So you got to be able to do all of that. So what are we looking at? This is a coffee shop, so we have a very small plan, easy to review, very small plans, but this is our site plan. And so we know that our driveways, right, and our walkways and all of that, and our curbs, and we have to measure. Make sure you measure, because the cost is going to vary if it's a straight curve as opposed to the curved curve. Okay, and so we're going to review this, and I'm going to come back with the full takeoff for everything based on this, right? The keynotes. And so dowed concrete curb. What's the dowed? We got to look at the detail, right? So we have to look at all the details related to, and the civil set's going to give us everything, right? Painting the concrete, the symbols, but we're for concrete only. So we are only looking for everything related to our concrete scope of work. 5-inch light duty concrete pavement, 6-inch heavy duty, medium duty, light duty, sidewalk. Okay, so what we're going to do for our purpose is just get a square foot total for everything, and a linear total for all of the curved curves and straight. And then we're going to come back and see what the takeoff looks like, right? So all concrete, and we can start here. I'm just going to start, and of course you got to start by knowing what your scale is. And on a civil set, the scale's always somewhere special. Here we go. So for every inch, right, it's 20. 1 equals 20. I agree. And then now I can use this. No, I don't want to use the segment tool. Let me cancel that. Let's use our ruler. Okay, so between 1 and 10, this should tell me it's 10 if the plans are to scale. Now that's close enough, right? All right, so yeah, so I'm just going to look at my keynotes, start with what's easier, and then I'll just call it curb 1A, curb 1B. And then later I'll look at what the construction of it is. And then we've got the 19. You got to make sure you know what that is. Let's look at see what that is. Okay, 2-foot V-notch curb. We'll just note that. Okay, and so let's see. We go from a 1A to a 1B. And so I'm going to say curb 1A. And I won't make this boring for you. I'm going to do it all. Boom, boom. And so everywhere where it's straight, I'm going to do all my straighties. And I think maybe at this point here, it starts to curve out. This is a 1A. Do it to here. This one. Because our form work is going to have to curve. And that's an extra cost for all of that and the labor involved, right? Okay, so we won't make this boring. We'll leave it to there for all the straights. And 1B will be the same way. Now, we need cubic yards of concrete. So what we do is we measure how many square feet and times it by the thickness. That gives us cubic feet. Divide by 27 gives us cubic yards. And so, or did I say divide? It's pretty much division. When you multiply by 6 inches, you're dividing in half. Same thing, right? And so we do with our square feet. Let's just say let's just do this right here. And we'll say, which one is that one? Medium duty concrete. So we got an area tool on that one. MED duty. CON. We don't have time to type a lot. We got a lot to do. Right? So that's all of this. And so we're going to go back and do our curves. But then we're going to just do something like that. Make it all nice. And see, that's our curve. So we're not going to include our curve. You want to do something like that? We just try to stay. And I can make it more curvy. You just got to pan in to get on the curve. Okay, so let me pan out a little bit. Okay, so I'll leave it at that. Let's get a little bit more over here like that. And then we're going to go like that. Construction. It's fun, right? It's like coloring. It's like we're coloring. It's fun. When you have good tools. We'll go a little over. Okay, so we got the little apron, right? So if we had to do, and then a good cost book is going to, you have a different cost for the driveway apron. That's what that is, right? So how many square feet is that? Oh, 554. And so times 6 inches, right? So we would basically divide that in half, 250 plus another 25, whatever, cubic feet, and then divide that by 27 for cubic yards, because you buy concrete in cubic yards. All right, so that's this, we'll just do that all over the place, right? All over this set for either this concrete pad, this one. We don't care about the striping because we're not doing that. Okay, if we were doing that, then we get our linear tool and measure, because it's to scale. So whatever I'm measuring here, I'm going to be measuring all concrete. Now, we have to go to, because from our plan view, right, we only see the plan view. We don't know the reinforcement details. We don't know anything else, okay? So we have to make sure we go to see note below, 15 feet, control joints. How would we do that when it's not shown? Pretty much this is how you do it. control joints in any area, what you're going to have to do is take your segment tool, because it's not shown, and I'll call it CJ's. I'm just going to have to go from one end till I get to 15. Stop it there. Okay. And then the control joint is this way. Same thing. Every 15 feet. I can stop it here. I mean, you're not going to be exact, but you are going to be close enough. Or you could just measure the whole thing, divide by 15. Right? Divide by 15. Do the whole thing, divide by 15. Because that tells you every 15 feet we need to. And then just do whatever this is. 30 feet. So divide by 15. If I got 15 of them, 15 times 30 feet, that's the length of the control joint, because you got to measure your control joints too. And if they're not shown, that's the best way to go about doing it. Okay, so that would be for our civil set. And then we go to we'll do the whole thing. We'll come back with all the totals. And you need to join me, because for all of we have the new program for every trade. So we have for framing only, for painting only, for concrete only, for electrical only, $9.99 a month. You join me live. You send me questions. You have your own set. We'll set up 45 minutes. You get that twice a month or as much as you want. I love teaching. I don't care. But the whole point is to give you continuous access to everything related to your trade. So it's not only the estimating, it's basics. It's if you want to get your trade license, then we go over the particulars on that. The basics, anything related to OSHA and construction, right? We know what's related to the concrete and OSHA, right? The silica dust. So we teach you all of that, give you information about that to stay safe. So it's basics, three pretty much aspects. The basics of everything. So basics could be anything from basic takeoffs to form work basics. And then estimating, of course, what we're doing here. If you have any questions, we'll answer your particular questions for work that you have of your own. And then OSHA-related topics related to concrete and doing the trade of concrete, how to keep you safe, what's the PPE, what's the standards, what's the violations, all that kind of stuff. And for $9.99 a month, you can't lose. What am I saying? What are we saying? So let's go to, now that I've done my commercial, let's go to the foundation plan. And this is a little project. So they have our roof, and this for roof, for frame, for framing only. We'll talk about that one, and the for framing only, and what all this is, and if we have fabricated metals. Is this fabricated metals? No, it's 2x12s. Beautiful. Okay, so here's our top of slab with number 3 bars at the 18th. Placed 1/2 inch clear from the top of slab. Provide 10 mil vapor barrier. Okay, so yeah, this again, same way we did the control joints. If we want to get the exact how many linear feet of the rebar, we know we're putting it is it both ways, each direction, each way, EW. And so if we do how many linear feet for this way, right? Because we're talking about the rebar that's going to go this way. And so we say we have however many linear feet that is, divide by, turn it into inches, right? Turn that feet into inches and divide by 18, right? Because you're placing every 18 inches, so you're going to take that length divided by 18. You know how many positions you have to put the rebar, right? But then you're going to put it this length, right? So that's the rebar for this length. Opposite is true for the this rebar, right? You measure how many linear feet, whatever that is, and it is 38, 39 linear feet. So we know 39 linear feet turn into inches. Divide by 18 inches. That's going to tell us how many placements our rebar is. And then those many placements times 18 feet. So you just that quickly have done your rebar totals. Okay. And so what's our continuous footer look like? We need to go to image number 1 on a S 2.0. Let's see. I knew I'd go past it. Image number 1. So that's our typical footer. Oh, that's the hold down. Wait, hold on. Yeah, image number 1. Oh, there we go. Wrong page. Image number 1. Continuous footer. So, yeah, let's do this rebar, right? You have 2, number 5, continuous top and bottom with the number 3 stringer at the 18s. Okay. So you can figure that out. We got to figure out how many linear feet of continuous footer first, right? And then our continuous footer is 1 foot 6 inches by whatever this height by 2. Okay, so we can break that down by how many cubic yards of concrete, and we can determine how many linear feet of number 3, number 5 we need. Very easy and very much fun if you're a nerd. Okay, so for concrete only, we got to be able to do that for our cost estimate. All right, so we got to also, because if the reinforcement is our deal, right, we've got to figure out how many of these we have as well. Anchor bolts, because that's going into our concrete. That's part of our reinforcement for the structural framing. Okay, and so that's why they give you these section views, so you can do the boom, 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 and do the math by the 18-inch, 3-inch, whatever it is, and do a very accurate takeoff. Okay, different section views going to give us different information. Okay, so we've got to make sure we look at each one individually and do the takeoff based on what we see. Okay, so for concrete only, for this from the ground up, we're going to look at our civil plan, right? Civil is going to give us all of our concrete driveways and asphalt and curbs and gutters, and really the supports for all of our signs and things of that nature. All of that has to be looked at. Okay, our support foundation for our handicap parking signs. That's part of our scope of work too. So have to be aware of everywhere your scope of work is going to show up, but most definitely from the ground up project, you're going to review the full civil set. And then of course you are the foundation, right? The bottom of the building. And so you got to make sure you are looking at the foundation, all the section views, so you can determine how many cubic yards of concrete as well as how many linear feet of each of the types of rebar and the vapor barrier. And for excavation only, we'll go over how we determine how much to cut and fill, right, based from that grading and site plan on the grading plan, and depending on the condition of the site, we may have a site demo plan, we may have a, who knows what kind of band. We may be doing more than just grading, right? Light grading, we might have to do some serious excavation based on all of that. So join us here online at our website every day, usually Tuesdays through Saturday, where we review everything, every trade, every aspect, so you can be excellent at what you do. Thank you for joining me, and I will see you next time. All right. So we are going to first complete the floor plan, because we are going to complete a cleaning estimate for a client. And also, we are bidding on this ourselves, so we are always looking for all of the trades, framing, painting, drywall, in this case concrete, because this is from the ground up, and we'll also be reviewing the foundation. And so let me make sure we have everything set before we start. And the first thing we always want to look at is the scale and make sure we have the scale correct. And so what we're going to do right now, before we do the foundation actually, because this is pretty much easier to do, we're going to look at all of the call outs, detailed call outs for how it's going to probably, who knows what it's going to show us, because I don't try to look at it too much in advance before we do the estimates. And so we're going to first see, we have wall here, but a lot of the building is a storefront. And so what I'm going to do is I'm going to separate the storefront walls from the main walls. I know that I'm not going to deduct an opening, because if this is the storefront walls, which we will look at the exterior elevations to see how that's built and everything, I'm going to separate these walls, the exterior walls, load-bearing walls, from our storefront window walls, because the wall portion is going to be totally different than if there are no openings or if it's not the storefront. And so I'm going to call it storefront. As soon as it catches up, I think it's doing too much. Oh, come on, computer. What are you doing? There we go. Storefront walls, because those, in terms of construction now, it's going to be a lot different than the other walls. And then I am going to go through the door there, because too, we're going to do this for final cleaning, and the final cleaning is going to really have to clean both sides of the windows, and so that's good for that too. Looks like these are also some kind of window. It's a drive-through most likely. All right, so let's just finish the exterior walls. Am I spelling right? I really don't care half the time if I'm spelling right, because I know what I'm doing. All right, so we're going to go through that door. We're going to go through all the doors, because in terms of the wall framing, it's waste, and usually if it's less than 16 feet, we go through it anyway. And so we'll go there. So those are our walls. Now, what we're going to do first, let's see how our walls are built. So 4/A 4.1 is what we're going to look at. Image number 4, page A 401. 401. Image number 1. So that's image number 2. Are we on page 401? Yeah. Okay. So all of the walls are pretty much this height to the roof joist, and this is the exterior. And we'll look at what the keynotes tell us. 2, 5, and 7. 2. Frame wall with that insulation, typical, so all the way around. 5. EIFS system, typical, and 7. Pre-finished metal coping at, so that's for our roofer. We've got that there. Parapet. So we have exterior walls that are, let's scale that, 1/4. This is very easy because it's a shell, so it's not really much that we need to do. And so the walls to the roof joist, that's what I want to know. Wall to roof, because our framer needs to know how many square feet. 14.9. So we're going to have to say 15. We'll just give it 15 feet for the exterior walls, because they are different at different heights, because it kind of goes up. So let's just do that one too. I'm going to use a dimension tool for that one. So just to the roof joist. 15 feet. Okay, so, and then the parapet wall is an additional, because we'll need that for 6.5 feet. Okay, so that's pretty easy. That's easy. All right, so going back here, we know that we have exterior walls of 145 feet times our 15 feet, we say. So that's how many square foot of framing, and we will have a professional estimate created from this takeoff. Okay, and so the framer's gonna do that, and let's see. I mean, we need some. Let's see. We gotta have some more details as far as the walls. So that's the storefront area, all of that window, and so final cleaning. We know we're gonna clean both sides of that, so that's easy. And then there's some other drive-through window. And so if I'm going to do windows real quick, which I probably will do real quick, let's do the scale 1/4, because we need to tell our windows, our final cleaner, how many square feet of window they're going to be cleaning. So this appears to be window, and if it's not, it's okay, we'll deduct it. And you know what? We're going to go through all of that is going to be window, because we got to clean it off anyway. And this is our exterior elevations. And so that appears to be window. We got to clean the door anyway. And all of this is times 2. And then we get this little window, because we got to clean both sides. And so we'll make sure we have 4, like 2 no, that's 3 elevations. Make sure we have all the exterior elevations, so we can make sure we have all as many square feet of window. And you know what? We're going to include that whole thing, because we have to wipe all that off when we do our final cleaning. Okay, so let's see if we have any other. One more page that has just the. No, that's the building sections. So that's okay. So, okay. And so we have that. We have the framing, roof plan. We're going, parapet cap. So now we're the roofer, and we need to know, we need a couple things for the roofer. First, we got to scale it. And we have to tell the roofer how many total square feet of, I think it's TPO roofing, because we are going to bid this. So if you would like to bid this with us, we would love to have you join us. And we do all your estimates too. When you work with us, we do all your estimates. And we always win. Why? Because we are the best. And then what we do too. So we have the total square feet. But what we want to also do, remember this is a share. And so we're going to deduct roof openings, because our roofer asked that we always deduct the openings from our square foot total of roofing material. And so we're going to make sure we do this. Isn't this exciting? Isn't it so fun? All right. These people in our country, they need to just do estimates and be happy. Oh, let's go over some more. All right, so the purpose of that is, we're a little off, but that's okay. And so roofer, and so we just finished what the framer needs real quick, right? And hood below, this is a big one. And what we also need is, because we'll have to flash the same openings, we really need to know how many linear feet, but because my tool I did point by point for each of these squares. See how that square is 28 linear feet? That square is same thing, should be, right? Same 28 linear feet, so I don't have to do the linear feet. I could just do that. 7, I'll round that up to 8 linear feet. 9, 8.5 linear feet. 12 linear feet. 43, so that's the flashing. See how great that is? And then let's see what number 9 is. Solar ready. All right, so I'm just going to do this area just in case they need it for something special. Just in case I'm asked to price a solar panel or solar something. Solar is weird. how they price it. So I'm just going to do that just for the heck of it. So I'll know. Just in case they need it. Oh, look. Forgot that. Look at that. Openings. Deduct. So let's go here. Oh, wait. I got to remember I didn't go all the way to the top. So my linear is going to be off. Or look. Bam. Yep. Let's start over. I don't know if I did that on the other ones, but you see the point. Okay. Oh, I did that again. Okay, so we know what Stacy should have done. All right, and another thing we need to get. We've got roof drains. So we're gonna need the roof drain. We're gonna need the flashing for the roof drain and overflow drain, and then we're going to need a perimeter for the parapet cap and flashing. Anywhere that window or wall meets roof, we need to consider we need some flashing. So if I would have done my roof like I did my openings, I would know how many linear feet this is, and I would not have to do this, but I'm doing it anyway. Alright, so what we don't know really yet is about our walls. We did the measurements, but we got building sections. Okay, so we're going to go here, right? Because 3 over A 413 is probably going to tell me the makeup of my wall. 3, 4, 13. 3. Yeah, see, here are all of our walls. So for our framer, what are we doing here? Okay, that's the foundation. So we'll do all of that from foundation. Rough carpentry, that's a 6-inch bottom plate, or 2 of them. Well, you can always measure and make sure. That might be a little. Oh, that's about the same. Is that the same? We'll look on the foundation, but we know that storefront, height, tube, wood stud walls with that insulation, vapor barrier on inside face of wall, refer to structural for stud spacing. Structural for stud spacing? Okay. EIFS system over waterproofing over exterior sheathing. Alright, so we got that. We have all the measurements to do all of that. And then all of the window, we have to measure maybe the length of the windows for our bottom plates, for our window top plates, for our wall, whatever you want to call it. And then this is on our structural, any headers, everything above the window is the structural member, it's the header. Below the window, it's from the framing, kind of rule of thumb, but kind of not. And we know that the insulation is going to go only to the top of the building. We don't need to insulate the parapet wall unless it was a second floor, right? We only insulate where the humans are. Alright, so, and it's interesting right here. Whatever that is, that's a lot of little things. So we could look at, right? Call out 5 over A 421. Let's do that, because when we do the actual takeoff, we need all of this and be able to determine how many linear feet. So how do we go from the takeoff, right? This is just a section view, but when we're at the floor plan, oh my God, I'm so glad. I almost thought I didn't turn the mic off. Thank you. All right, so when we're at the floor plan, right? So we have to measure if we have a detail call out, say for instance like this one. Well, this is referencing because we know where the section view is. We know it's only in reference to this opening in the door. We know that this is only referencing this because it is within the call out. And so if whatever I see at 2 over A413 to do the takeoff, well, I'm going to measure how many linear feet from here to here. Let's say 6.5 feet. And so I'm going to go to 2 over 413. Next one, 2 over 413. So if I go to 2 over, where is it? Right here. And so I know that that was 6.5 feet. That section view was 6.5 feet. And so I know that I need 6.5 feet of this, 6.5 feet or whatever that is, 6.5 feet of this one, this one, this one, this one, and whatever this is. 6.5 feet times the length of that is what I need, because every section view, right, is broken down. And so when we look at the exterior walls are all 4 over A401. So whatever I see at 4 over A401, I mean, pretty much all of the exterior walls are this construction. So I go to 4 over A401. I go to 4 over A401. 401. 4, right? Where is it? It's up here. Okay, I go to 4 over A401, but then again, I'm the framer. This doesn't tell me anything about my framing. So I'm like, oh, okay, here we go. Because I'm the framer, it's got to tell me more specifically about my framing. I can use this like I did before to determine how many linear feet. This doesn't tell me the wall framing, the drywall, the insulation. But if I go to the call out, if I go to 1 over A413 now, I get more specifics. 1. Now I know how my wall is built, because there's going to be some arrows hopefully pointing to my wall. And I know all my exterior walls are the same. So if my arrow's not pointing here, then my arrow's going to be pointing somewhere else, and I'll know it's the same wall. What's the and it says, oh yeah, look at the structural for the type. All right, so we go to the structural. That's the roof framing. Okay, roof framing is structural because the roof is a structural member. So the roof framing, not the roof finish, is structural. And so we'll look at this. We'll see what this is when we get there. That might be this afternoon's presentation. Girder truss. And let's see what we got. Oh, prefabricated truss by others is this. Now that's what I like. Is when I have a set of plans that show these things. Okay, so it only applies to structural framing. And so when you have these little things, that circle and that arrow, that tells the framer that only within here, only this part is whatever this is. So now we have it again, right? From this all the way to here, and then again to here. It looks like it's continued because it's not giving us any description. Yeah, so it's all the way through. So it goes from here to here, and then it connects here, all the way through here, and then again, just like that end, it tells you a different type of truss. And so what that means is from here to here, where one arrow begins and the other arrow ends, you got to look and find where they're trying to tell you about the trusses. And that would be, maybe they're breaking it up. No, yeah, they're breaking it up. We got arrows. There we do. Okay, so here we go. Let's start again. Because like I said, never look at this until I look at this with you. Right, so from arrow to arrow, we have this type of truss. 1 or 2 ply prefab trusses by others at the 32s Da 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 da. Okay. And then we go from, we have a new arrow, this arrow, to this arrow, and we look for the description. There we go. 1 or 2 ply prefab. Da 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 da. Then we got another set of arrows from here to here, and we look for the description. So, when it comes to trusses, if they're putting them every 32 inches, then if you want to know how many you need, then you have to go 32 inch. Oh, wait. Yeah. Feet? No. Heck no. What's wrong with me? 32 inch. One. 32 inch. Another one. 32 inch. Another one. Da 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 da. All the way through. Okay. So if you want to know how many, because you can't. I mean, I guess you can. I guess you can. You could do it just like you do. Oh, you could do it the same way. How many linear feet? Turn it into inches. Divide by 32. Either way, the first way is so much more nerdy and special. All right. So we always gonna look for our headers, right? So this is a metal header, H hollow structural steel, and the dimensions. Okay, and usually with fabricated metals, the last digit on like W 84 by 115, the 115 tells you how many pounds per linear foot that can hold. And so if you know how many linear feet of that type of truss, then you know you can determine how many pounds, and they're determined price by the pound. So I rarely get those these days. All right, so we were looking here to see what kind of framing we got there. All right, here we go. Trusses, hold down, number 2s, wall, number 6. Oh, look at that. Tells you how many linear feet. That's nice. All right, so let's see. Our walls are, we already know they're 6-inch walls, and we know that they're wood framing, so it's not really difficult to determine what we got here. All right, so our post, all right, and our columns are hollow structural steel. Then we look at 9 over S200 to see the makeup, and that's prefabricated, I'm sure. No, we got a couple of wood posts. That's nice. Okay, and so we do our framing takeoff for the structural framing. Our posts, what, are 15, 16 foot? So we just assume they're 16-foot posts with all this extra stuff to hold them down, embed them within the concrete. Slab on grade. We'll do that. That's easy. 6-inch concrete foundation wall with number 4s at the 16th vertical and horizontal. That's nice. So number 4 goes this way and that way. So you do it the same way. The number 4s are what, at the 16? Yeah, every 16 inches. So how many linear feet multiplied by inches, right? So you change that into locations, times however many locations, and then the length. That's for the ones that go in that direction. And then you do the same thing for the ones that go in that direction. For the how many linear feet of how many linear feet of number 4. All right. What else? Because our whole purpose is to do this for the final cleaner. So they have to clean, wash down the walls. They're going to have to probably polish the slab on grade, or wipe it down, or buff it, or whatever. So we're going to measure how many square feet for our concrete person too of slab on grade. And we'll look at the foundation section views for the footer, the stem wall, all that stuff. All right, but for now, we're going to say slab on grade. And we know it's 4 inches. So it's the whole kit and caboodle. How old are you? Old enough to know all my construction principles. All right. And see, now I'm going to go all the way to the top so I'll know my footer minus that piece because I didn't go up in there. I have 211 linear feet all the way around plus what is this linear feet? How do we read this, boys and girls? From hash mark, there is one, not one, but from here to there, the number in between is an extra 9 feet, 4.5 inches. So that's our foundation. Almost 23, right? 100 square feet. All right, so let's get rid of that real quick. Cut off the light bulb. All right, so if I'm doing, so my final cleaner's got to buff out 2,300 square feet of concrete. And let's go look at some foundation section views. That's our main wall there, structural, external wall there, and we know any walls that are connected to the footer, the concrete footer, is going to be a structural wall. So that is a structural wall if we have framing connected to it and bolted into it. And then we could look at section view 10 over S201 for the configuration of all of that. So you got a lot of section views here and a lot of call outs. So the concrete person knows basically how to form the concrete and more importantly how to place the reinforcing steel. Okay, so let's look at 7 and 6 over S200. S200, 7 and 6. Oh, look at the beautiful stem wall there you've got. So per plan, I think our plan told us. I don't know. Per plan. It told us. Okay, so we've got from here. It's a 6 inch, I think. So this would be a foot stem wall. So I know my stem wall is a foot by 412. Right? So I know how many square feet of concrete. But then concrete is in cubic yards. Right? So how do I do that? Well, I always turn cubic feet into cubic yards by dividing by 27. Remember, with concrete, you have 3 dimensions. You have the length of the wall, which was 411 feet. You have the width of whatever it is, 1 foot, 6 inches, whatever. And then you have the height, which is 6 inches. So that's 3. Multiply those 3 together, then you shall have cubic feet. And then divide that by 27. That gives you cubic yards. So now, if I know my my plate, I got a single bottom plate, stud wall, and sheathing per plan. We've got some shear walls, right? We got it when they talk about that. We've got also the waterproofing, okay, exterior footing. All the different section views for all the different concrete configurations. That's a stem wall at stud wall with 12-inch foundation wall. That's nice. Reinforcement per plan. I don't know what plan they're talking about because this is the plan. So, I don't know. We don't want to spend a lot on our stuff here. We just do that and let the pros figure it out. All right, shear walls. Here we've got our steel. I can't even think. I just said it. Our structural steel headers, post beams, plans. So we don't have a construction defect. Okay, so this is typical base plate. concrete wall connection, HSS column. Okay, so 2 times da 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 with hex nuts, just 2. It don't say per side. Da, 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 okay. All right, so we don't mess up and the thing don't fall, right? It don't fall. There we go. Isn't that pretty? All right, so you know what you're doing when you can look at your detail views. You got to be able to get down to your detail views and do the math. Okay? Very, very important. Stem wall or continuous footer, stem wall. Then we got the hooks here. And then we also have individuals running the whole perimeter, right? This is a section view, so we cut it and then we broke it apart, and this is what the interior construction. So this is what we use for our detail material quantities. You got to be able to look at the detail views and determine your material quantity. So I've done that. So my foundation, I want to do my foundation. See, those are my 2x6s. And then, see, I have different continuous footers, see. So when you do your takeoff, let's just do that. Did we already? Yeah, we did, because we did. See, when you do your continuous footer, you want to make sure you break up your sections, because you want to go back and look at each of these, because what? The continuous footer is going to be different. The stem wall is going to be different, thicker, smaller, whatever. And then what we got here? Look at that. So we have a 4-inch slab on grade outside the building with da 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 da. Okay. And here too. So that's the additional concrete work. And then okay, so let's look at that. 9 over S201. 201. 9. All right. Okay, so yeah, that's slab on grade. So what do we do in this case? So you have this this is almost like, this is kind of different because it's not like this. It's not as clear when you want to determine how many square foot, when you want to do actual, like how much. So with me, here's real clear. This is about, what, 6 inches. This goes from 6 inches to 12 inches. I'm going with 12 inches. Sorry, I'm just going with 12 inches stem wall, because I'd rather have more than not enough, right? So to do the takeoff for this, you have this stem wall, this continuous footer, this stem wall, and then the flat portion slab on grade. And then, yeah, you're going to do dowels to match the slab reinforcement at the 24s. I mean, 24s, that's 2 feet. This thing isn't even 2 feet long, so it's probably at both ends of it. This one right here at the 24. And this is a continuous, right? So it goes all the way through the slab. And this goes these two go all the way through the slab. And so however long the slab is, right? Let's go back. Where were we? I don't know. So yeah, so however long the slab is, that's how long that continuous is, which is this. I like that. So when you can go from, what, plan view to section view, and the section view will take you to detail view. You'll make sure you have a good thing. All right, so we're going to take a break and see what else we got. Remember, this is a shell, so we don't have any. This is all the MP we got. Mechanical plumbing plan. We just have stuff when it's a shell. We only have things that are coming into the building. So even the electrical plan, right? Just coming into the building. No lights, no nothing. Just the panel even. I don't even see that we have the panel. I don't even see the panel. It's like just put the lights in. There's no panel. let's see, data junction box, lights. Yeah, we just putting everything in. So when there is, unless we have to provide temporary power, of course we will. To make sure this works, because it's just like junction boxes for the drive-through. What's one? Yeah, civil set. Yeah, we were looking at that. Civil set, site demo, civil set, utility plan. So that would be our power coming through. Water, water. Where's power? Water, water, water. Let's just look on the list. We're looking for transformer. I'm not really looking. Now I'm gonna look. Sewer, grease, trash, existing, cap, this, that, and something else. No? Do we have a electrical site plan? Other than, okay, no. So we just, panel A. It's just right there in the middle of nowhere. That's beautiful. Okay. So yeah, we'd have to get more details. Oh, there we go. So yeah, shell, of course. We just had it floating out in the middle of nowhere, but it's gonna be somewhere. And we have to look on the, I'm sure it's shown on the utility plan. We'll find it before the lunchtime presentation. See, so shells are nice. And again, let's go back. There's a whole bunch of stuff. This is a shell for a Chipotle. See, it doesn't even say, but yeah. This is a shell for a Chipotle. That's going right there. Next to it, I think that's a hotel. That's coming up later. So, yeah. We've got everything the civil set. Yep, 23. Right, that's what in the pickup window. And then we're going to do site demo this afternoon. We've got some site demo. We knock out some trees. And that's always nice. And we're going to stripe the parking lot. Yep, it's going to be beautiful. And we got some concrete, site concrete now, other than the foundation, right? So the site concrete is going to be on the civil set. Grading plan, I'm not messing with a grading plan unless it has the section view of the earth, and it does not. So when they send me that and ask me to do the grading estimate, nope, unless it has properly been section viewed so you can see what the existing elevation is in comparison to the one they want. And that's the only way I can do it. Now, they'll sell you a $1 zillion program that'll take all of this and claim they're doing it, but nope. I'm good. Erosion plan, what's that? All of those fences, all that stuff. That's not really fun. But what is fun is the utility plan. So we'll do all of that later this afternoon. But right now, we are going to make sure we have everything for our framer and our final cleaner. Oh, you know what? For our final cleaner, I'm sure they're going to have to, I don't think they'll have to wipe down the exterior. Other than, oh, look, we left out windows. That's why you don't, come on. That's why you don't do the estimate in one day, boys and girls. Because it's not due till Wednesday, I don't think. All right. And so the framer has what they need. And all of this is that parapet wall. I'm assuming that I did get the roofer. Let's see. Fix what the roofer needs. Let's get the roofer valley flashing. That's always fun. And we don't care about spelling. And we want, and then sometimes we have to have this insulation like doubled and tripled over. Because right, valleys are lead us to water flows from the valley. Might be some parapet walls. I mean, some crickets in here, but it doesn't really say specifically. And that is another opening for our roof latch, roof thingy, so we can get on the roof. And that's where our ladder is on the other side. All right, so the roof is good. And what's 8? Let's see what 8 is. Canopy. Okay, we're not going to install that. They have a vendor. All right, so we have our floor plan. And let's go to, because we got our walls. Let's see. We got the roofing membrane. So not only do we have it that the 23 square feet, we've got to have the roofing membrane up the parapet wall too. So that's an extra. Let's scale that. 3/4 equals 1. Sometimes this stuff be off, but we'll try it. So the parapet wall needs to be in it. Oh, we did say it was 8.5 feet, right? Well, no, not the parapet wall, not the no. Let's see. And if you had questions, you couldn't ask me because I'm not paying attention. But next time we'll make sure we do. Let's see. Dimension, because we want the additional, and we'll add that too. Because it's got it. They say go up and over, right? And that's the insulation. So it's going on top of the insulation. So we can stop right there. Extra 5 feet. So an extra 5 feet times 411. So that's a lot of extra TPO that you don't want to mess up or forget about. All right. I think we got it. I think everything. Insulation, we're going to go up the, let's just do this. Insulation. 14 feet. See, 14.5 feet times 411. Right? That's the perimeter of the building. We got pretty much everybody's takeoff. Just have to do more in terms of the foundation. Or let's go. Where are those shear walls? That was annoying the way that they did this. That was annoying. Let's see. Where's foundation? Where is it at? Okay, no. Another thing, framer needs to know all of our doors, so we only have 3. And then the storefront, that frame really questionable. The aluminum storefronts, usually the framer doesn't provide anything but the hollow metal one, so, that's another question. But if it's only the hollow metal, then it is one that is 3 feet 6 inches high, wide by 7 feet high, easy hollow metal, and only has to install that. And the storefront person most likely would install the storefront. All right, so we're gonna take a quick break until 11 a.m. to let it all sink in. We'll be right back. Okie dokie. We're going to get started again. Had to take a little longer break there. All right, so this is a shell for a Chipotle located here in lovely California. And we are looking for contractors to bid with us. And as you can see, we'll do your estimates for you. This is actually a shell of the building. It's not a complete interior fit out, build out, whatever they call it there. So it's just the site and the shell building. Makes it real easy. And so now this afternoon when we present at 2 o'clock, we're going to do more of the pricings because we pretty much know how many square feet or whatever. We're going to do all from assembly pricing. So we won't break down the individual pieces of, say, like the foundation until, we're ready to win and do the work and get an actual pricing. Foundation, assembly prices should not be much different than individual pricing of the concrete, the rebar, and formwork, and all together. The assembly price should not be much different. So, all right. So here's the demo plan. So it has it's in the middle of somewhere, and we have to get rid of some things first. And so let's see what 5 and 6 is. Protect. Let's see what we're removing. All right, so 1 and 2. Okay, so removing a tree, it's important to know the size of the tree. And we go by the diameter of the stump or the base of the tree. That diameter of that tree, that's how they base, either putting it in or taking it out. Okay, so that's important to know, and if you don't know, it's important to find out. So can you just pull it up, right, with very little effort, or you got to cut it down? Those kind of things makes a huge difference in the world of construction. All right, so 1 and 2. Where's 1 and 2? Do we have a lot of 1 and 2? Not really. Okay. And so if this is dirt, then we don't need to saw cut anything. I don't know if it is. This may not be. On this side, this is probably. So we'll saw cut that. Include the price for our demo for saw cutting this, because this is really attached to something, just like maybe this is. I don't know. But what's the scale? On these plans, scale's in a funny place. Here we go. 1 inch. Oops. Cancel that. We don't want that one. 1 inch equals 20. There we go. We agree. And so we're going to demo. We're going to 1 and 2 first. So we're going to demo curve. And in this case, we don't care if it's curved or straight. In the afternoon session, we will be going over actual pricing. Okay, so now we want to saw cut because we don't know. We can delete that if it's no need once we win. So we think that's connected to something, but that doesn't appear to be. And so now we're going to demo. Let's just say remove concrete. We'll assume that it is reinforced, because that's how we price it. It's priced different if it's reinforced. So we're going to go like this. There we go. Oh, come on, don't fail me. 1 and 2, 1 and 2. Yeah. Okay, so there's a lot of protect. So we just going with what we see, remove and see. That's a big tree. Those are two big trees. Huge trees. So we have to get more details. But remove tree. Big. We'll assume that it's the biggest that the cost book gives us. I think that's 24 inches around. Alright. I think those are the only two trees. And what else is remove? Remove is a property line per lot adjustment. Remove property line. I don't know that applies to us. That's property line is just set. Yeah, we'll ignore that one. Let's see. So you give some time for field verify. Violate and sewer main exists. That's the appropriate. Okay. So we give an hour for that. Field verify location. Hour. Field verify. Hour. Abandon it. That's easy. Remain. Quit claim. Given to. Not our problem. Protect. Now the protect part, we can do some protect. Go into the specifications on how they mean protect. And we have those, so we'll bring those up in the afternoon, 2 o'clock Pacific time. Remove sidewalk panels marked. Remove sidewalk panels. Oh, okay, like those metal panels probably. 17 curb and gutter. Okay, because we can measure that. Oh, look, we had more one. Alright, let's go back. Get this one. Alright, so what do we say that was? The panels are 16, 17 is curb and gutter. Let's put, okay, there's the panels. 17 curb and gutter. Oh, that looks pretty. Seventeen. Then we'll just 17. Alright, and panels, sidewalk panels. And about 3 hours of side. 3 hours of verify. And that was sidewalk panels. That look kind of big. I don't know what kind of panels those are. Those are concrete. And if they are, we'll do them different once we know. And that's all the remove there is. I'm not worried about protect. Let's see, 14. Yeah. Okay, protect utility box in place. Okay. Boulders surrounding the site. There's a separate one. I guess you just gotta go out there and see if you find some boulders, because they're not marked. So wherever the boulders are, get rid of them. That's extra. So all those are things to note, but nothing to really, be able to determine, because they're not shown or anything. So that's like removing a tree, depending on the size. that one. All right, so we go all the way down. The striping plan, really, we just, now, they have a stripe. Let's see. We need a concrete plan. That'd be nice. Yeah, there we go. Existing is A, so let's do pavement C, sidewalk D. Okay, let's do D. Now, when we price the sidewalk, you can price the sidewalk by the width of the sidewalk, or we can do it by square feet. So that looks to be about a 3 to 5 foot sidewalk. So let's see. We're going to do it both ways this afternoon when we come back together. We are finished here at 11:30, which is about 10 minutes, and whenever we don't finish here, we'll finish then. All right. So scale, always scale. And I know my sets of plans are always good, so I don't worry if they're correct. All right, so sidewalk was D. Let's see what the width of the sidewalk approximately, because you can price it by the width of the sidewalk. It's a 6 foot, not even 6 foot. I go by 6 feet because it's closer, but then you got to make sure they're all 6 feet. See, that's 6 feet. D, now that don't look 6 feet. See, that's 5 feet. 6 feet, what's that? Is that a special? That's a special kind. That's a curve right there. So, can we use all 6 feet? Or just measure how many linear feet? You know what? I'm going to use 6 foot wide concrete sidewalk, because that's how we price it. 6 foot sidewalk, instead of doing it by the square foot, because that's we're going to do everything assembly price. So it goes pretty much from here to here, and then from here to there. We're going to just give it extra. Always give it extra. Here to there, and then there. To the front door. D. Then we got some right here. Might as well finish it up right there. We got some right there. That's the patio area. I'm going to make that different. And do we do all D though? Yeah. Alright. So that's the sidewalk. And then C was parking pavement. We're going to do that by square foot. We'll call that parking. And then we'll go by cost book wise, what it tells us. So we're just going to include all of that, because this gray is different. It looks like we have curve too. We need to determine how many linear feet. Lots of. Oop. Oop. Going to Nilly Willy. Yeah, let's just cut it off halfway right here. Cut it. Because I like to be as precise as possible. Alright, let's cut it off right here. And you know what? Yeah, we got a lot of this and this small little curve. Let's go. Let me just go. Look at that. forgot I'm recording. Like, hey, it's still quiet. Except for the clicks. There we go. See. Let's see. Yeah, then we gotta come through and do the more annoying curves because we're a little bit. Ooh, look at me. Look at me. Alright, see? Alright, so striping plan. Why don't you call it the concrete plan? The heck? See, they broke it up in phases, but we don't care. Let's hope we're not asked. Alright, we got some arrows, so we do those separately, but in the meantime, what is B? Sidewalk. No. Did I say what? I said B. Drive on pavement. 5 inches. Then 9.5. 9.5. Da da da. We'll look at the specifications, but I mean we could go on, right? What's G? We'll do G. Let's just know what it is. We got 5 minutes for this session. Oh, good. No. Landscape. That's good. That's where the flowers are going. Flowers, flowers. What's M? Bike racks. That's nice. Let's see. It's going to be flowers. Okay. Because that's still in this area and not in this area that we didn't include in the sidewalk. And you see right here, it's a little thicker. Right there. So we're going to say that's probably let's see. You don't have to guess. Well, what is this one? 4 inch. Okay, well that's the smaller one. Let's delete that one because we said they were all inch feet, not inches. So let's do this. This is still our 6-foot concrete up until we get to there. Then it's a 4-foot. 4-foot sidewalk. From here, right there, let's go over a little bit. From there to, okay, and then yeah, we'll fill all that in while you're gone. And then A, we'll fill that in while you're gone. And then G's the landscape is A. Oh, good, existing. We don't need to fill that in. And so that should also mean we're not striping that. Let's see. Yeah, no. We're going to say we're not because it's existing. So we are going to always exclude existing striping. All right, so that is the Monday live edition of What the Heck is Stacy Doing? All right, so this is our shell. Right, so when we come back, we're going to complete the little pieces of the takeoff we didn't do, and more importantly, the pricing. So if you have any questions between now and 2 p.m. Pacific time, make sure to email me at education@sfjohnsonconsulting.com, and I'll see you this afternoon. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and I have a little information I wanted to give to our small GCs and large DCs. so they can get ready for 2023. There's a new class we were given. I'm not sure how old this is, but I think it's awesome. If you've ever been to a live construction site, it's a very dangerous situation going on there most of the time. And I could understand that because when everything is active, everything is moving, it's hard to be able to make sure all of the damage and the hazards are actively where they're supposed to, right? But it's really hard to do. And so without a plan, it's even more difficult. So OSHA has a class that we are going to be presenting. It's a 4 hour class, though, and we will present it in 1 hour segments, and it's called Design for Construction Safety. So again, basically, the architects, engineers, they build the set of plans for us to put everything together, but they don't really put into mind or have into mind in their design how we should stay safe, right? So they have pretty much no involvement in the actual construction project process, right? So what we're trying to do is give a course that gives a couple of course objectives, and one is to be able to identify the factors that contribute to construction industries and fatalities on site, right? General industry, right? We do things in a static, pretty much in one building. Things never change. We're just walking back and forth. But with construction, scopes of work change, equipment comes and goes, and of course, if you're in construction, you know what I'm talking about. And so this class helps the project managers, helps the construction people, helps the owner not be sued, because this is an active thing that we're doing here, and we're teaching you to identify the factors. We also explain and analyze how worksite hazards happen. Okay. We discuss the hierarchy of controls for construction hazards, and that's very important. And then last but not least, we provide a methodology and with examples, okay, and design features to show you, again, to keep your site very safe. So if you go to our website, we have some information where you can sign up. This is a class. It is $4.99 per company. You can invite as many of your people as you like. So if you go to Safety Lane over here on the right side, the other left on the right, you're going to go down to Design for Construction Safety, enter here, and then you'll be taken there, and the objectives again, why it's needed, what we go over, methodology, kind of give some information, what the class is all about. And if you choose to sign up, please do so here. You can choose your own day and time. So for instance, what we ask is you pick the same time. So the class is available from 10 a.m. to 2 p.m. Pacific time. And so pick the same time, but you can pick different days. And it's just first come, first serve. And we're trying to fill up that class and the OSHA class. Now, if you so choose to take this class, you will get OSHA 10 for free. Okay, so keep that in mind too, which you want to be all wrapped up for your safety for 2023. Okay, so if you have any questions, please email me at education@sfjohnsonconsulting.com. Stay safe and let us help you do so. Have a good rest of your week, and I hope to talk to you soon.
Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and we are going to review this site work estimate, takeoff actually. It's already complete because I thought the better way would be to do it first and then review each point as we go on. So remember, this is an existing location where we're adjusting the site work. Here's the building envelope, but we're working on all of the new site components, which the gray represents asphalt. This represents new concrete. We have new wheel stops. There are new upright curbs and
So we break those into straight portions and the curved portions. And we had to reinstall the gate. And so basically that's what this is. And install a new walkway. And then all of the control joints we have to count for, all of the parking lot stripes, and that's about it. Oh, and then we have a new dumpster area at another view because the foundation is different. So really with this, because we have a good cost book, we'll start with curbs. So the straight portions, and then we added the curved portions. Okay, and then let's see, the concrete, we broke it down. So that portion, and then we had to do all of the, we'll get that later. Then we did the wheel stops. All right, so you count those individually, and it's based on all of the, so we always have to go here, right? So for instance, the curbs cost book, it'll vary from 12 inch, 18 inch, 24 inch. So we had to make sure, you look at your details for each, so you can make sure you're at least pricing it for the right things. But if you went by, you could also price it by a cubic yard of concrete, right? The height, the depth, and then we measured how many linear feet. So those are the 3 dimensions. And divide by 27 to give you cubic yards. I turned cubic feet into cubic yards. Okay, so you could do it that way, or our excellent cost book. That's not our excellent cost book. Our excellent cost book will give us, and then do we already have it? No, we did the paving. We were on the paving because we already did the estimate too. So we're gonna, where'd it go? It's down here. We'll put in curbs so you can just have an idea. Because we'll come back with the actual estimate. Let's go here and let's pick this one. So those are asphalt, and those aren't the ones that we chose. Let's go here. There we go. So curbs, the vertical curb, see, that's what we had. Vertical curb, upright. Okay, and ours was 6 inch by 18. So we had the straight portion is $9.77 for the material, cost unit 0.119, and then the equipment, and this is all per unit, so right, per linear feet. And so depending on what we had, right, concrete apron, I actually could have used that for that. I might go back and use that for the concrete apron part. And then we had the walkway. Okay, so that's for that as far as the pricing. But yeah, so you just got to go through. So this is asphalt, and let's see how they do the asphalt. That's interesting, how they price the asphalt. Yeah, so asphalt for roads, assembly cost, on-site roadway, base and aggregate, the binder course. Alright, so and the compaction, square yards. So we get square feet, divide by 9. That'll give us square yards. Okay, or it gives us to us per square foot. Okay, so that's what we have for this portion and that gray area. So where's my asphalt? Okay, and so this was already, it didn't give us anything for that, right? This part, so we didn't account for that. Unless there's something we need to do, then we'll go back and fix it. And then, of course, let's see, the handicap stripes, these right here, and then the symbols is 2, and then these we had stripes for. Let's take that back off. I don't know what they were trying to do with this, if this was actually something that they were going to paint on, and these were something actually that were actually going to get painted. So I'm like, number 8, how do they figure that's 8 and that's 3, and is it? So I'm not really clear, but we did account for these broken striping, and I'm like, okay, this is number 1, 1, 2, 3, 4, 6, 7, 8, okay. And then I also assume that these numbers will get painted everywhere, even though they only put it here, so that might be a lot of assuming, but we assume that that is the case, the broken striping as opposed to the solid, and that's what is reflected on the estimate. Okay, so all of the stripes, we don't need that one, and we got all of those handled, the curb, the asphalt, and this is a 4-foot walkway, so we could price it by assembly by 4 foot wide, but I believe we did it separately. It's on the estimate. And then the dumpster pad. So this is the enclosure, but then the pad itself is on. More details about the pad is here. There are the bollards, 1, 2, 3, 4 of those we've accounted for, but then also the thickened slab edge. And the bad part about this is that it's not to scale, so it looks like the thickened edge is around the perimeter of the whole thing, as well as 2 going along the middle portion, going along with this. So that's basically how we price that, is that as far as the thickened slick over here. And so that's how it was priced. And then we'll see that we've included the rebar in there as well. And let's see, and then all the expansion joints and the control joints, and I think that as far as that's it for this. So this is basically the full takeoff for that. It's pretty simple. And if you have any questions, please email me at education@sfjohnsonconsulting.com, and let me know your thoughts. And please also subscribe. We will get the estimate portion shown to you, just so you have a good idea of all of the man-hour totals for each and the pricing, because like stuff like the bumper pads are precast, one cost. It includes the dowels that hold them in. So we'll go over that, and yeah, hope you enjoyed the presentation, and please give me your thoughts and email me, and I'll see you at the next class. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and we have a project right now that we're looking at. We are doing the structural set, and of all the sets, the structural set is the most challenging. For me it's a lot of fun because it is so challenging and complicated, and You just can't rush if you're going to do a good job. You just can't rush a structural set. So what's in the structural set? Well, our set, we have the foundation that is going to extend from the existing foundation, and everything that's going to go with that, all of the column pads. So we have some that are A of a certain make, right? They're all going to be different, and we'll go over each one. We have B's, and then there's a C, and then there's these things and how they're connected to the column pad. And then we have this thing with the call out, right? And these are paint booths. Okay, but again, it's just the foundation. And then here we have something that's existing, or no, it's not existing. This is something new that we're creating or making on the existing foundation. And so that's the foundation. So the structural set is the foundation. And then we have the equipment platform. So there's a new awning that's going to be put on there. So we have this structural member, hollow structural steel, 8x8 by a quarter, high and low. So it's on, should have an elevation view, probably doesn't, but it has the section view so we can see what it is. And then here we have new, in our demo, if you can remember, we demoed the railing because this was a patio. So we demoed, I believe, I'm not sure, some part of it was. So we demoed everything, and now we're going to put in 2x10 joists at the 16ths, and then there are some additional structural members that have to be there, LVL beams. And so we have all the measurements done for those. And then the roof framing. We have new roof framing, and it's a new parapet wall that's going to be created right here. And so we have that section view, and we can start just looking at details there, because parapet wall is in the wall we extend above the roof. And so we have it at the front of the building, I believe. And that's at CS/301. So we'll look at that. And all of the section views. And so let's start with the foundation. And so when we do the estimate, we'll come back with the actual estimate now. First thing we see, we'll start here and work our way around, is the section view of A/S201. Well, that's telling us the foundation and how it's built on this stretch. Okay, so this is A, whatever that is. And then here it gives us another section view to show us how that column pad B is constructed. And so we'll look at A and B. Now, remember when we do the section length, whatever we see at that section view, it's that many linear feet. So if we have a top plate, bottom plate, if we have bolts, if we have whatever, it's going to be based on that linear feet. So if we put it at the 8 inches, whatever, it's based on each section view's length. The column pad really is, it may show us how this is connected to the column pad, but the column pad is just going to be a particular width times the length times the depth and the structural steel that's going through it. And so we'll do a takeoff for each of, so for this estimate for the structural, it'll be a takeoff for linear amounts based on each of the section views. So the GC knows how many linear feet of section view. See, now C is not really a section view. It is, but it's not for us, because again, it's just showing us how the makeup of this A column pad is. But this A/S201, that's the full length of that wall. So whatever we see there, and also footing, that's the concrete footing. That's the full, that goes, I think, here, here, and here. And so whatever we see there, and there's a list of all of our, so what is a what is da-da-da, what is B, what is C? Alright, so, right, structural notes. Alright, so column pads or pad footings. A is the size 2 by 6 by 2 by 6, so square, you know, but by 3 feet 2 inches deep. Okay, so those are pretty big column pads. Alright, that's huge. It's a 3-foot deep pad. And so, yeah, we have to determine, and here's the reinforcement. So we have 3 both ways, 3 number 4s equal top and bottom, but here they get pretty big. 8 by 8, 5 by 5. Now this is, oh, no inches, 3 feet, 3 feet, 3 feet 6 inches. That's odd. No, wait, what am I doing? 2 by 6 by 2 by 6 by 3 by, okay, got it. Too many, got confused. So 2 by 6, 2 foot 6 inches by 2 foot 6 inches by 3 feet 2 inches deep. So they're all 3 feet 2 inches deep. 5 by 5, 8 by 8, 2 6 by 2 6. Hey, what the hell are you looking at? All right, and then the anchor rod schedule. Okay, so that's what we'll use for that. So just very quickly, because we'll zip through them. We already did the length, so really it's just a matter of going ahead and now showing and putting it on the estimate and seeing how much it cost. All right, so A over, and let's go to S201. A, everything's pretty much on S201. And so we have A, where do we have A? Over here. So that length is going to be this configuration. So what do we have to do? We have to determine the length. This is the length of the wall, and this is the slab on grade, and then also we have to determine the length of the rebar. And so this rebar is going to go into the existing foundation at this point. This is the new foundation, and number 4 continuous all the way through that length that we measured. And then this set, so now we have the length that's continuous. Then we have this one, this pretty much upside down L shape, and this upside down L shape. Number 4, and it's 4 feet long. We're going to place them every 16 inches at the exterior. And then, so this connects the existing slab to, well, the existing slab to the new one, and then this one right here, number 4, 5 foot 8 inch down at the 24s. That's this one by 3/16 all the way down that length as well. So each one of those things will be listed individually on the estimate under that section view based on the length. Okay, so that's pretty much what we have to do for every one of these. Determine, and because we have all of this is the existing, and this is the new. It should be, it is, yeah, the new, the existing, and you just have to match that rebar. So it is time consuming, but you have to do it based on each of the section views, and that's what's going to be done. So based on each one of those section views, F, S2, or whatever F was, and then even though we have the column pads, that goes continuously through. But we have to see what is CF1. We didn't go over that. So we have to create that too on the estimate line by line, whatever it says that is. So let's go to that. And that is the continuous footing, 8 by 3, 2, with 3, number 4 continuous all the way through. So that's easy. We have to create that, price it. That's easy. We broke down all of that now. Let's look at these, whatever this is. Okay, so these are whatever this is. I don't even know what this is. But we know we're going to have some new trench drains through it. Existing slab. And then let's look at 3 and 4 over S201. 3 S202. Alright, so that's this. Was the center, and then the section view from here. So basically we have to always, when you have a new slab and an existing, you always have to do this deal right here. So it's giving us that section view. And now what's weird, this is not a very good set of plans, and I just want to show this. Gee, here we go. I just want to show this. Alright, so now we call these out. Okay, so let's take a look at that. I didn't even measure the length because it's on the other page. Okay, so we go to, those are the paint booths. So that's these. And so the section view right here, we have to know how to build these walls. And so what I've figured out from this section view, when you cut your section view, it says if you cut it right here, now you're looking based on the arrow, you're looking this way. And so if I'm looking, if I cut it here, here's the section view. And so now basically my walls, it's a base of whatever this tells me, 8-inch, and with 8-inch walls, that's the new slab. That's how we connect it. But then I was like, what is that? But then you just have, it's like it's just floating. Well, remember when you have two different scales, you got to make sure you're on the right scale. This scale is 3/4 equals 1. This scale is 1/4 equals 1. Oh, well, I figured out this is this, the bridge. And so it's showing me in the bridge. So if I use scale 1/4, remember this is a section view of this, and it's going through this. So it's trying to tell you if you cut that and you stood in that gap, that's how you would see the layout of the concrete. But this was the more confusing. I'm like, what the heck? And so this is actually what they call the bridge right here. That's that 8-inch reinforced concrete bridge. And so it's this whole area, and I know that it's that, and I measured it. It's like, okay, 5 feet 3 inches. So I put it on that scale. It's on that scale, 3 feet 3 inches. And then I put it on this scale, which is 3/4, right? It's like sometimes it's rocket science. It really is. I said, okay, well, oh, 5 feet 3 inches. Okay. So that must be this, right? So if the scale is different, remember that it's going to be a different length based on the scale you use. And so I'm like, okay, so it's just this long, whatever the heck that is, and why they stopped it, because it looks like it's this. Is it just that long to where it's like a concrete connected to only here? It's like this still don't make no sense the way they have it laid out. But I just assume what I'm going to do, just so you know, Sean, for that I'm just going to do this area right here. But as far as whatever the heck that is, I'm assuming it doesn't is it the whole? I don't think so. I'm not thinking it doesn't go any bigger farther than I don't have it going here because that's longer than 5 feet 3 inches. If I did it all the way to here, so just right here is that what we're pricing and everything for that square because it's very odd. And so that's just about it as far as the takeoff numbers, and everything is just all about a number. And then once we put the actual estimate together, we'll go over the line by line items that made up each of these things that we will have on the estimate. And even right here, this is 1 over S201. It's like, okay, what do we do with that? 1 over, says field verify existing pit lock. Okay. So I'm like, okay, I'm assuming because it's dark. Usually stuff in dark colors means new work. So it's dark, which means this is something it's new, even though it's on the existing foundation. Just like this is new on the existing foundation. But I don't know. So I'm going to account for that too. So 1 over S201. Where are we? So 1. So I'm assuming this is all something new that we're doing. No. Yeah. Drilling the holes. And this. And covering it up with whatever that is. So. Okay. That's for that section view. And I'm assuming that's the existing slab, but this right here, I'm not quite sure what we're doing with that. It just tells me what the reinforcement is. I'm assuming that's concrete. Yeah, foundation section. So we'll be doing that, adding that to again where we see this right here, 1 over S201. So yes, foundations are very different, very difficult. Okay, and but we're gonna get it done, and we'll be back with the full estimate. Any questions, please email us at education@sfjohnsonconsulting.com and look very shortly for the full cost estimate on pretty much everything you see here, and then it'll be explained even further. All right, thanks a lot. Talk to you next time.
Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and we are going to go over just some parts of our foundation or structural estimate based on our takeoff that we did a few days ago on this auto repair location. And we did the takeoff, and all of that is on video already on the channel. And so just want to point out how we would actually put the estimate together. Now, remember when we're doing, now, this is the structural set, and so in the structural set, in our set, you know, it could be a number of things depending on what you're doing, but this is a existing building that has an extension of a metal framed building, and so we're basically putting in the foundation that the metal frame building is going to sit on, and then once it's built, then we have all of the interior framing that's going to go inside the building. And so structural is all of the foundation,
all of the roof framing and everything related to this. If there are headers and posts and beams and column pads, then those are the things, and all of the reinforcement, all of the rebar or the mesh or whatever. And so I'm just going to go through some points. This ended up being a $1.5 million estimate for the structural set. And so just want to go through, when we're doing, we come across, and I, methodical, I do everything just in line. And so the first part of a structural set is the foundation. And so, yes, we did broke down the foundation based on the section views and individual items. So we had quite a few different, 12, I believe, of the smaller column pads they call A. C, B, I think we had 2 or 3. And we had a bigger one, only one of C, and a bunch of other rebar. And then in here, in the new building, we had the paint booths that had 8-inch foundations and 8-inch walls. And so that's a whole different section. This is the call out right here, and then the full slab, which was 4,000 and some square feet. And so won't go through the full estimate because 1.6 pretty much $1 million worth of estimate we have right here. And so there's just some portions like, and again, when we have a existing building and we're adding on to it in terms of the foundation, you're always going to have some portion of the dowels or rebar basically that you are going to go from the from the new foundation into the existing. And so this was this section view F over S201. So we'll look at that one first. F as in Frank over S201. So we go to page 201 section, and I always get that's 301. So F as in Frank. And so yeah, now you can imagine for each one of these section views we had a line item on the estimate, but we'll just look at a few. And so this is the existing building, this is the new building, and so anytime we do have that, we're going to have some dowels that secure new to existing. And so yeah, we're going to put a 1/2-inch dowel, 1 foot rod, and times 4.5 minimum. That's how far it's going to go into the concrete on this end, right? At every 24 inches. And so, when you do the takeoff, then you want to figure out, okay, if we got to place it every 24 inches, then if we have, how many feet of that did we have? F over, what is that, 201 or 301? We had 71 feet of that, so it says. And so we'd have to determine, let's go back to F. So if we had 71 feet of this, so we know continuous number 4, there'd be 71 feet, because whatever we see at the section view is that much in takeoff or in length. So 71 feet of that section means 71 feet of that, which means now for our placing it every 24, that means every 2 feet. So we just take the 74, did I say 74 or whatever, 74 divided by 2, right? Because we're placing every 2 feet. And so we have 37 locations that we're going to be placing that. So we know how many of those or how many linear feet of that we need. And so, that's what we had to do for every section view that you see. Okay, and so we had a lot of the, drilling the holes and the column pads now. We got all of this out of a cost book. So you got to make sure you're getting your cost, not from your uncle, but from a construction cost book, where it gave us now the cost per column pad. And the column pads, again, were based on a certain size. Right? These are the column pads A, B, and C. Certain size with certain reinforcements, so we know what size they are. Right? Same with the continuous footer. We know the size, so we go to our good cost book, and it helps assist us with the material cost and also the labor cost, the man-hour units. How long is it going to take us to do a certain thing per unit. Okay, and so that way we can determine how many, everything we need. All right, so section view, that's one part. And another part of the section, or in the structural set, is some of the framing, right? And so we have some beams. So again, section views, we'll look at E, right? E over S301. So let's take a look at that on the plan. E over S301. So 301 E, and that's our section view, and that's our telephone. And so now we know that this was a fun one. So you know, you have to, hopefully you're a nerd. Well, if you're an estimator, you have to have fun doing this. And so you start from top to bottom. So now we have a continuous 2x10 with 3 16D nails, joists at each joist. And we have 2.5, it's late, 2x4 studs at the 16 we have to add, then the Simpson ties, then the treated, oh, this is what I wanted to show you. No, maybe not. Yeah, and then the treated this and that. Okay, and so E over 3, let's look at the estimate. E over 3, S301. Where is that at? There we go. We had 67 feet. Okay, so all the way down. The studs we did by square feet because we knew that they were 1.5 feet high times 67. That gives us that, and then cost book kicks in, and then the Simpson ties. We know how many because we do that same thing. We turn 67 feet into inches, and then we divide by the placement. So if we have to put every 8 inches, we divide by 8. If we have to put every 32 inches, we divide by 32. If we have to put every 16 inches, we divide by 16. Okay, and so that's that. And then there was one other. Sometimes in the structural set, you have to, okay, so that's the paint booth and how we figured out all the rebar and everything for that. There were 2 of them, so we figured out the cost for 1, and we multiplied by 2. And then there was one other, here we go. Now we're at the roof framing. Okay, so the new roof, well, we have to have 18 gauge studs, parapet. We got all of that. Okay, and then we had to have a metal deck, but this is what I want us to look at, is L lintel number 1 in section view A over S301. So let's look at that one, because in that one we had fabricated, well, it will end up being a piece of fabricated steel. And so I want to go over quickly how we determine the cost and price and all of that. So let's look at A over S301. A right here. So at the wall elevation at the entrance. Okay, so we had the studs, the 6-inch or 8-inch metal. That's easy. But then we have these C8 by 1875. Okay, and so these are C-beams, you know, steel. You have I-beams, J-beams, C-beams, whatever. Okay, so this is a C-beam. And basically, the second digit tells us the weight per linear foot. So how many feet can this beam hold, or how many pounds can this beam hold per linear foot? And so that's always the standard. So whatever you see by whatever, that second digit always means. Sometimes you have what, 25, 125, whatever. That means that's how many pounds per linear foot that beam will hold. And so in order to turn that into a price, we have to turn, because fabricated metals are priced by the pound. And so we have to change this into pounds. And the way that you do it is, if it holds 18.75 pounds per linear foot, you just multiply the linear feet by the pounds, the number of pounds, and you have how many pounds. And then you can charge by the pound. So what is that? We'll look at that section view on the estimates. You can see how that's priced. A over S301. A, I think it's farther down. And that's about all we're going to... A over S. Okay, and so we had the C8 by 18.75. We had 17 linear feet of that. And so we say 17 times 18.75 is 319 pounds. And so cost book again kicks in and tells us how much it is, the cost of that per linear foot or per pound. And then you can figure out the cost, and then we have to do some and that is the cost to install. It's the full price of everything for that. And so I got to see why we don't have a and that is the man hour unit for that too. So the cost, so it's going to take 13.40 hours to install that according to the cost book. Okay, so that's the one thing that's kind of different if you're dealing in something other than, you know, metal studs or whatever. When you have fabricated metals, you have to take determine how many linear feet you have, and then multiply that by the pounds per linear foot. You have the pounds, and then yes, the good cost book's going to tell you the cost per pound. All right, so that is the full structural. I mean, all we did was go to each section view, right? We had how many linear feet, turn that into square feet, you know, and it's just crazy. But in the end, it's a whopping $1.6 million. And this is just the base rate. We haven't even added overhead and profits. So any questions at all related to anything you see, please email me at education@sfjohnsonconsulting.com. Please also give us your thoughts on the presentation and make sure to subscribe. All right, and we'll see you next time.
Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and we are finally going to try to get through it, all of the takeoffs and the estimates for all of the 3 projects today. And here we're going to discuss project number 3, which was the smallest of the 3. Where we are looking at, again, the site demolition. And thank you for your comments. Like I said, I've been doing this for a long time, and I should have been on here a lot sooner, giving you guys some tips and stuff. And I'm actually looking to see what I need to do to become an accredited facility, because I do know a lot, and I've been able to help a lot of people. So now it's time to teach as much as possible. So thank you very much for your comments. And I got a couple of emails, and yeah, any questions you have related to your own projects, or if you're looking for a few hours to look at some of your own work, I will always try to take time to do that as well. So what are we looking at? It's an existing facility, and we will in this case, it looks like they're just creating some ADA ramps, and all of the striping that's associated. So the demo, again, always when you have concrete asphalt, you have to do the cutting first. Let me turn off all the lights. Okay, so always we have to, you know, you look at the legend, and now after number 3, it's a little easier, but there's always something that's going to be different. So that's the good thing about doing each one individually and with detailed plans, because yeah, there's always going to be a difference. And so always you have to cut. So we have the saw cutting first of the, and I do it a little different from the, because I'm assuming the driveway is 4 inches where the parking lot or asphalt is 6, and so that would be different. And then the where it joins, I use S6.
right? And only for the pavement, or for the pavement, the driveway, the black asphalt. So that's that one. And then let's see. So I'll cut so that's for that. And then the removal, which is easy. Removing that. And I like to break down everything. And then removing that. And the same thing here. And then the new work was just to build the new aprons, the ramps, and the new striping for 2 of them. And then we have 2 handicap signs on either side. And we had to remove a bollard on this side. Had to remove one, I think. Yeah, remove one on this side and add one over here. So this site work was pretty easy. And then in total, let's see, where is it at? Is that it? Yeah. So in total, altogether, 25,000. So not very big, but nice still. But very simple. See, I knocked that out real easy. So any questions related to this, let me know. They get easier. And so I think I wrote down all 3 because, like I said, once we finish all of the estimates and do everything in total, we're going to show how to do now the work breakdown schedules, what comes first, what comes second, so we can use that to create construction schedule. And let me just show you, cost book. We don't want to see that right now. Let me just, any of the estimates, right? When we do our estimates, when we do the man-hour totals, right, it gives us a total for all of the line items. And again, this is from a cost book. This is not something we're guessing. We're getting the man-hour units from the cost book. That's the best you can do if this is what you do. Just like if you're a mechanic, the best you can do is get the automotive mechanics manual and look in it, and it tells you an hour and a half. But you can do it in 45 minutes, but that's not the point. The point is to get what the cost book says for the man units. Okay, so in the end, it tells you how many man hours for everything. You total that up. So that's assuming one person, right? So one person's going to chunk away, if they work 8 hours a day, going to chunk away at 8 hours of this every day. But if you have a crew of 5, that's 8 times 5, that's 40 hours. So per day for the work. So you chunk away 40 hours every day. If you have 6, you chunk away whatever, 7, 10, whatever. And then you can determine how fast you want to get a job done. So, and their recommended crews for different things, a crew of 5 through crew of 3 to 5 to whatever. And then that's how you use that information to determine how many days it's going to take to do your work. And another thing, too, in order to determine the work breakdown schedule, the WBS, right, everything is done in order. So when you're dropping concrete, what do you do first? You have to do the form work first. So that takes an amount of time. And so when we have the cost estimate, we might have to go into this further and break it down even further. What's the form work for each of the layouts? That's first. So you got to do your form work first, then you drop all of your reinforcements, then you drop the concrete. So everything is in progression. How long is each thing going to take? Well, the total job, is going to take 686.09 man hours. Well, that again can be broken down day to day. Form work takes these many man hours. We use this many people, takes that many days. And then also with that, you can also track how much money are you spending on the labor and the material for that. So that's a project management thing, but it's fun to do, right? Especially if you like doing this kind of stuff. And if you're going to have a management role, you got to be able to do everything from looking at the sets of plans, doing the takeoff, finding the cost book, putting together the estimate. Once you have it together, now I have to break it down to do the actual work, right? Because up to this point, it's just paperwork, but you have to make it come to life in real life, so you got to break it down even more. That's a different class. All right, so if you have any questions, let me know. And look for a variety of other of these based on all the other scopes of work. Oh, and did I write down? Because we finished all three for the site demo. So the biggest one was 198,000. That was a big mistake on that one. So yeah, we fixed the mistake. And for the demo was 198,606, and I'm going to measure how many square feet too, because we want to base it on how many square feet of area or whatever. And then the second largest was 83,563. Oh no, I'm looking at the building demo. That's the building demo. Do I have the site demo? I'm not helpful. Site work. So okay. Yeah, no. The first site demo was 118,537. I don't have the middle one, but this one is 25,546.88. So wow. The last one was a little 20% of the biggest one. 25,000 and 118,000. 19,000. All right, so any questions, email me at education@sfjohnsonconsulting.com. And if you have questions related to anything you've seen or hear or on your own stuff, make sure you email me. I'll get back with you within this, hopefully the same day. And we missed the live class, so I will be recording that at a later time. I was going to do business, how business are organized, the types of business structures. I was going to do that live and got busy and I forgot. So I'll make sure I get it up there. And also I had a request for a design build for electrical. How do you approach a design build project? And if you reviewed the video, I think we have on here of the different construction delivery methods: design, build, design, bid, design, bid, build is one where, right, you just basically design the sets of plans where everything is not already set and there's not a lot of oversight with those kind. I don't really like design build bid. I really don't, because you basically design your sets of plans as you're going along. So yeah, we've been asked for that for electrical, but that's possible because really, if you know the size of the building and the type of building, I mean, if you've done anything this for any amount of time, you can go back and look again at historical data. What is it, a 400 amp system, a 600 amp system? If so, there's a requirement for, certain things. Or you can go backwards. I need 10 outlets in 10 rooms, and then you can do the math that way if you're a good electrician. But, well, I don't do that. So, but yeah, you can do that. But I basically go from similar building, similar type, similar amount of outlets, because there's a recommendation, there's usually an outlet every 10 feet, and I've heard that it's one 2x4 fixture for every 85 square feet of area, so we can figure out how many lights you need that way, kind of stuff, basic. But anything like that, you're going to add like 25% and when you're guessing. So I've tried to say goodbye more than once, but I think I'll do it this time. Make sure you email me if you have questions and look for further information, and visit our website, sfjohnsonconsulting.com. I am the S and the F and the Johnson. So talk to you soon. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, going over now our structural set for the smaller location. Okay, so remember, this is an existing location. The only one was new was the real big one, the Brunswick, the very first one. This is in Akron, Ohio, and this is a renovation of an existing building. So what they're doing here in the existing, they're going to install new exhaust fans, a new rooftop unit, and the associated condensing unit. Okay, and so when they do that, basically we're going to be either replacing probably existing units. I'm not quite sure, but hmm, got to think back if these were all we were replacing existing units. So what we always have to do, this the structural set. That's where we find the roof framing, because structural is it's a single story building, so the roof is part of the structural set. And so anytime we put a hole in a structural member, when I say hole, I mean we could put a door in, right? We put a door in the exterior walls, our structural members, meaning it holds the building up. And so anytime we put a hole or an opening in a structural component, we have to shore it up by structural members, right? And when we say members, that's just a technical term for a 2x4, a beam, a column. Those are members. Okay, and so what we have to do for this one is basically add L frame beams, 4x4 by a quarter, along each side at all the new openings. Because again, anytime we open up a structural component, we weaken the roof basically. And so in order to give the roof the strength back that we took out by chopping out a few of the roof joists, we have to give it back with our beams that it's telling us to do. So a couple of things. Typical is what we use when we want to let the contractor know we're doing the same thing to everything here, but we don't want to keep typing this over at every location. And so let me turn off basically what this is telling us is that we're installing this 4x4 by a quarter L frame everywhere we see this symbol, this broken line. And so wherever we see that, we know we're doing the same thing. So that's why we use typical. Otherwise, you would have to rewrite all of this, put it here, right? Put it here, put it here. So remember, anytime you see typical, it's based on what the symbol or what the thing looks like. And every time it looks like this, or if it looks like that, we're going to do the same operation to that. And so at every one of these pieces of a mechanical equipment, we're going to attach those beams. And so one thing I wanted to point out in how we do the math to determine, because we got to do material quantity, so we measured all of those, and those about, I think in total, like 200 and something feet. And then we have to attach them using one on each side. Okay, L beams, a 1/2 by a 1.5 by 3/16. That length, and that's how we're going to attach it. And so that is about a 1.5 piece of that is where we attach it here and there. And so you want to be able to determine not only how many linear feet of this, which we've easily determined, but how many linear feet of this you're going to need. And so you're always going to want to know what the placement is, and the placement is every 4 inches. And so what we'll do is measure in total how many total linear feet. Like I said, it came up to like 200 and something. We change those feet into inches by multiplying by 12. And then we divide by the placement, which is 4 inches. And so that tells us how many times we have to put that piece there. Then however many times we have to do it. And this would account, because we did the total length for both sides. So however many times we'd have to do it times 1.5 linear feet, and that would tell us how many linear feet of this we need. So that works whether it's studs, nails, anything. If you have to put something at a particular placement, meaning you have to put it every 18 inches, 24 inches, 12 inches, 8 inches, 3 inches, whatever, you get however many linear feet in total, change those feet to inches, and then divide by the placement, 18 inches, 24 inches. That tells you how many times you have to place it And then if it's a particular length, then you say, well, that many times 5 feet, 1.5 feet, whatever. A lot of times for your rebar, you have to place like a 4-foot dowel every 18 inches at the corners of the slab. So that's how you would do that, right? All right. So that's all we had to do for this one. And then, okay, remember how we determine when we have a beam. Let's see. And we had to do the paint booth. We did that before. See, that's kind of what I'm talking about when you have a dowel is 4 feet and you have to place it every 8 inches. Well, I want to determine how many linear feet of number 5 rebar I need, or in this case, okay, continuous, that just tells us, right, it just goes all the way down. So if I have 100 feet, it's 100 feet of that or whatever, right? But the placement, that's different, right? Each way, and the thing about this, when it's each way and it's the same thing, do it one way, multiply by 2. It'll be the same as doing it each way, even if it's different lengths. Even if it's not a square, somehow that still works out that way. It has for me. Yeah, I think it does. Or maybe it's all been squares, but try it for yourself. So it's the same. If you had 25 by 4, right? 25 by 4, and you had to place it every 8 inches. So let's work on this. 25 times 12, that gives us inches, and we had to place it every 8 inches. We divide by 8. That would tell us how many placements. So if that's 25 by 4, it'd be that many placements times what? 4 feet. So, you do studs the same way. It's easier when it's studs. Think about studs, right? If you got a 100-foot wall and you got to place it every 24 inches, then that's 50 placements, and you got 10-foot studs, so that's 50 times 10. It makes it kind of easier to think about it when it's studs. All right, so I think for this, this is really the only structural part for this one was everything at the roof framing. So let's look at the section view though real quick and see. 2 over S01. This is, okay, no. 2. Wait a minute. What's the page? What is it again? Am I missing a page? 2 over S001. Okay, that's the first one. 2. Okay. And so, yeah, that's here. The masonry lintel. And the lintel is here. And lintel is just like a beam, but that's what they use for, it's a technical term for like the steel one. It's like a steel beam. They call it a lintel. So it's pretty much the same. Okay, and so remember, when we're doing cost booking, the W beams, I beams, L beams, C beams, it is the second digit that helps us determine what we need for our estimate. And I believe I got this one up. I think I did. And if I don't, we'll open it. And this is this one. Right, so our fabricated metals. Okay, here we go. W 16 by 36, we have 32 linear feet of that. So we say 32 times the 36, that gives us how many pounds, because the fabricated metals are priced by the pound. Okay, so it's 5,000 bucks for that. Okay, so that's the only thing. And then usually the L beams that are like 1.5 inch by 1/4 inch by 3/16. Usually they price those in the cost book by the linear foot. So you can get, it's like $28, anywhere from $14 to $28 to $32 a linear foot for those smaller ones. But for these that you have to get made, just go by that formula. The second digit determines how many pounds per linear foot, and then you measure how many linear feet, and that gives you how many pounds. So, and that is it for this one. And we will be going on to many of the others, trying to get this finished, not only for you, but for the client, so they can see, make sure, you know, everything we did with the takeoff is complete. And that's how we like to do it, because people are too busy to be sitting around talking. And so we give them this so they can review it on their time, and if there's something we missed, or they can let us know. And hopefully not, usually not, but you never know, everybody's human. So, you know, you look at something 3 or 4 times, especially when you got a bad set of plans, you're like, oh, I think I should add that. It's always better to be safe than sorry. You know, especially you always want to put what you see on the set, nothing in addition to that. Or if you're good and you know something's missing that should be there, then yeah, you add it and you add a note, that kind of thing. All right, so if you have any questions, email me at education@sfjohnsonconsulting.com. Otherwise, I will see you at the next class or the next video or whatever. Talk to you soon. Hey everyone, this is Stacy again, and I want to now go over the very last of the structural sets for our 3 projects, and this is the middle one, and this is the second one, the second largest. And so they pretty much have, in this case, we have some columns now that we have to install, vertical members, and we have pad footings that the columns sit on. And pretty much what they are, 2.5 by 2.5 by 1 foot and 4 inches deep. This is the reinforcement, and so, you know, any good cost book's going to give you the cost per pad for that size or approximately that size, and then you'll adjust the cost book price based on what it says and what, you know, it gives you and what your specifications ask for. And so you may have to run, you know, the specs may say 4 number 4s. Okay, well, you might take the cost book price and then add an additional run of a number 4. So just know any cost book you use, and I was asked which one we use Craftsman cost book. There are a ton of them out there, and they all do the same thing. So the main thing is to use the one that you're most comfortable with, and know that it's not the Bible, but it gives you a good reference for which to build your material list and to get a pretty decent cost. And what I like it for the best is for our man-hour totals, because, you know, we go by what the construction industry says, and what it says is what we do. And so that's why all of our estimates are always very tight, bare bone, you know, and our clients usually do really well. The only thing they have to do, I mean, they can verify the material cost on their own, but what we like is that we can verify that these labor rates are within industry standard. It's not something that, you know, my uncle did it for 40 years, and so he knows how long it takes to install a column pad. Like, okay, well, you know, and you know, you have to imagine there are not very many women in this industry doing this, so I always have to hear that a lot. But, you know, hey, I just go by the books, and we do very well. I would recommend going by the books, okay? And so that's the final estimate for this middle one. We ended up at, well, that right there. For the paint booth, that was, the paint booth, I believe, is like an 8-inch concrete with the reinforcement. So it's pretty thick up there. So that was the structural for that one. Okay, let's go back to, so here are all the structural components, and remember, here's another W-beam, W8 by 18, how we, or by 11 3/8, and then the bottom plate, bottom plates, what we need for here, that is just the third dimension of the lintel. And then how do we measure? Based on how many pounds, right? So we know how many linear feet we have, and then times it by 18, that's how many pounds, and then that's how you price it, is by the pound. And bearing plates, and so let's look at the foundation, this first thing. And so we had, remember this is a renovation, so we had to cut the slab and then build that out. And then our new paint booth, it's also that's the 8 foot, 8 thick concrete, and then the 5 inch thickness, and then all of the column pads. And C1 are the columns, and then the column pads, and all the section views that go with them, and all that good stuff. And so what we do, we mark it out, get how many, the area for the new concrete, the area for the new paint booth, and then how many linear feet. It's just like all the other ones. This one is from the first project. Instead of doing 2, now we're only doing 1 for this one. And we have some trench drains. So let's look at really quickly. A over S201. That's the trench drain section view. 201. The other 201. All right, so A. So what do we have to do here? Start from, well, the length of it, expansion joints. Gotta add that. The trench drain itself, which is in the plumbing set, we'd add that in the plumbing plan. And then basically the rebar. Okay, so same way you put it at the 16s, right? How many linear feet? I think it's 22 linear feet. So you can say this plus that plus whatever, add all that together. So that's what you're going to place every 16 inches, right? So that's, we do that. And then the column reinforcements, how they sit in the column pads. Okay. And then we had to, in a portion of this foundation, drill some holes, and all of that through our slab. C, let's go back to the, let's see where that came from. C, yeah, right here. Okay, so yeah, we had to drill holes every however many feet in both directions. So let's go back to that. C over 201. That's 201C. Yeah. So drill 2-inch in diameter holes at the 4 feet each way. So each way, same. So with this it was kind of crazy. So, you know, just go through every 4 feet each way. We just visually went through it. And then how long is that? It's about 1 inch. We can scale it out, and then we know how many linear feet of hole we have to drill, because, and I think it came up to like 2 feet altogether for, you know, in total. Because you got to know how many. Then we had to do the compaction, and then the slab number 4s. And here's when we're talking about where it tells you how long it is. So it's a number 4 rebar, but it's going to be 2 feet 4 inches every 24 inches. So again, you know how many linear feet of that you have. Change it into inches, divide by 24, and whatever that number is their number of placements. And then, so that's your multiplier. And then you say that number times 2 feet 4 inches is how many linear feet of number 4 rebar you need. Okay, because a good estimator, you got to be able to do your material quantities, and that's all this is. Material quantity is easier to put together than the cost estimate. You got to do all the extra stuff with the cost estimate. Material quantities, you can just boop, boom, boom, knock it out. Okay, so same here. We had a new awning, and so just look very closely. Good set of plans, and then your imagination, right? 1/2 by the square plate, so we need 2 square plates, right? And then for these we figure 4 different locations. Go back and check that. It's like we do so many of the same one. I'm like, oh, did I do that one right? I was like, I'm thinking about the other one. So yeah, material quantity. So 4 locations, because you're going to have this on both sides of the awning. And each of the locations going to have 4 screws, so you're going to have 16 of those. And I think this is an existing wall. Yeah, it's existing, so you got to include the cost to drill those holes for that to fit in. Okay, so all those kinds of things. All right, and I think that's going to be it. Oh, this is our, let's go back to, because it was very interesting. That's our foundation, but here is our roof framing. We didn't go over that. So what's happening with our renovation for the roof is these are exterior elevation views looking this way, where basically these are all the lintels, which is again the metal header. Instead of wood headers, the lintels are metal. Some bracing had to be taken out. Like the other video, we had to do what it said there, took care of that. But this is overhead doors being installed, so they needed the metal header basically to hold the framing for the overhead window installation. And then some other stuff going on here. So let's go to 1A 301. It's right here. Right here. Okay, so they only show us one time, but it's all of the 4 that we saw. So again, this is a C-beam, C8 by 1875. What's that mean? It holds 18.75 pounds of weight per linear feet. So we know how many linear feet times the weight. We can figure out how many linear feet and figure out the price, because we price again those by the pound. All right, so that is the middle project that came up to at $115,000 for the structural components, structural set. And shoot, that's it. So we have videos for all 3. And remember, we're going to go over, once we review all the videos, there's going to be a lot still coming up for each of the scopes of work for each of the 3 projects. Then we're going to add everything up based on the square foot of the project, the different prices, and then we can go forward and start to create for each of the trades, see, which is going to be the fun part, creating a work schedule, a work breakdown schedule for each trade. And what you have to start to think about, especially if you're an estimator and you don't actually do the work, but you know how it's done. That's what a good estimator is. You don't do the work, but you know how it's done, and you can visualize it being done. And so the work breakdown schedule, you'll be able to see, okay, what would the framer do first? You lay out the bottom plates or whatever. You have to determine what comes first, second, third in order to create the proper work breakdown schedule for each trade. So now you can create your budget for each day, whatever. And so that's what we're going to be doing. So if you have any questions, please email me at education@sfjohnsonconsulting.com. Hope you enjoyed this video. Let me know what you think. And please subscribe if you haven't already. And I'll talk to you very soon. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and I thought I would take a quick break on the estimating, just a small break, to talk about some safety issues related to our concrete and masonry standard, which is 29 CFR 1926 subpart Q, which are the OSHA standards related to any the work that you're doing when you're performing the work, or any concrete or masonry work, and some of the standards. And what we always like to do is, first of all, what are the hazards that are possible when you're performing the scope of work? So I've outlined about 8 of those, and they're really easy to take care of. So one of the hazards are chemical burns. So if you are, and I saw a lot of video yesterday where we're mixing the concrete, or we're even pouring it or from the dump truck or whatever, and nobody's wearing gloves, and they're just putting their hands all in the concrete. So proper PE, right, gloves And then you may pop that in your eye, so eye protection and hand and body protection. So the proper PPE would solve that problem. Most importantly, the damage or injury from the silica dust, so respiratory irritations and illnesses, and that is the biggest one when it relates to concrete and cutting the concrete. And the standards that have changed, I believe, in 16 or effective in 18, where you have to use a water feature when you're cutting the concrete. You just can't let the silica dust just go all everywhere, because that affects the worker and the community and everybody. So 3 injuries from improper lifting. So our ergonomics standards would apply. Move smarter, not harder. There's an ergonomics class that I think we have on video too, for you to look over, and what are the standards and what are the things that you should think about. And ergonomics is the way that we move our body, right? And so depending on what you do, you move your body in certain ways that could injure yourself. So form blowout, that's number 4. What is that? That is concrete's pretty heavy, and if the form work isn't properly placed and secured, the forms blow out, they break, and the concrete goes everywhere. I saw a nice one yesterday, but at that point you're just running around trying to scoop up all the concrete so it doesn't harden wherever it blew out. And so you can have injuries from improper lifting on that. You can have respiratory problems, chemical burns, all of that from the blowout. And that's kind of stupid and funny at the same time. Injuries from falling objects, of course. If you're doing platforms, slabs above grade, you have to worry about objects falling as well as you falling. So the proper fall protection training, as well as proper struck by identification, knowing when there's a possibility of a struck by or caught in between. And so those are all things that, if you are taking this OSHA concrete masonry class, you've already taken the focus for the, struck by, electrical, falls, and caught in between. So you've already taken that, so you'll be familiar with the ways to protect yourself from falls. And then lastly, the vehicle accidents, especially with the, when we're dropping the concrete, right, just straight out of the chute. We're backing up the vehicle, we run over somebody, or the mechanism we use to pour the concrete isn't secure and it breaks off and stuff goes everywhere. So, there are, of course, OSHA standards related to motor vehicles. And last but not least, goes kind of with when you're cutting the concrete, you want to make sure you have protection for your ears, protection from noise. So I want to just quickly show this. We have a couple videos, but one is the silica dust is the one that's most important. So I'm just going to show it on this video, and I'll mute myself, and then we'll wrap it up.
Crystalline silica is one of Earth's most common minerals. It is found in stone, brick, rock, concrete, block, mortar, asphalt, and sand. Using power tools on these materials for tasks such as cutting or grinding can release tiny particles of silica into the air. These tiny particles are known as respirable crystalline silica. Workers who breathe in respirable crystalline silica can develop diseases that can be life-altering or deadly.
Traditionally, on construction sites, silica with grinding and cutting produces a lot of dust. It gets into the workers' lungs.
Exposure to respirable crystalline silica can cause silicosis, a disease that permanently scars the lungs. It can also cause lung cancer, kidney disease, or chronic obstructive pulmonary disease, also known as COPD. The chances of developing these diseases increase with higher and longer durations of exposure.
What we're looking at on the left is a normal lung. You can see that the lung tissue on either side of the heart is dark and black, and that means it's full of air. And the X-ray on the right, you can see those white scars throughout the lungs on both sides. That's all scar tissue. It's from a patient with advanced silicosis.
Without protection, workers who are exposed to very high levels of respirable crystalline silica during activities such as abrasive blasting with sand can develop silicosis within a period of months to a few years. Workers usually do not develop signs of silicosis until after they have been exposed for 10 years or more. Once silicosis symptoms, such as shortness of breath, appear, the symptoms can get worse over time, even after the worker stops working with silica.
Usually people who develop silicosis have been very healthy, vigorous people, and they find after years of the disease that they're short of breath, that they can't go very far, they can't walk very far, they can't climb the stairs, they may even be short of breath just sitting still. I continue to see new cases of silicosis, and yet there is still no treatment. So I would like to see prevention of silicosis so that this disease is eliminated from our hospitals and our health clinics.
Silica disease can be prevented by controlling exposure to silica dust. Water can be used to wet the dust and prevent it from getting into the air. Vacuums can be used to remove the dust at the point where it is made.
We stir up a lot of dust, so we try to prevent as much of it getting in the air as possible. So we use these vacuums. But while we're working on cutting the joints out, we create a lot of dust, which we collect in the vacuums inside these bags. Much rather have it in this bag than I would inside my lungs.
Once I tried the new things, it worked well, because at the end of the day, I went home without silica dust in my lungs. I went home clean at the end of the day, and I got used to it.
Gary Sasse's family business is stone carving. His father and his grandfather both died of silicosis.
I believe that our industry here has worked hard to bring in new technology that does help with the silicosis problem. I also believe that there's also room for more education for the workers themselves to understand the critical reasons why they have to be very careful in this industry.
In today's climate, we stress to our customers safety, financial stability, company stability. We remind our men we want them to go home same shape or better shape than when they showed up at work that morning.
OSHA's rule for respirable crystalline silica requires employers to protect workers from silica dust to prevent them from developing disease. Silica-related diseases can be prevented if proper controls are used to reduce workers' exposure to dust. More information on OSHA's requirements to protect workers exposed to respirable crystalline silica can be found at www.osha.gov/silica. For information.
All right. So, most definitely, that is our biggest issue. When you're tuck pointing, you're cutting that, you need to have either the vacuum system or the water feature system to keep that from going in your lungs. And whether they're cutting concrete, shaving down the sidewalks, you see that all the time. So definitely that is the biggest hazard when we talk about concrete and working with concrete is that silica dust. And a mask doesn't work unless it is like a scuba type thing where you're taking in all new fresh air, okay? So if you do this for a living, like I said, it doesn't show up for 10 years. And then you're pretty much counting your days after that. And one other thing I wanted to go over is when you're working on masonry walls, when you brick walls and you're building brick walls or CMU walls, there's a standard that there needs to be a limited access zone around that wall. So if I'm putting up a wall, the access zone has to extend from the wall, the height of the wall plus 4 feet. So if you're building a 8-foot wall, your access zone, you have to extend out or close out that 8 plus 4, 12 feet outward from the wall, where you limit access where people can't walk. Okay, so that's another really important standard when it comes to our concrete masonry, just in terms of avoiding violations, right? We want to avoid violations. And you can't avoid a violation if you're sitting there in a cloud of silica dust and you're cutting the concrete. you're pretty much done. Okay, so you want to be able to avoid violations, limited work zones, proper PPE, all that good stuff. And two, this is just one part of your, what would be your OSHA 10, OSHA 30 training. So just wanted to give you a little heads up on, you know, what you would study, and, you know, really what's the most important. They have standards for slab lift operations, you know, limited access zones, type of equipment, the standards for the equipment. So again, you can get all of this directly from the OSHA website, even if you are not getting your certification, just for so you'll know. Or please do, or you should. Your employer should make sure you're certified if you're doing this for a living, and it's a requirement that you have a training program. So if you have any questions in regards to this or any other issue, please let me know at education@sfjohnsonconsulting.com. And also, please let me know what you think, and subscribe and all that good stuff. And I will see you at the next safety video. Hello everyone, this is Stacy with SF Johnson Consulting and Construction Services, and in this short video we are going to look at the new site work for the middle project that's not the biggest one, not the smallest one, but kind of big. And so the site work, here's the building envelope, and what do we have here? We have new concrete pavement, some parking stripes, an apron for the ADA ramp, and an equipment pad, and some numbers that we're going to put on there. So let's get rid of and a new bollard and an ADA sign. So we have quite a few. So let's get everything off and then build it back up. Okay, so the site work is all the work that happens outside the building. For our case, it is a renovation. So basically they're adding new parking lot spaces to store, I guess, the cars once they're finished with the collision work. And then a new area here, new concrete. Then we have a new equipment pad, 40 inch by 40 inch here, some ADA signs, and our pricing will include the footer. So anytime you have signs, you always got to make sure you include the footing for the sign. And we have some symbols. And when it came to these, we just priced it for the 3 that were there. I think the first time we did it, we overdid it, assuming it was a mistake that all the other spaces weren't marked off. But I think the only 3 we have, and then the ADA symbols, and then here's the apron, and then we have more stripes. So this one was really pretty easy. So we had the curbs. So let's do the curbs. So we always distinguish between the curved ones, okay, and straight ones. Okay, so there's the straight ones, because it's a little more in the formwork when they're curved, and so, you know, you get as close as you can. So we have that, and here's our signs, and our apron, no, our symbols, the new bollard. Where is it? Where did it go? The new bollard. Oh, it's over here. Where is it? Hold on. Slide it up. We have 3 new ones. Okay, that's right. With the, and here's some more curve. So we said that was the difference between the curved one. That was a straight, and you know, we break it down right here. Okay, and so these numbers are the radius of the curve. Okay, that's why they have those there. So when the machine is laying the concrete or when they do the angles, they'll know that the radius of the angle is that number. Alright, so this wasn't too difficult. I'll just light up everything again. And so, again, the stripes, you can price them per linear foot if you want to go through and just do all this like we do, which is more accurate. Or you can price it by the area, and then the symbols are separate. And what we normally do is do one of the stripes, because they're all the same, about 19 feet long, something like that. I think we had 20. And then we had to put them all in. So let me just fill in all the colors, and that's all of our new, oh, let me show you how the difference between the new concrete and the existing concrete. Okay, so you really have to, look very closely, because the darker color is the new. So it basically stops right here. And you can see even the little representation for concrete. These are more black than gray. So this would be your line. That's where we got our line for there. And then here, they just straight out give you the line. Okay, so always be aware when you have, see how the difference in the curve right here is gray and it's black. Okay, so you'll know where to start and where to stop. That's real important, especially when you have a renovation. So everything new is going to be more black. Okay, so if you have any questions on this one, please email me. Give me your thoughts. Please subscribe, and I will see you at the next video.
Hello everyone, this is Stacy with SF Johnson Consulting and Construction Services, and in this video we are going to discuss the basics of structural estimating. And what we mean by structural estimating, basically we're going to be looking at all the things that we look at in the structural set. So we will be looking at the foundation, and for concrete, that is the only concrete scope of work that's in the structural set, although that may not be the only concrete, of course, in the project, especially if it's from the ground up, right? You'll have asphalt concrete in the site plan, but if you're the concrete person, you're going to do that concrete. You're also going to do the concrete on the site plan. But this is specifically for the structural set, and so the only concrete in the structural set is the foundation, any column pads, and anything associated with that. And so for this project, we had, this is our crash facility where we had to, in the structural set, install or adapt some existing concrete to, we had to like make a pit. And so what we had to do always when you have existing concrete, you're going to have to cut the concrete first. So there's a cost for the cutting, and then there's a cost for removing the concrete. So never forget that. And then this was one of the pits, the paint pit that we had to create. And what this is all of the walls were 8-inch concrete walls, and it was also recessed down with an 8-inch concrete foundation. And so what is this? This is a call out, right? Where they're going to send us somewhere else to look at the construction of this. But this we were able to do from this page. And what do we also have here? Well, this automatically tells us that we have some kind of columns that are going to be installed in, looks like the existing foundation. Yeah, in the existing foundation. And so what we need to do is determine what the height, the width, and the depth of the column pads. And so in any structural set, they're going to give you all of the structural components as they apply. So the column pad or the pad footing, it's 2 by 6, so square, 2 by 6 square, and the depth is 1 foot 4 inches. And so if you have a good cost book, it will give you the cost for a column pad that's similar to that, you may have to add the additional reinforcement, but you'll be able to do it. Okay, and here it's telling us about lintels. So a lintel is basically just a steel header. So headers are typically wood, right? Well, lintels are headers, but they're made out of steel. So anytime you see lintel, just know it's the same as a header, but it's made out of steel. And the bearing plates for the column pads that connect the column to the bolt. And then we have some beams for which we'll be able to, it'll be an I or W or C beam, which is something by something, and then we'll look on the plan and that'll tell us what that is. And it's telling us we have the beam, then we have to infill it with grout once we place it. And this is an existing building where we have to do some additional foundation work. Okay, and this is so when we have structural, right, that is our foundation. That's any new roof framing or anything of that nature. So here we have some new beams that are going to be placed along the existing metal joists. Okay, so they're W beams, W12 by 19. So what's that mean? That means that they are able to hold 19 pounds per linear foot, and so we'll measure how many linear feet altogether, and we'll multiply that by 19, and that tells us how many pounds, because when we do the beams, C beams, W beams, I beams, it's fabricated metals, and those are priced by the pound. And so we need to be able to determine, just for these types of beams, how many pounds we are talking about. And again, we take the second digit, multiply by the length, that gives us how many pounds. And then we also had some C beams, right? So we have different ones. So what is this? This one says that the strength of this C beam will hold 12.7 pounds per linear foot. And so we do the same thing. However many linear feet times 20.7, that gives us how many pounds, and then we're able to put that on our estimate. Okay, so when it comes to the column pads, you have to have a good indication from your cost book, how to price it. There's no way to guess that. So you really have to have the tools you need when it comes to this kind of stuff. And when it comes to your beams too, you have to have a good cost book to tell you, because based on the weight, it goes from 0 to 20 pounds. It's a certain amount of cost per pound. Then we go from 20 to 50 pounds. It's a certain cost. And then from 50 to 75 pounds, and I'm talking weight per linear foot, that second digit. And anything over 100 pounds per linear foot, that's like a specialty thing. There's no cost book that's going to have that information. Okay, so that's very important. But what I'm going to do is I'm going to put this on hold, because I don't think I have the structural estimate up. So I'm going to place you on hold for a second while I give you kind of a visual on what your estimate should look like for a structural, for the structural portion. So be right back. Okay, so now we're looking at the estimate for actually that project. And so we have the column pads, and there were 6 of those. And from, all of this gives us, we get all this information from the cost book. So the cost for the formwork, the steel, and for the concrete, and it's per column pad. And here is our C1. So that was what that was. Our columns are 3.5 by 3.5 by 1/4. Each one was 10 feet. So we estimated, from the section view, it's 10 feet high, and we have 7 of them. And so those we are able to get, hollow structural steel, you're able to get a cost per linear foot. So we got that for that. The base plate and the anchor bolts, and then now the fabricated metals, right? We had W8 by 18 or 19 linear feet. So we had 342 pounds, and then there was a bottom plate anchored to it. So that was another cost for that one. And I believe we had all three. C-beam, C12, we had 228 pounds of that, and then the bolts, and then we also had a 12 by 19, and there was 522, and we had 29 linear feet of that, and so 522 pounds, and then all of the other things, all of the supports, right? Bearing plates and supports, and then the new foundation. So let's go back to the plan. The new foundation, and let's look at some section views. It's important that you're able to go to the section views. This is the pit that we talked about, right? The paint booth, where now we have the section view, right? Section view, you got to really be able to determine and take your time and look at stuff like this, because the section view is as if we took this is a knife, right? We cut straight down, and then we opened it up, and now we're standing in the middle of that, and this is what we see. Okay, so it gives us a more detailed view, so we can determine all of our rebar totals. We have a number 5 every 8 inches both ways. Okay, so when you have your number 5, number 4, whatever, every 12 inches, 8 inches, it's important to do the conversion. How many linear feet do you have, right? Change those linear feet to inches, divide by the placement. That tells you how many positions you have to lay the rebar, and then however long it is. And then if it's a square, you can just multiply by 2. I think in most cases, every time I've done it twice, whether it's a square or it's a rectangle, it's always been the same amount of rebar, whether I did it this way and did the equation or this way, and it's always twice. So try it for yourself. I don't know, but just do it both ways so you're not short. But when it says each way, you have to do it each way, right? This way, and then that's what these are showing, and then those dots are showing it's moving away from us. Okay, so it's really important that you're able to read section views very well. And it's not an easy thing, so just, take your time. And there is a video on the 4 views in the that's probably one of the very first videos I uploaded to try to give you a good understanding of the 4 views: plan view, section view, detail view, elevation view, and how to float from one to the other so you can have a clear understanding of the construction. The takeouts and the call outs and all that stuff. Okay, so what we have here is basically this pit, right? These are the walls. They're 8 inches wide, and that's the reinforcement. So what it has this ledger, pretty much the perimeter of the whole thing. Pretty much the perimeter, that's what this is showing. Okay, so structural is very detailed oriented, and you really have to just take your time and probably make a few mistakes before you get it all right. But the main thing is, if you want to really do accurate rebar totals, just take it one piece by one piece with 6 inch 3 by 8 hollow steel at the 18, angle set with at the 18th, entire pit, okay, with at the 18th. This is, I gotta look into the hollow steel with, okay, every 18 inches, entire pit perimeter. Okay, and then the vertical right? And then the horizontal. So the vertical is the up and down conduit. So you have to say, well, it's that many linear feet, and it goes the whole perimeter too. So you know, that many linear feet at the 8 inches. So what's the perimeter? What's the perimeter, right? However many linear feet, change it into inches, divide by 8. Then you know you have that many placements times the length at each placement, you know? So, really easy to do. Okay, and this is our awning, okay, where we had to, now this is an existing wall, right? So what do we have to do? A couple things, costs a couple things. Had to drill the holes in here. So there's 4, right? We have a section view, so we have 2 on one side, 2 on the other side of these plates. So we have what? 1, 2, 3, 4 plates, 4, 8 screws, and then we have to drill through the beam. Okay, so all of that is actually on our estimate. Foundation, paint booth walls, paint booth foundation, and then we have some demo of that, some rods. And the demo shouldn't be on here unless they just caught us by surprise and it wasn't even on the demo plan, which those rods weren't. Okay, so awning support, the base plate, the anchor bolts, drilling the holes. See how much drilling holes is through steel? It's very expensive. But it's only 2 feet, so it wasn't too bad. Okay, so you want to make sure you include everything that's in the set. Structural could be one of the hardest ones, but what are you doing? Structural, you know you're doing concrete foundations. My grandkids gave me a cold for Thanksgiving. Concrete foundations, column pads, columns, beams, could be roof components, right? Because if you have a single-story building, the structural is the foundation, the exterior walls, beams, columns, and the roof. So if we're putting new holes in the roof, we have to make sure we secure those holes in the roof. Okay, so, and this is our new wall elevation. This is our 18.75. Basically, we're making an opening for a new overhead door. So we had to have that beam. So that's the elevation view of that. We have the plan view, so we only see it from here, right? So we had to include these on both sides and a new beam and the connectors. And then in the demo portion, if you saw the demo, we already accounted for putting the hole in the exterior wall. Okay, so to produce a good structural, you know, let's see. We had to, let's see, the drill in the holes. I think that was for the pit. Let's go back. For this, this is the A over 2, AS201. AS201, 201. Where is it? Right here. A. Yeah, so that was our trench drains. So we had to put some rebar in there. So, and I believe we had to drill some holes. Yeah, in the foundation. Oh, in the foundation we had to drill holes. So that's where that came from. Okay, so you have to really be, and that's our column pad and how we're connecting the column. The anchor bolts for, you know, all of those things have to be reflected piece by piece. That's why a good cost book is valuable, because it's going to take you forever to get this done, right? And I mean, I was lost. I'm like, how you price a beam? But yeah, with enough research, it showed me, yeah, you got to figure out how many pounds it is. Okay, so just go through your set. Everything on your set should be reflected on your estimate. So the person you're doing the estimate for, right, the estimator has to be able to see the project when it's finished and be able to look at all of this mess that they give you, okay, and be able to break it down. So if you have any questions, roof framing. Oh, okay, we didn't go over this. Okay, so that's the all of those the openings. See, they built. They only show you one in the section view, but they actually had 3 new garage door openings. Okay, so oh no, here it is. And they had 1, 2, 3, 4 new garage door openings. This was something else, but that's all the fabricated metals. So that's why I said we had, what, 29 feet. How many of lintel one? Let me see, 74 feet. Yeah, that was that 522 pounds or whatever. Okay, so we had to shore up all of the secure all of the new exhaust fans in the roof, because that's weight, right? So we have to be able to make sure it doesn't fall through the roof. And so that's all the exhaust fan secure bracing that we have to account for. C301, let's look at that real quick. C301. C. Okay, so yeah, 10-inch, 12 gauge on each side of that. Okay, so we can go back to that. You see, basically that's going on each side, and you have to connect it. Okay, and then D, you connect it like this. Okay, so you got to be able to make sure you know how to get from what they're trying to tell you to the next thing and get it on your estimate. And make sure you get it all together. Somewhere on here. Fan supports, 240 feet. And then the Simpson tie L70. So much fun. But yeah, structural is no joke. Okay, that and electrical probably, and excavation, especially if you have bad plans, it can be 3 of your most difficult of estimates to put together. Okay, so this is the basics of structural estimating, right? Just your structural set, and only the concrete in the S plans. If you have concrete in the C plans, civil set, it's not on here. You don't put that on here. Everything is separated just this way because it's all its own thing, right? So, you know, even if there is interior building concrete, it won't be on here and it won't be on the civil set. It'll be on the estimate associated with the architectural set. Okay, so we'll come up with a video in detail to show you like how you separate estimates, because a lot of people just throw everything on there, and those are the estimates that get thrown away, right? Because it shows that the person doing it, they don't know what should be on their estimate. So unless somebody specifically says, like for the electrician, put the trenching on that, well, that's different, because the electrician's job is to be an electrician. And the structural set it's understood that these things are on it, so all of these will be on a structural estimate. Concrete, the foundation, any of the structural components, all of the beams and columns and stuff. It's understood those will be all on the same estimate. Okay, so if you have any questions, please let me know, and please give me your comments, and thank you for your very nice comments and your likes and all that good stuff. Please continue to like. Let me know if there's something in particular you need help in and you want to know, because there's very few things about this mess that I don't know, and I like to share. So thanks a lot. Email me at education@sfjohnsonconsulting.com. I hope you had a wonderful Thanksgiving, and look for the next video. Talk to you soon.
Hello, everyone, and thank you for joining me. My name is Stacy Johnson, the owner and operator of SF Johnson Consulting and Construction Services. And then in this snippet, this is part of a multi-series class where we go through a set of construction documents, the architectural set, structural set, the civil set, and all the MEPs. And we go over them sheet by sheet for what's important, what you should be aware of, and basically what we're looking at. And in this snippet, we're going to be talking about the MEP site plan. Okay, and this is, we call it the MEP site plan because it is not a full site plan. It is a site plan that gives you kind of like a salad bowl of what is in a full set, a full civil set. The site plan is just one of the sets that is comprised within the civil set. And so this is like I said, it's a compilation of all of the trades just on one sheet. It's not used for detail, of course, because we need all of the individual sheets that would be comprised within a civil set. So this set or this sheet gives you contour lines, right, which would be found on the excavation page of a civil set. It's going to show us the parking lot striping and curbs and gutters, which would be found on the concrete asphalt plan in a civil set. Okay, so this is just one sheet that gives us kind of a little bit of everything that we would find in a full civil set. And then we're going to just go over each thing individually and give you an idea of what we're looking at. And so the first thing we'll start off with are these lines that look like mountains. And those are called contour lines. And those are the lines that kind of that do represent the GPS coordinates if we were to go out there and do a survey. Well, that's what they mark each of the contour lines, and it basically represents the height and the depths of the land or the dirt at various locations. And so what we're looking at on this MEP site plan are just a few of the contour lines. And what I want to go over is just how they represent, because the contour lines, again, represent what we would find on the excavation plan. And on the excavation plan, what is that? That's telling us how much dirt we need to either cut or fill in order to properly level the land to build, in this case, our restaurant. So the way they represent the contour lines of what they found on the survey, when they did the survey, the number that represents the number that, or basically before number, would be the number they represent here in the parentheses. Now, 588, we don't care what that means, but, we just want to make sure you know that before and after, right? Excavation, what we found before, and then what we need to either cut or fill to build our property or build or level it out for our foundations, our parking lots, and all of that good stuff. So the way they represent before is in a parentheses, and the way they show what we want as a result of the excavation is represented in a square. So this is for this particular architect and what they use to represent before and after, but it'll similarly be represented in some kind of way. Or we can see that before is represented by the broken lines, the broken lines, and where after is represented by the solid line. Okay, so in this MEP site plan, they're representing the heights and the depths of the dirt at various locations. Before is the broken line with the parentheses. What they want after they've done the excavation is represented by the square and the solid lines. Okay, so that's one thing for our MEP site plan. Another thing is underground utilities and how they represent underground utilities. Well, underground utilities are represented by, if they're existing, they're more of a gray color. And so we see here UT, so that tells me that's an underground telephone. They have G, it should be underground gas, but there's a lot of inconsistencies in this set. And then we see underground EUE, underground electrical. And so how do they represent utilities that are underground and that are existing? They represent those by a gray broken line. Usually new construction is always represented by a black line, meaning this is the new construction as opposed to the existing. So if I had to look at this and say in words, we see that the SD, which stands for the storm drain, is black, where all of these other ones are more gray. So that would tell me maybe we have a new storm drain coming through the new construction that is junctioned or broken off from the existing storm drain, something like that. Okay, so underground utilities are represented by gray lines if they are existing and broken gray lines. So you just have to kind of look what's the existing, what's the new, and kind of determine it that way. And so if we look all around this set, we'll see that we have, now this is a black S, so even though the line is gray, the line is probably telling me it's underground, yes, but the black is telling me it's a new storm drain or sewer drain that's coming into the building right here. So underground utilities, again, if they're already existing, broken lines, gray color if they're new, more solid lines, or maybe a broken line, but a darker representation of what it is. And so here we see that there is and we know that these are new because, again, this is new construction. So we have 8-inch water, then we have the underground electrical, underground telephone, underground something else right there, 4-inch gas. Okay, so broken lines tells me it's all underground utilities, and they're all coming into the new construction. Okay, that's another thing for our site plan that's typical of a site plan. One thing we always have to make sure we do correctly is to make sure if we're using a digitized software that the set of construction documents or the plans are to scale. Okay, so what does that mean? That means if we were to print a full legitimate set of construction documents and we used a regular ruler, for every inch that we measured with that ruler, it would really mean that we are measuring 20 actual feet in real life. Okay, so you always want to make sure if you're using a digitized software that you confirm that the scale of the set that you receive is correct. And so here on our digitized software, we just tell it that for every 1 inch, it's 20 feet. We set the scale, and then we take a measurement somewhere on that set to confirm that between 20 and 40 should be 20 feet. So we know that this set is to scale, so when we do our measurements, we know that our measurements are correct. All right, on any set of construction documents, you're always going to have keynotes. And how the architect represents the keynotes is really based by architect to architect. But it's very important that you look at each of the keynotes individually, match them up with the keynotes that are on the page, so you can make sure that you covered everything on your set in terms of your full scope of work. Every set's going to have keynotes. It's important that you find a methodical way to make sure that you have covered every one of the keynotes and what you need to do. Okay, so let's go back. This is a very generic MEP site plan. It shows us some of the things that would be on the site plan all on one sheet. Remember that the civil set, the civil set is the set of construction documents that show us everything, all new construction outside. Okay, so when you walk outside any door of the office or home, what you're looking at is everything that you would find on a civil set if it was to be built new. What do we see? We see asphalt, concrete. That would be a separate plan. We see, we see the results of underground utilities, right? We would see fire hydrants or something like that, or manhole covers or something like that. Well, that would mean that there are underground utilities under our feet. We would see trees, right? That's part of the landscape plan. That would be a part of our civil set. We see, again, in this Popeyes, we would see parking lot striping, handicap symbols for parking lots. We would see all of that. Again, all part of that same asphalt concrete striping plan that we would find in a full civil set. What they did here was give a little bit of underground utilities, a little bit of excavation, some parking lot striping, asphalt, concrete, all of that on one sheet. Okay, so this is kind of like a salad sheet of what would be comprised individually in a civil set. Let's see what else. Scales, always important. Make sure you are always on the right scale when you're doing measurements, or else your measurements are not valid. And the only reason why we had to have a set of construction documents is that we can look at them, we can scale them, we can make measurements, and from those measurements, we can apply value to this is how many linear feet of new wall, this is how many cubic yards of concrete, and we can give a cost to how much it is to build this thing. Okay, so again, an overview. Underground utilities are represented by broken lines. If they are new utilities, you'll see black. If they are existing, you see gray. The contour lines are represented by the heights and depths of the dirt. Those are the contour lines when we go out there and do the survey. And it's showing us for the excavation plan what the height and depth of dirt is at certain locations, and then what we need to do to get it to the height and depth that we need it to be at, so we can build our storm drain basins and build our new foundations. Okay, so that's what we're seeing here. Make sure you read all the keynotes regardless of the sheet. And one thing, and we'll go over individually, we are looking at this sheet from a plan view. And you will look at any of the sheets from one of 4 different views. You'll look at the sheet from a plan view, which is the view from above, and we'll have a separate class detailing each of the 4 views, how we look at it, how we flow from one to the other. But on this sheet in particular, we're looking at anytime you see the plan. See, we always say, send me the set of plans or whatever, but really that's a misnomer, right? Because plan is a particular way that you're looking at the project. It's a perspective of the sheet from which you're looking at the project. The plan view is the view from above. It's as if you're hovering over, you're flying over, and that is the most basic of the views, is the plan view. Okay, so from the plan view, we get a good idea of the site plan. But if we were to, say, build the walls of the Popeyes, the plan view doesn't tell us the height of the walls. It doesn't even tell us the thickness of the walls. So we need other views, other sheets in order to give us more detail. All right, so this is the MEP site plan for our set that we are breaking apart and analyzing. And remember, if you have any questions or concerns, you can always go to our website, www.S as in Sam, F as in Frank, Johnson Consulting.com. Fill out our online office hours. We will make time at your convenience to go over anything with you to make sure you understand. Thank you very much for joining me this time, and please make sure to return. You're awesome. And well, I guess that's it. Have a wonderful rest of your day. Well, I guess that's it. Have a wonderful rest of your day. Well, I guess that's it. Have a wonderful rest of your day. Well, I guess that's it. Have a wonderful rest of your day. Well, I guess that's it. Have a wonderful rest of your day. Well, I guess that's it. Have a wonderful rest of your day. Well, I guess that's it. Have a wonderful rest of your day. Well, I guess that's it. Have a wonderful rest of your day. Well, I guess that's it. Have a wonderful rest of your day. Well, I guess that's it. Have a wonderful rest of your day. Well, I guess that's it. Have a wonderful rest of your day. Well, I guess that's it. Have a wonderful rest of your day. Well, I guess that's it. Have a wonderful rest of your day. Well, I guess that's it. Have a wonderful rest of your day. Well, I guess that's it. Have a wonderful rest of your day. Well, I guess that's it. Have a wonderful rest of your day. Well, I guess that's it. Have a wonderful rest of your day. that it gives is configuration is this, but and so this is a small shear shear that it gives is configuration is this, but it gives us the shear, and so this is a small shear traditional framing that you put over structural framing to give the wall traditional framing that you put resistance to shear. Structural framing, in this case, is showing give the wall lift from snow resistance to shear. Structural framing or earthquakes, in this case, California, and so you give the wall some additional structural earthquakes components to make them stronger, basically. And so, what is a shear wall? It's basically just plywood on the exterior portion. Well, because it's right, it's at the for the rough framing. We're not talking about drywall. We're not talking about framing that's on the architectural set, right? So it's just so we have the rough framing, and so we're going to connect the shear walls at the frame of the structural walls, and it's nothing but plywood, okay, 1/2-inch plywood, and it tells you how to place it, basically between the posts, right, and how to nail it. Okay, so what is this? 10D at 6-inch off center. So shear wall 1, the hold downs are these. It looks like all the hold downs, no, they're not the same. Hold downs are as listed. Then the anchor bolts are as listed. Okay, so 10D is the size of nail. 6-inch OC is, so we're putting a 10D nail every 6 inches on center. And the hold downs are as such. So we're going to have to look at, if we really want to get a good look at this, we have to look at the structural sections, right, in order to see exactly how everything is placed. And so the anchor bolts, this is the size. And for shear wall 1, they're placed every 2 feet, and we work our way down to every 32 inches. So basically it shows us here. So wall B, and now we have these are wall B, and so now this is just the shear wall, and we have to go to the other page in order to find out, well, what is B? What's the configuration of B? What are we talking about when we're talking about B and A? And that's on the other sheet, okay? So this basically just shows us the shear wall configuration, and we have to use this in conjunction with this. And so what's A, what's B, what's 1, what's 2? Here's the actual roof framing plan, and then the foundation plan, which in the foundation plan, they also kind of mix up your, they put everything that's for your framing here. So, it's kind of like, for my liking, I don't want the king studs on the foundation plan, right? Because the foundation plan is concrete, right? For me, it's we have a single story building, right? So it's kind of like, okay, do I put it here? Do I put it there? But because it is framing, we should put it on the roof plan. But every architect is going to do something different. So what is my job? Let's go back to what my job is. As the framer, structural framer, I have to be able to do the takeoff for this thing. That's really so I have to do the takeoff for the shear walls, and I have to do the takeoff for all of the king studs. How many? What's the height? I have to do the takeoff for the headers. How many linear feet of each type of header? What is B? So that's why we have to use this sheet in conjunction with the sheet that we already saw. What is B? Well, B is the header. And what's a header? Header is, let's go back. When we put a, see, that's why I don't like it. It has the header here and the header here. But no, it doesn't have the header here because it doesn't mark it. It only has the king studs here, but the header's over here. Okay, so what's a header? That's header B. Anytime we put a hole in a structural wall, and a hole is a door or window, you have to give the strength back to the hole so we can place the roof joists and they can be secure. So we put headers in doors and windows. So it's a combination of 3 or 4 2x4s, 2x8s, 2x6 with the plywood to fit the gap. So let's go back to see what, let's go forward to see what header B is. See, I kind of don't like when you got to go back and forth. Everything that you need on one set should be on the set. There's no reason why they couldn't repeat this on the sheet that we actually need it on. So it's like, oh, if you're new to this, I'm like, okay, well, what is this? And yeah, when I was new to this, it drive you crazy. It's like, well, wait, where's A, B? Oh, it's on a different sheet. It should always be on the same sheet that it's referenced. But in this case, it's not. So we have to keep going back and forth. And so what I would probably do is just print this out. So when I go to the next one, I'm like, okay, what's header B? Okay, I already know because I printed this out. Okay, this is a pain, but it is what it is. You know what I mean? You work with what you got. All right. So what's header A? It's 3 2x10s. We know the by is wood, right? X wood with 2 1/2-inch plywood spacers to fill the gap, basically. B is 3 2x8s with 2 1/2-inch plywood spacers, and header C is 3 2x6s with 2 1/2-inch plywood spacers. So when you're doing the takeoff, you're basically saying 2x10 times 3. So if I measure 25 feet, I'm really going to say 75 feet of a 2x10. That's how we do that. And 1/2-inch plywood spacer, 1/2-inch thick by 1/2-inch by the width by 2. Half by, because you need a height for it to be very technical on your takeoff, right? You need a height and a width for that plywood spacer. So you just got to sit there and, do the math. It's easy. Okay, so some stuff is over here now. What's B? Shear wall schedule. See, but this B is nowhere on this, right? Because this B, well, where's 1 and 2? See, 1 and 2 is nowhere on here, so I hate this set of plans. So what we're going to do is we have to measure 1 and 2. That's here. That's all of our 1. Because your shear wall isn't continuous. It's only where it's noted. Okay, so that's confusing too. That's why I decided to get a very confusing set of plans. Okay, because here's the shear wall, here's the symbol. So when we see octagon 1, 2, 3, 4, we need to look for octagon 1, 2, 3, 4. Okay, so that's here. Octagon 3, and it is only where you see these symbols. So it's not everywhere. Okay, so that's a pain. So we'll do those measurements. Okay, and remember this is for framing only. So what do we need to measure? The length of the shear walls, how many linear feet. Then we're going to go to the section views. And see, these section views don't help. because they don't go all the way to, they don't tell you the height. Okay, it shows you, see, it breaks it off right here because this is the header. Man, this sucks because your shear wall is going to go the full length of the wall. So this right here is the header. Where's the header? Header's at the top of the window or the door. And so you have to figure out what's the top of the window, and it tells you right here. Reference the architectural set. So you see how difficult it can be to navigate when you have a crappy set of plans. And what's our job for framers only? Measure how many linear feet of shear wall, and you got to figure out what the height is, because you need square feet for shear wall. You got to determine how many linear feet of the header. See, this is the one with the 3 or 2 or whatever plywood header, and then it tells us to reference the plan. So this is from section view 2 on there. Okay. And so, yeah, it could be a little difficult, but this is just the basic overview of the plans, right? We got to get a basic overview. We're the framer. Basic overview is kind of crappy because framer, we need our rough framing. 3 king studs and 1 jack stud at rough opening typical. So whatever I see here, so that's why they don't have to mark this one, because they've already marked it here. They gave me the details. Typical means this picture right here, whatever I see that represents this picture right here, which is like what, this one, that one, that one, that one. Oh, see, no. Okay, so corners, typical. So the corners, we know we have 5 at the corners because it told us. Typical is the key. And then at the openings, we have this configuration, typical. And this is an opening. And I just have to know it's an opening because I should know it's an opening. This represents an opening. Okay, so a little confusing, but not really. So again, what am I doing? Measuring how many linear feet of shear wall. This represents the shear wall, octagon 1. It's only this many linear feet. But at the corners, I have this configuration and that. So I have to measure what? 5, 10 king studs times 15, 20, 12. I don't know how many linear feet, because it's going to go from the foundation, right, to the roof joist. So I have to get on another set of plans if this section view doesn't show me, which it doesn't. Okay, it only shows me from the header all the way up. Now, it's very confusing because I have the shear walls. Let's go back to the shear walls. Well, we know that the wall is, let's go back to the floor plan, right? Floor section view. Here we go. Okay, so now we're in the architectural set. It's not telling us anything about these, right? That's our header that we're looking at on our structural set. It's not giving us info about that. But see, we have to go here to determine the shear wall height, because there's nothing that tells me, and shear walls are usually that's the whole point, to attach it to the foundation, to the roof joist, and then above. And so that's the only detail, and I would just, when you do the estimate, you just got to be very detailed on how many linear feet, how many square feet of shear wall are you allowing for the plan. You got to be very detailed, especially when the plans aren't detailed. You got to write out a lot of stuff because you want whoever's reviewing your estimate to know that you've done the best based on these plans that you're given, right? To get the correct numbers. And so over time, we'll have the takeoff completed, the visual completed so you can see it. And you'll also have the pricing from a cost book. And then with the cost book, we'll be able to tell how long something takes. That's the beauty of this whole thing, because you want to be able to price it correctly. If you know how long it takes, you'll be able to price it correctly. You'll be able to know how long each job you do is going to take. And so you'll be able to schedule work for the whole year, right? If you have 5 jobs and you know exactly how long they're going to take, you know if you need more work for the year. You can't just work, oh, I think this is going to take 2 or 3 weeks. No, there is a way to determine, once you have your full takeoff completed, how long this job is going to take to do every portion of the scope of work. So let's go back, because this is for the framer. Okay, so the framer, what I'm going to do is shear walls. I got to measure how many linear feet of the king studs, right, from foundation to roof joist. I have to determine how many linear feet of the headers over here. How many linear feet of header I have. And now, how do they represent the roof joists? Structural framing and always represent it with the arrows, the sweeping arrows. So I know the full roof joist configuration. And if it was something different than 2x12s, it would have another sweeping arrow and give me whatever that is. And so the full roof joist, structural roof framing is structural framing. We know that it's all 2x4 at the 16th on center. And then we have to look at, because we have a hole in the roof, right, to hold the condensing unit and the air handling unit and whatever unit. So these structural roof joists have to have their own additional structure to keep the air handling unit from falling through the roof, right? Okay, and so for the structural framing, there's a few totals that we'll come up with. All of the headers, all of the shear wall totals, all of the roof joists. Now, you can do the roof joists because you actually buy roof joists based on not square feet, but how individually, right? In all of these individually, and it appears that the majority of them are 17 feet 11 inches. So that's good for this one, because if the building was built another way, then we'd have to tailor our roof joists to fit that length, right? Because these are made specifically for the building. Okay, so again, for framing only, what do we have to do? The structural framing, not architectural plan framing. Structural framing, architectural plan framing, two different things. So this is S plan as in Stacy. So what do we look for again? Shear walls and posts and columns. Basically, these are acting as posts. Pretty much these are acting as posts, because it's single story. You don't need anything other than that, but that's a lot. These are posts or columns, whatever you want to call it. Call it either one. They have the same purpose. So, again, I repeat myself. Structural framing, what are we measuring? Shear walls. And that's all is represented by this configuration. And on the other sheet, it told us what octagon 1, 2, 3, 4 plus the anchor bolts. So really, we can determine first if we know how many linear feet. And it should tell us more about the nails. It's like, okay, 10D nails at the 6 inch. Is that at the framing? See, we got to look more in detail on the nailing because it's just, yeah, every 6 inches, but at the corners on in each direction. So that's something else you got to look for. Okay. And you can figure out how many anchor bolts you need. If you know how many linear feet, you're placing them every 2 feet. So you figure out how many anchor bolts you need, the hold downs. You can really determine how many nails you needed if you wanted to. Okay, so shear walls. And then we say, well, how many linear feet of shear wall, octagon, 1, 2, 3, figure that out. Then all of the corner king studs, figure that out. All of the headers, how many linear feet of whatever configuration it says it is. So, right? No, headers. So remember, it's not just one stretch of 2x10. If I have 100 feet, now I've got to get 300 feet each cut that size, right? Because within each opening, I have to put 3 plus 2 1-inch half plywood spacers. So that's what the structural framer does. Got to figure out all those totals. We'll have all of that done shortly in a video reviewing all of that, and then we'll have video 2, which is the pricing, and then video 3, which is formatting an Excel spreadsheet so it can look nice and pretty. And so if you have any questions related to any of this, please email me at education@sfjohnsonconsulting.com. Tell me what you think. A lot of little details. If the plans aren't really good, you got to go back and forth and back and forth. And you can't make mistakes as an estimator. You got to make sure everything is right. So you have to take your time. So you'll see once we work through this little by little. And again, any questions, please email us. Or otherwise, I will see you at the next class. So we are going to first complete the floor plan because we are going to complete a cleaning estimate for a client. And also we are bidding on this ourselves. So we are always looking for all of the trades, framing, painting, drywall. In this case, concrete, because this is from the ground up, and we'll also be reviewing the foundation. And so let me make sure we have everything set before we start. And the first thing we always want to look at is the scale and make sure we have the scale correct. And so what we're going to do right now, before we do the foundation actually, because this is pretty much easier to do, we're going to look at all of the call-outs, detailed call-outs for how it's going to probably, who knows what it's going to show us, because I don't try to look at it too much in advance before we do the estimates. And so we're going to first... See, we have here, we have wall here, but a lot of the building is a storefront. And so what I'm going to do is I'm going to separate the storefront walls from the main walls. I know that I'm not going to deduct an opening, because if this is the storefront walls, which we will look at the exterior elevations to see how that's built and everything, I'm going to separate these walls, the exterior walls, load-bearing walls, from our storefront window walls, because the wall portion is going to be totally different than if there are no openings or if it's not the storefront. And so we've already, so I'm going to call it storefront. As soon as it catches up, I think it's doing too much. Oh, come on, computer. What are you doing? There we go. Storefront. Storefront walls. Because those, in terms of construction now, it's going to be a lot different than the other walls. And then I am going to go through the door there. Because too, we're going to do this for final cleaning, and the final cleaning is going to really have to clean both sides of the windows. And so that's good for that too. Looks like these are also some kind of window. It's a drive-through most likely. All right, so let's just finish the exterior walls. Am I spelling right? I really don't care half the time if I'm spelling right because I know what I'm doing. All right, so we're going to go through that door. We're going to go through all the doors because in terms of the wall framing, it's waste, and usually if it's less than 16 feet, we go through it anyway. And so we'll go there. So those are our walls. Now, what we're going to do first, let's see how our walls are built. So 4 over A 4.1 is what we're going to look at. Image number 4, page A 401. 401. Image number 1. So that's image number 2. Are we on page 401? Yeah. Okay. So all of the walls are pretty much this height to the roof joist, and this is the exterior. And we'll look at what the keynotes tell us. 2, 5, and 7. 2. Frame wall with that insulation typical, so all the way around. 5. EFIS system typical, and 7. Pre-finished metal coping at, so that's for our roofer. We've got that there. Parapet. So we have exterior walls that are, let's scale that, 1/4. This is very easy because it's a shell, so it's not really much that we need to do. And so the walls to the roof joist, that's what I want to know. Wall to roof, because our framer needs to know how many square feet. 14.9. So we're going to have to say 15. We'll just give it 15 feet for the exterior walls because they are different at different heights because it kind of goes up. So let's just do that one too. I'm going to use a dimension tool for that one. So just to the roof joist. 15 feet. Okay, so, and then the parapet wall is an additional, because we'll need that for 6.5 feet. Okay, so that's pretty easy. That's easy. All right, so going back here, we know that we have exterior walls of 145 feet times our 15 feet, we say. So that's how many square foot of framing, and we will have a professional estimate created from this takeoff. Okay, and so the framer's gonna do that, and let's see. I mean, we need some, let's see. We gotta have some more details as far as the walls. So that's the storefront area, all of that window. And so final cleaning, we know we're gonna clean both sides of that, so that's easy. And then there's some other drive-through window, and so if I'm going to do windows real quick, which I probably will do real quick, let's do the scale 1/4, because we need to tell our windows, our final cleaner, how many square feet of window they're going to be cleaning. So this appears to be window, and if it's not, it's okay, we'll deduct it. And you know what? We're going to go through all of that. Is going to be window. Because we got to clean it off anyway. And this is our exterior elevations. And so, that appears to be window. We got to clean the door anyway. And all of this is times 2. And then we get this little window. Because we got to clean both sides. And so we'll make sure we have 4. Like 2 that's 3 elevations. Make sure we have all the exterior elevations, so we can make sure we have all as many square feet of window. And you know what? We're going to include that whole thing because we have to wipe all that off when we do our final cleaning. Okay, so let's see if we have any other. One more page that has just a. Now that's the building sections, so that's okay. So, okay, and so we have that. We have the framing, roof plan. we're going, oh, parapet cap. So now we're the roofer, and we need to know, we need a couple things for the roofer. First, we gotta scale it, and we have to tell the roofer how many total square feet of, I think it's TPO roofing, because we are going to bid this. So if you would like to bid this with us, we would love to have you join us. Do-do-do-do. And we do all your estimates too. When you work with us, we do all your estimates. And we always win. Why? Because we are the best. And then what we do too. So we have the total square feet. But what we want to also do, remember this is a share. And so we're going to deduct roof openings because, oops, our roofer asked that we always deduct the openings from our square foot total of roofing material. And so we're going to make sure we do this. Isn't this exciting? Isn't it so fun? All right. These people in our country, they need to just do estimates and be happy. Oh, let's go over some more. All right, so the purpose of that is, oh, we're a little off, but that's okay. And so roofer, with the roofer now, so we just finished what the framer needs real quick, right? And hood below, this is a big one. And what we also need is, because we'll have to flash the same openings, we really need to know how many linear feet, but because my tool I did point by point for each of these squares. See how that square is 28 linear feet? That square is, same thing, should be, right? Same 28 linear feet, so I don't have to do the linear feet. I could just do that. 7, I'll round that up to 8 linear feet. 9, 8.5 linear feet. 12 linear feet. 43, so that's the flashing. See how great that is? And then let's see what number 9 is. Solar ready. All right, so I'm just going to do this area just in case they need it for something special. Just in case I'm asked to price a solar panel or solar something. Solar is weird how they price it, so I'm just going to do that just for the heck of it. So I'll know. Just in case they need it. Oh, look. Forgot that. Look at that. Openings. Deduct. So let's go here. Oh, wait. I got to remember I didn't go all the way to the top. So linear is going to be off. Or look. Bam. Yep. Let's start over. I don't know if I did that on the other ones, but you see the point. Okay. Oh, I did that again. Okay, so we know what Stacy should have done. All right, and another thing we need to get. We know we've got roof drains. So we're going to need the roof drain. We're going to need the flashing for the roof drain. Roof drain and overflow drain. And then we're going to need a perimeter for the parapet cap and flashing. Anywhere that window or wall meets roof, we need to consider, we need some flashing. So if I would have done my roof like I did my openings, I would know how many linear feet this is, and I would not have to do this, but I'm doing it anyway. All right, so what we don't know really yet is about our walls. We did the measurements, but we got building sections. Okay, so we're going to go here, right? Because 3 over A 413 is probably going to tell me the makeup of my wall. 3, 4, 13. 3. Yeah, see, here are all of our walls. So for our framer. What are we doing here? Okay, that's the foundation. So we'll do all of that from foundation. Rough carpentry, that's a 6-inch bottom plate, or 2 of them. Well, you can always measure and make sure. That might be a little, oh, that's about the same. Is that the same? We'll look on the foundation, but we know that storefront, height, tube, wood stud walls with that insulation, vapor barrier on inside face of wall, refer to structural for stud spacing. Structural for stud spacing? Okay. EIFS system over waterproofing over exterior sheathing. Alright, so we got that. We have all the measurements to do all of that. And then all of the window, we have to measure maybe the length of the windows for our bottom plates, for our top plates, for our wall, whatever you want to call it. And then this is on our structural, any headers, everything above the window is the structural member, it's the header. Below the window, it's from the framing, kind of rule of thumb, but kind of not. And we know that the insulation is going to go only to the top of the building. We don't need to insulate the parapet wall unless it was a second floor, right? We only insulate where the humans are. Alright, so, and it's interesting right here. Whatever that is, that's a lot of little things. So we could look at, right? Call out 5 over A421. Let's do that, because if when we do the actual takeoff, we need all of this and be able to determine how many linear feet. So how do we go from the takeoff, right? This is just a section view, but when we're at the floor plan, oh my God, I'm so glad. I almost thought I didn't turn the mic off. Thank you. All right, so when we're at the floor plan, right? So we have to measure if we have a detail call out, say for instance like this one. Well, this is referencing because we know where the section view is. We know it's only in reference to this opening in the door. We know that this is only referencing this because it is within the call out. And so if whatever I see at 2 over A413 to do the takeoff, well, I'm going to measure how many linear feet from here to here. Let's say 6.5 feet. And so I'm going to go to 2 over 413. Next one, 2 over 413. So if I go to 2 over, where is it? Right here. And so I know that that was 6.5 feet. That section view was 6.5 feet. And so I know that I need 6.5 feet of this, 6.5 feet or whatever that is, 6.5 feet of this one, this one, this one, this one, and whatever this is. 6.5 feet times the length of that is what I need, because every section view, right, is broken down. And so when we look at the exterior walls are all 4 over A401. So whatever I see at 4 over A401, I mean, pretty much all of the exterior walls are this construction. So I go to 4 over A401. I go to 4 over A401. 401. 4, right? Where is it? It's up here. Okay, I go to 4 over A401, but then again, I'm the framer. This doesn't tell me anything about my framing. So I'm like, oh, okay, here we go. Because I'm the framer, it's got to tell me more specifically about my framing. I can use this like I did before to determine how many linear feet. This doesn't tell me the wall framing, the drywall, the insulation. But if I go to the call out, if I go to 1 over A413, now I get more specifics. 1. Now I know how my wall is built because there's going to be some arrows hopefully pointing to my wall. And I know all my exterior walls are the same. So if my arrow's not pointing here, then my arrow's going to be pointing somewhere else, and I'll know it's the same wall. What's the and it says, oh yeah, look at the structural for the type. All right, so we go to the structural. That's the roof framing. Okay, roof framing is structural because the roof is a structural member. So the roof framing, not the roof finish, is structural. And so we'll look at this. We'll see what this is when we get there. It might be this afternoon's presentation. Girder truss. Let's see what we got. Oh, prefabricated truss by others is this. Now that's what I like. Is when I have a set of plans that show these things. Okay, so it only applies to structural framing. And so when you have these little things, that circle and that arrow, that tells the framer that only within here, only this part is whatever this is. So now we have it again, right? From this all the way to here, and then again to here. It looks like it's continued because it's not giving us any description. Yeah, so it's all the way through. So it goes from here to here, and then it connects here, all the way through here, and then again, just like that end, it tells you a different type of truss. And so what that means is from here to here, where one arrow begins and the other arrow ends, you got to look and find where they're trying to tell you about the trusses. And that would be, maybe they're breaking it up. No, yeah, they're breaking it up. We got arrows. There we do. Okay, so here we go. Let's start again. Because like I said, never look at this until I look at this with you. All right, so from arrow to arrow, we have this type of truss. 1 or 2 ply prefab trusses by others at the 32s. Okay. And then we go from, we have a new arrow, this arrow, to this arrow, and we look for the description. There we go. 1 or 2 ply prefab. Then we got another set of arrows from here to here, and we look for the description. So when it comes to trusses, if they're putting them every 32 inches, then if you want to know how many you need, then you have to go 32 inch. Oh, wait. Feet? No, heck no. What's wrong with me? 32 inch, 1. 32 inch, another one. 32 inch, another one. All the way through. Okay, so if you want to know how many, because you can't, I mean, I guess you can. You could do it just like you do. Oh, you could do it the same way. How many linear feet? Turn it into inches, divide by 32. Either way, the first way is so much more nerdy and special. All right, so we always going to look for our headers, right? So this is a metal header, H hollow structural steel, and the dimensions. Okay, and usually with fabricated metals, the last digit on like W 84 by 115. The 115 tells you how many pounds per linear foot that can hold. And so if you know how many linear feet of that type of truss, then you know you can determine how many pounds, and they're determined price by the pound. So I rarely get those these days. All right, so we were looking here to see what kind of framing we got there. All right, here we go. Trusses, hold down number 2's, wall number 6. Oh, look at that. Tells you how many linear feet. That's nice. All right, so let's see. Our walls are, we already know they're 6-inch walls. And we know that they're wood framing, so it's not really difficult to determine what we got here. All right, so our posts, right, and our columns are hollow structural steel. Then we look at 9 over S200 to see the makeup, and that's prefabricated, I'm sure. No, we got a couple of wood posts. That's nice. Okay, and so we do our framing takeoff for the structural framing. Our posts, what, are 15, 16 foot? So we just assume they're 16-foot posts with all this extra stuff to hold them down, embed them within the concrete. Slab on grade, we'll do that. That's easy. 6-inch concrete foundation wall with number 4s at the 16th vertical and horizontal. That's nice. So number 4 goes this way and that way, so you do it the same way. The number 4s are what, at the 16? Yeah, every 16 inches. So how many linear feet multiplied by inches, right? So you change that into locations, multiple times however many locations, and then the length. That's for the ones that go in that direction. And then you do the same thing for the ones that go in that direction. For the how many linear feet of how many linear feet of number 4. All right. What else? Because our whole purpose is to do this for the final cleaner. So they have to clean, wash down the walls. They're going to have to probably polish the slab on grade, or wipe it down, or buff it, or whatever. So we're going to measure how many square feet for our concrete person too of slab on grade. And we'll look at the foundation section views for the footer, the stem wall, all that stuff. All right, but for now, we're going to say slab on grade. And we know it's 4 inches. So it's the whole kit and caboodle. How old are you? Old enough to know all my construction principles. All right. And see, now I'm going to go all the way to the top, so I'll know my footer minus that piece because I didn't go up in there. I have 211 linear feet all the way around, plus what is this linear feet? How do we read this, boys and girls? From hash mark, there is one, not one, but from here to there, the number in between is an extra 9 feet, 4.5 inches. So that's our foundation. Almost 23, right? 100 square feet. All right, so let's get rid of that real quick. Cut off the light bulb. All right, so if I'm doing, so my final cleaner's got to buff out 2,300 square feet of concrete. And let's go look at some foundation section views. That's our main wall there, structural, external wall there, and we know any walls that are connected to the footer, the concrete footer, is going to be a structural wall. So that is a structural wall if we have framing connected to it and bolted into it. And then we could look at section view 10 over S201 for the configuration of all of that. So you got a lot of section views here and a lot of call outs. So the concrete person knows basically how to form the concrete and more importantly, how to place the reinforcing steel. Okay, so let's look at 7 and 6 over S200. Mm-hmm. S200, 7 and 6. Oh, look at the beautiful stem wall there you got. So per plan, I think our plan told us. I don't know. Per plan. It told us. Okay, so we've got from here. Oh, it's a 6-inch, I think. So this would be a foot stem wall. So I know my stem wall is a foot by 412. Right? So I know how many square feet of concrete. But then concrete is in cubic yards. Right? So how do I do that? Well, I always turn cubic feet into cubic yards by dividing by 27. Remember, with concrete, you have 3 dimensions. You have the length of the wall, which was 411 feet. You have the width of whatever it is, 1 foot, 2, 6 inches, whatever. And then you have the height, which is 6 inches. So that's 3. Multiply those 3 together, then you shall have cubic feet. And then divide that by 27. That gives you cubic yards. So now, if I know my my plate, I got a single bottom plate, stud wall, and sheathing per plan. We've got some shear walls, right? We got it when they talk about that. We've got also the waterproofing, okay, exterior footing. All the different section views for all the different concrete configurations. That's a stem wall at stud wall with 12-inch foundation wall. That's nice. Reinforcement per plan. I don't know what plan they're talking about because this is the plan. So, I don't know. We don't want to spend a lot on our stuff here. We just do that and let the pros figure it out. All right, shear walls. Here we've got our steel. I can't even think. I just said it. Our structural steel headers, post beams, plans. So we don't have a construction defect. Okay, so this is typical base plate. Concrete wall connection, HSS column. Okay, so 2 times with hex nuts, just 2. You don't say per side. Okay. All right, so we don't mess up and the thing don't fall, right? It don't fall. There we go. Isn't that pretty? All right, so you know what you're doing when you can look at your detail views. You got to be able to get down to your detail views and do the math. Okay? Very, very important. Stem wall, or continuous footer, stem wall, and we got the hooks here, and then we also have individuals running the whole perimeter, right? This is a section view, so we cut it, and then we broke it apart, and this is what the interior construction. This is what we use for our detail material quantities. You got to be able to look at the detail views and determine your material quantity. So I've done that for my foundation. I want to do my foundation. See, those are my 2x6s. And then, see, I have different continuous footers. See, so when you do your takeoff, let's just do that. Did we already? Yeah, we did, because we did. See, when you do your continuous footer, you want to make sure you break up your sections because you want to go back and look at each of these because what? The continuous footer is going to be different. The stem wall is going to be different, thicker, smaller, whatever. And then what we got here? Look at that. So we have a 4-inch slab on grade outside the building with Okay. And here too. So that's the additional concrete work. And then okay, so let's look at that. 9 over S201. Okay, so yeah, that's slab on grade. So what do we do in this case? So you have this this is almost like, this is kind of different because it's not like this. It's not as clear when you want to determine how many square foot, when you want to do actual, like how much. So with me, here's real clear. This is about, what, 6 inches. This goes from 6 inches to 12 inches. I'm going with 12 inches. Sorry, I'm just going with 12 inches stem wall because I'd rather have more than not enough, right? So to do the takeoff for this, you have this stem wall, this continuous footer, this stem wall, and then the flat portion slab on grade. And then, yeah, you're going to do dowels to match the slab reinforcement at the 24s. I mean, 24s, that's 2 feet. This thing isn't even 2 feet long, so it's probably at both ends of it. This one right here at the 24. And this is a continuous, right? So it goes all the way through the slab. And this goes these two go all the way through the slab. And so however long the slab is, right? Let's go back. Where were we? I don't know. So yeah, so however long the slab is, that's how long that continuous is, which is this. I like that. So when you can go from, what, plan view to section view, and the section view will take you to detail view. You'll make sure you have a good thing. All right, so we're going to take a break and see what else we got. Remember, this is a shell, so we don't have any. This is all the MP we got. Mechanical plumbing plan. We just have stuff when it's a shell. We only have things that are coming into the building. So even the electrical plan, right? Just coming into the building. No lights, no nothing. Just the panel. Even I don't even see that we have the panel. I don't even see the panel. It's like just put the lights in. There's no panel. Let's see, the junction box, lights, yeah, we just putting everything in. So when there is, unless we have to provide temporary power, of course we will. To make sure this works, because it's just like junction boxes for the drive-through. What's one? Yeah, civil set. Yeah, we were looking at that. Civil set, site demo. Civil set utility plan, so that would be our power coming through. Water. Where's power? Water. Let's just look on the list. We're looking for transformer. I'm not really looking. Now I'm gonna look. Sewer, grease, trash. Existing cap, this, that, and something else. No? Do we have a electrical site plan? Other than, okay, no, so we just, panel A. It's just right there in the middle of nowhere. That's beautiful. Okay. So yeah, we'd have to get more details. So yeah, shell, of course. We just had it floating out in the middle of nowhere, but it's gonna be somewhere. And we have to look on I'm sure it's shown on the utility plan. We'll find it before the lunchtime presentation. See, so shells are nice. And again, let's go back. There's a whole bunch of stuff. This is a shell for a Chipotle. See, it doesn't even say, but yeah. This is a shell for a Chipotle. That's going right there. Next to it, I think that's a hotel. That's coming up later. So, yeah. We got everything the civil set. Yep, 23. Right, that's what in the pickup window. And then And we're going to do site demo this afternoon. We got some site demo. Knock out some trees. And that's always nice. And we're going to stripe the parking lot. Yep, it's going to be beautiful. And we got some concrete, site concrete now, other than the foundation, right? So the site concrete's going to be on the civil set. Grading plan, I'm not messing with a grading plan unless it has the section view of the earth, and it does not. So when they send me that and ask me to do the grading estimate, nope, unless it has properly been section viewed so you can see what the existing elevation is in comparison to the one they want. And that's the only way I can do it. Now, they'll sell you a $1 zillion program that'll take all of this and claim they're doing it, but no, I'm good. Erosion plan, what's that? All of those fences, all that stuff. That's not really fun. But what is fun is the utility plan. So we'll do all of that later this afternoon. But right now, we are going to make sure we have everything for our framer and our final cleaner. Oh, you know what? For our final cleaner, I'm sure they're going to have to, I don't think they'll have to wipe down the exterior. Other than, oh, look, we left out windows. That's why you don't, come on. That's why you don't do the estimate in one day, boys and girls. Because it's not due till Wednesday, I don't think. All right. And so the framer has what they need. And all of this is that parapet wall. I'm assuming that I did get the roofer. Let's see. Fix what the roofer needs. Let's get the roofer valley flashing. That's always fun. And we don't care about spelling. And we want, and then sometimes we have to have this insulation like doubled and tripled over. Because right valleys are lead us to water flows from the valley. Might be some parapet walls. I mean some crickets in here, but it doesn't really say specifically. And that is another opening for our roof latch, roof thingy, so we can get on the roof. And that's where our ladder is on the other side. All right, so the roof is good. And what's 8? Let's see what 8 is. Canopy. Okay, we don't care about that. We're not going to install that. They have a vendor. All right, so we have our floor plan. And let's go to, because we got our walls. Let's see. We got the roofing membrane. So not only do we have it that the 23 square feet, we've got to have the roofing membrane up the parapet wall too. So that's an extra, let's scale that, 3/4 = 1. Sometimes this stuff be off, but we'll try it. So the parapet wall needs to be in it. Oh, we did say it was 8.5 feet, right? Well, no, not the parapet wall, not the, no. Let's see. And if you had questions, you couldn't ask me because I'm not paying attention. But next time we'll make sure we do. Let's see. Dimension. Because we want the additional, and we'll add that too. Because it's got to, they say go up and over, right? And that's the insulation. So it's going on top of the insulation. So we can stop right there. Extra 5 feet. So extra 5 feet times 411. So that's a lot of extra TPO that you don't want to mess up or forget about. All right. I think we got it. I think everything. Insulation, we're going to go up the, let's just do this. Insulation. 14 feet. Say 14.5 feet times 411. Right? That's the perimeter of the building. So we got pretty much everybody's takeoff. Just have to do more in terms of the foundation, or let's go. Where are those shear walls? That was annoying the way that they did this. That was annoying. Let's see. Where's foundation? Where is it at? Okay, no. Another thing. Framer needs to know all of our doors, so we only have 3. And then the storefront. That frame really questionable. The aluminum storefronts, usually the framer doesn't provide anything but the hollow metal one, so that's another question. But if it's only the hollow metal, then it is one that is 3 feet 6 inches high, wide by 7 feet high, easy hollow metal, and only has to install that. And the storefront person most likely would install the storefront. All right, so we're going to take a quick break until 11 a.m. to let it all sink in. We'll be right back.